Hi everyone and welcome to this series. This series is about Windows privilege escalation. In this introductory part I will describe all the different videos and then you can go and watch those that you are interested in. Now the series starts with some introductory content with respect to the Windows shell and the Windows permissions. So here we analyze the most important CMD and Powershell commands that allow you to enumerate a Windows machine, and we also talk about the basic feature with respect to Windows permissions. Then we talk about reverse shells in Windows, so what is a reverse shell and how to obtain it. And this is useful knowledge because in the future video, in the later videos, I show techniques that allow you to obtain a code execution with higher privileges. And one of the first things you want to do once you obtain code execution with higher privilege is to spawn a reverse shell. So the first three are sort of like introductory. Then we go into exploitation with the SeImpersonatePrivilege video in which we analyze how to exploit this privilege. Then we talk about cross-compilation, which is a very useful thing to know because it allows you to write your software in Linux, but the software can also be executed on Windows. So you write it on Linux, you execute it on Windows, and this is very useful if you are used to work with a Linux-based workflow, like myself. Then we start the discussion about Windows services, and we show how to attack them with the weak service permission video, the unquoted service path, and the DLL hijacking. Now, DLL hijacking is a very general technique, however, it is not strictly related to services, it can also be applied to programs and to many different things. Continuing, we showed what is UAC, we talk about UAC and how to bypass it, we talk about the always install elevated configuration, which is dangerous because it allows to elevate privileges, we talk about files that contain sensitive data in the context of Windows, about Windows hashes, so the different types of hashes such as NTLM, Net-NTLM and things of the sort, about store credential and the Windows Vault, about schedule task, which is different from Windows services, about the registry and some path in the registry which, if misconfigured, can represent a significant security risk. Then in the useful tools video, I go through all the tools that we use in the course so far and just analyze them like, okay, this is useful, this is useful. It's just like a list of tools that you might want to use in the context of Windows privilege escalation. Then we talk about AMSI bypass. So what is AMSI and how we can bypass it? This is more advanced content. It's not strictly required for an OSCP certification. However, I wanted to include you to let you know like how these things are done. This is just introductory material on antivirus evasion, AMSI bypass, and things of the sort. And finally, in the last video, we do a review of all the commands that we cover in the course, and I provide a cheat sheet with such command, with the list of commands subdivided by the different categories, and also a methodology that you can use to approach Windows privilege escalation. So once again, with all my courses, I hope this is going to be useful to you. If it is, leave some feedback. If you have some criticism, also leave some feedback. I'm open to all feedbacks. Share this video and this series with like-minded people to help me grow here on YouTube. Subscribe, and that's it. Enjoy the series. Hi everyone and welcome to this new video. In this video I introduce a new series which is gonna be about Windows privilege escalation. So these days I'm also uploading the Linux privilege escalation series, which is about privilege escalation in the Windows operating system, and today I introduce the one in the Windows operating system. And these series are similar in certain aspects and different in others. They are similar because both Linux and Windows are, after all, operating system. So many concepts apply to both the operating systems, but at the same time, they have different internal architectures, which implies that the way you do privilege escalation in Windows is very different from the way you do it in Linux. Therefore, we need two different series. I'm continuing the Linux one and I'm also doing the Windows now. So this is the first video of this series, and so this video is gonna be the start of the Windows privilege escalation series. Now in this video we will talk about Windows, we will introduce the Windows operating system, I will then talk about how I'm setting up the virtual machine to play with Windows. So here I have a virtual machine running Windows 11, and anything that I will discuss in the notes I will also showcase practically within this machine, this Windows 11 machine. And then we will start to see some commands in the cmd.exe and in the PowerShell.exe. So we'll talk about what these are. These are the Windows shells, and I'll leave some reference at the end. So I hope the video is enjoyable. If you find it interesting, leave some comments, please subscribe, share it with like-minded people, and enjoy the video. So in our discussion regarding Windows, the first thing to mention, which is actually really important, is that Windows is not an open source operating system. So let's go back to Linux. Linux is an open source operating system that was initially developed by Linus Torvalds around 1991 and then became a huge and popular open source project. To this day, Torvalds is the one who maintains the Linux operating system project. So if you want to understand the development of the Linux kernel, you can go into this website, which contains an archive of all the communication that happens for the development of the Linux kernel, which means that with respect to Linux, we have a lot of different information. We have the source code of the operating system, we have the communication, the development that happens, we can see it evolving, and so on and so forth. Now, this is not the case when it comes to Windows. So this is the really first and important part to understand about Windows, is that it is a proprietary operating system which is developed by a company and specifically by Microsoft. What does this mean, essentially? Well, in practice, this means that we have less knowledge about the internal functioning of Windows. Why is this important? Because every operating system, essentially, has two main components, which is the kernel of the operating system and the application layer. This is also called sometimes the user layer, interchangeably, you can also say the user layer. It is also said like userland, kernel land, userland. So what's the idea here? The idea is that when you have a computer, of course, we start from the hardware resources. So we have the hardware, which essentially limits what we can do because we need a processor, we need some memory, we need an hard disk, we need some power consumption, we need extra drivers. So we have a lot of hardware components. Now, the piece of software that interacts with the hardware, that actually writes into the hardware registers, that reads the value, that controls the hardware essentially, is the kernel. So the kernel is the most important part of the operating system, and it is also the most critical with a lot of different respects, because essentially it is the wrapper for the hardware. It is the layer that abstracts the hardware away so that the software can do its thing. So that when I write a C program and I open a file, I don't need to worry about the internal hardware implementation of my hard disk. And I don't need to worry about that because someone else did, and specifically the people who developed the kernel. So the kernel is a piece of software that is written in low-level languages, such as C and C++ with some assembly, depending on the architecture. So the kernel is really critical part of the operating system. Now the kernel offers to the applications a series of system calls. So essentially the interface between the kernel and the operating system, the application layer of the operating system, this one, is done through system call. System calls. For example, if you ever write a C program, sometimes you notice that there is the write syscall. The write syscall is offered by the kernel. It is a service that is implemented internally in the kernel. So when an application has to make a write syscall, the application gives control to the kernel understands the request of the application, performs the job, also interacting with the hardware, and essentially it just does what it has to do, and then it gives back control to the application with the results of the operation. So essentially that's the idea. Now, when it comes to Linux, given that Linux is an open source project, what happens essentially is that Linux is the kernel of the operating system. So Linux is the most fundamental part that is above the hardware. So this part is open source, which means that over time, on top of this, various things have been developed, and these are so-called distribution, Linux distribution, which means that they are wrappers over the kernel that take specific choices in the type of software they use, in the way they organize that software. For example, you can have Ubuntu, or we can have Arch Linux, and so on and so forth. So we can have different distribution. We can also have Kali Linux, which is another distribution. So like each distribution can be based off other distribution or directly onto the Linux kernel. So that's the idea. There is a lot of variety because it's open source. So everyone can see the kernel, everyone can modify the kernel, and so on and so forth. When it comes to Windows, however, this is not the case anymore. Since the Windows kernel is not open source, there is no distinction between the Windows kernel and the Windows application layer, because they are bundled together into a single product. We cannot separate them because we don't have the source code, we don't see it, it's a product, we just have to use it entirely as a single piece. So there's no distinction between the application layer and the kernel. This is not, it's like just united, it's a single block. This means that Windows has different versions, so we have Windows 11, Windows 10, Windows 7, Windows 8, so on and so forth. But each Windows versions come with both kernel changes and application layer changes. So it creates a really like complex environment to learn and understand. Now, I wanted to mention this because it's important to understand the difference between an open source operating system and Windows. So since in Windows it is not possible to separate the user space program from the internal kernel code, the concept of a Windows distribution does not exist. This is why we don't have Windows distribution. Rather, we have Windows versions, which are single product shipped by Microsoft to do what they want to do essentially. So some history regarding these versions. So initially we did not have a graphical user interface, it was only like a text terminal, and it was called DOS, which stands for Disk Operating System. It was a non-graphical command line operating system, and it was created for like IBM and for other companies that operated with mainframes and things like that. So the idea is that we have a bunch of releases for this Microsoft DOS from 1981 to 1994, and then comes the actual Microsoft Windows, the first version around 85, and then the last version is Windows 11 with 2021. And in between them we have Windows 1, 3, NT, 95, XP, Vista 7, 8, 10, 11, so there's no 9 here. And also here I do not mention, but there are other product lines from Windows, which is the Windows servers. So it's like Windows servers. Because of course Windows is also used in the industry for managing corporate networks. So there's like a heavy product line with respect to like servers that are used in corporate networks. And this brings us of course to the Active Directory part. Now, this series will not be about Active Directory, because for Active Directory there will be a specific series. But essentially, the idea of Active Directory is that once you have a bunch of Windows servers together, you want to manage them like in a centralized way, in an abstract centralized way. And so Active Directory was developed to ease the management of many different computers, of corporate networks, to join corporate networks together and things of the sort. For now, we will just focus on the basic Windows version. For example, this one, the one that you use, because the commands we will talk about can be used into these versions, into the basic server versions, and things like that. So this knowledge is the knowledge you need to do privilege escalation on Windows. So in terms of virtual machine setup, I'm using the project called quickemu. And here in the reference, I bring the GitHub project. So this project is extremely useful and I suggest you to use it. It has a lot of stars, extremely useful. So essentially this project allows you to quickly create and run optimized virtual machines for Windows, macOS and Linux. It's really simple to use and there's a lot of documentation. It is based on QEMU, which is like a machine emulator. So it emulates the machine essentially. And you have two commands here, which is quickget and quickemu. Quickget is used to download the ISO for the operating system, which represents the disk image, the one you use it to install it essentially. And once you have the disk image, you can run quickemu to create the virtual machine and to also start it. So it's extremely useful. I will make a dedicated video on quickemu, I think, because it is a project that you must really know essentially, because it's super useful. So how you use it, once you download it through your distribution, so if you have Arch Linux, you do one thing, if you have Ubuntu, you do another thing. And I believe that in the documentation, here in the installation portion, there are instructions. For example, in Arch Linux, you can use the our helper EI. in Debian or Ubuntu, you have to first add the repository, then you have to update your sources, and then you can quickly install it with sudo apt install quickemu. So it's really simple install, and the way you create a virtual machine is extremely simple, because first you do quick get. Once you do quick get, it's gonna download the ISO into a folder, Windows 11, and then it's gonna create a specific configuration to run your virtual machine, like this Windows 11 conf, which if we look at it, it contains just a bunch of like file paths, essentially. And then to actually start the project, you can run quickemu --vm Windows 11 conf, so the configuration file that the first quick get created, and then you can use the display spice to enable the sharing, for example, of the clipboard between the host machine and the guest machine. So like the guest is the virtual machine, the one we are virtualizing. The host is our real machine, the ones that runs on real hardware. So extremely fast. Here is the result. So here I have my machine. I can open the command prompt, for example. I can write something, for example, whoami. We will see this command. I can do this, I can copy this, and this is gonna be copied into my clipboard, and then I can pass it here. So I have everything enabled. It's really useful, and I suggest you also to use this project. In the future, I might make a video more detailed on how to set it up, because it's an extremely useful project. So now we can get into the meat of the argument, which in this case, since this is the first video, we can talk about an introduction to the Windows shells. And notice here that I use the plural shells, not the singular shell, because actually in Windows there are two ways of doing things most of the time. There is the cmd.exe way, the cmd.exe, and the PowerShell, so the command line and the PowerShell. And you can see here in the virtual machine that here I have the command line, this one, and the Windows PowerShell, this one. And if I open them up, so like this is the command line, it's the latest version, and this is the PowerShell. Notice that even though like the terminal looks pretty similar, the actual shell is different. So remember from the Linux introduction that we discussed the role of the terminal, which is the graphical GUI that allows me to interact with the shell, where the shell is the interpreter that receives commands from the user, understands them, and sends them to the kernel. So the way that the interpreter works essentially is, I write here a bunch of like things like whoami, I press enter, the process of the terminal sends this string to the shell receives the command whoami, understands it, executes it thanks to the kernel, and then gives me back the result. So it's like graphically we have the terminal, which talks to the shell, which talks to the kernel. Of course, this is just an abstraction. In practice, it could be implemented using like middle elements into here and into here. This is just like an abstracted way of thinking about it. For example, in the Linux, we have a specific device driver, which is called the TTY. And here we do not show it because I don't know exactly how it works in Windows, but generally the high-level components are the terminal, which is the graphical interface, it's literally the GUI that is rendered by Windows, the shell, which is a process, so we don't really see it in terms of graphical terms, and it is the process that reads the command, for example whoami, and prepares the various code that is then executed by the kernel. So the shell is like, hey kernel, can you execute the command whoami? And the kernel is like, okay, I execute it for you and I give you the answer. The shell receives the answer, which then sends back to the terminal, which displays it after the command. So this is the basic idea, and notice that if you check the differences between the PowerShell and the basic Windows shell, is that here we have a bunch of Windows PowerShell, here we have just Microsoft Windows, and here we have in the prompt of the shell, we have the same path, C users quickemu, but here we have PS, and here we do not have PS. So be careful about this, because anytime you are in a shell and you see this PS sign, it means that you are in PowerShell. And why is this important? It is important because the commands that work on PowerShell are not the same as the commands that work on the CMD, on the command line, on the basic Windows shell. So there's a difference, and you must be aware of this difference if you want to like do your privilege escalation, your penetration test, or if you just want to use the shell. So why is there this difference? Like, why do I have two terminals and not just one? I don't know the exact reason, but I believe that it was because, as I said initially, Windows was developed as like a text-only operating system with DOS. And essentially the cmd.exe, this command line, this first command line, was just like a part of that, essentially. It was like, okay, we have a graphical interface now, but any operating system at some point has to interact with the kernel through text, because that's how we talk to the kernel, through text, not images. Which means that at the end of the day, we still need like a shell. And so the command line, the command prompt is the old DOS that is now just one part of the operating system. We have all the GUI and stuff like that, but then we have this command prompt which is taken from old. It's taken from the old version and is ported for backward compatibility and also just for basic usage. So this is like the old shell that used to run Windows, essentially. When it comes to Windows PowerShell instead, it is more new, so this was developed later, and indeed it has, I think, a lot of abstraction and a lot of power over the way it allows you to control Windows. So this is like a newer shell, more powerful, and also like more complex to use, because you have a lot of different commands, and like you have a rich scripting language, essentially, that you do not have with the command line. So the command line is like old school shell language. PowerShell, I'm not good with PowerShell, honestly. I never really enjoyed writing PowerShell. It's like pretty complex scripting language, but of course it can be useful. It can be useful to learn because you will use it a lot when you want to do like security stuff with Windows. So like for now, essentially what I will do is we will discuss about the command line first. So the idea is that here we have our command line, and here I'm gonna put just a notepad. I'm gonna create a notepad so that every command we're also gonna write here, essentially. So we're gonna do cmd.exe. So we're gonna do this. Here I'm gonna put the Italian keyboard, and here I'm gonna do this, and so we are ready to discuss our commands. So I've grouped the commands into like 4 categories for the cmd.exe. So we can start with some basic command. For example, system info. Now, system info gives us basic information about the operating system, the version, the architectures, and things of the sort. So we can do essentially simple system info. It's gonna load of course, the information of the environment, and it's gonna print us this information out to us. So the most important thing is the host name, which is the name of the machine in the network, the OS version, and the OS name. So we can see that it is a Microsoft 11 Pro build. It is a version 10.0.22631. It's manufactured by Microsoft, of course. Here we have information about quickemu, which is a virtualizer. Here we have information about the type of processor. So it's like here we have information about the Windows directories and a bunch of other things. The page file location, the domain, and the logon server. Now in this case, what's really important here is definitely information about the OS version to understand what kind of like version we are running. Information about the processor could be useful, not really for OSCP, you don't need to go that deep, but in general it's a useful information to know. Also the system directories, but this can never change, so it's really like you don't really care about that. And also the domain. The domain is, I think, it's a useful information when you have to do Active Directory. So like this is a first introductory command that gives you, okay, you're running Microsoft Windows 11 or Microsoft Windows 10 or Microsoft Server, a certain version and stuff like that. So this command is really useful. System info. So this command is system info. Of course, I will give the PDF with all this file in the note of the video, in the material of the video. You will find a link in the description that point to the GitHub directory. Then another information is the username. So in any operating system, and these are like common with Linux as well, in any operating system you always have the concept of users. So users allow you to essentially to authorize resources, to give permission to resources and to make sure that your user can only access certain resources. So the idea of user is critical because it is linked to the idea of privileges. So you need to understand who are you in the system essentially. And we can do that with the command who am I. So we say who am I. Here is gonna print the name of the machine, the host name. Notice that this host name is essentially this one, I believe. So like, let's see, quickemu u2fn. Quickemu u2fn essentially is the host name of the machine, and then here it's our username. So it's given hostname / username. So who am I is another really important command. Now another important command is the working directory that the processes finds itself in. So as I said, this is a shell, it's like a terminal that runs a shell, which means that it has a current directory. And we need to know the current directory when we want to move into the file system. So to print the current directory, we can do the command cd. If we do cd, notice that we get c/users/quickemu. And notice here that there is a letter, a colon, and then a \, because essentially this says, this is the root of this file system, and then you can move into the file system. So for example, if you have 2 hard disks in Windows, each one will have a different letter. And you can see these names from this tab. From the This PC tab, you see device and drivers. You see I have a Windows C. This is the path, the portion, the disk that contains the Windows installed folder and the operating system essentially. So another command useful is cd. Then going on, we have the environmental variables. This is another concept that both Windows and Linux have. So what does it mean? It means that each process has a working directory, but it also has a bunch of variables that define its environment. So this is why they are called environmental variables, because they are variables, like you have variables in your C program, but they are like, they depend on the environment. So they allow the shell to understand the external world, to interact with it. And to get a list of our environmental variable, we can use the command set. So we can say set. And notice here that I have a bunch of output here. And this output is structured as follows. We have the name of the variable, an equal sign, and then the value of the variable. And this is like applies to every environmental variable. For example, we have this app data folder, which is a critical folder that contains data generated by the various applications. So each application can write some files, and typically the app data folder is used to application to write their data. So it's really useful to know where it is. And then you have a lot of other environmental variables. The important thing is just to understand what they are, because sometimes, for example, if you get a remote code execution into a certain web process, maybe that web process has like sensitive information stored into environmental variables. So understanding them is critical. And so we have the command set to understand the environmental variables. Then if you want to print a specific environmental variable, we can use the command echo. So once again, this is similar to Linux, but in Linux we would use the syntax $path. This, for example, in bash. In CMD, in the command line, we have to use this modules operator, these percentage signs, and we have to put the name of the variable in between these percentage signs. So we have to do essentially echo %path%. And here it's going to print out the value of the path environmental variable. For example, let's say I want to see the variable of app data. What I can say is, I can say echo value of app data. Now this is path again. I have to write app data. And here I get the value of the value, I get the value of the variable app data. So notice that here I printed the value of the path. Now the path is a really critical concept to understand, because the path is the environmental variable that is used when I want to find the program to execute. So for example, if I write a program here like whoami, if I do whoami like this, the shell has to understand which binary to execute within the system. And in the current directory that I'm in, there is no binary named whoami. So it is not in the current position. How does the shell know how to find this binary? Well, the idea is that it looks through all the directories saved in the path. It goes over them because notice that this value is a bunch of directories separated by this semicolon. So we have this one, C Windows System 32, C Windows System 32, WBEM, C Windows, and so on and so forth. So the idea is that the shell is gonna loop over these directories to find the specific command. Now, and so we have this echo path as another command to save here. Then, for example, if you want to find the specific path of the executable, we can use the command where, which is the equivalent of which. So like in Linux, we would use which. In Windows, we use where. So for example, we can say where whoami, and notice here what it says. It says, look, whoami is found in C, Windows, System 32, whoami.exe. So if you notice before, it is essentially like this one. I think it's this one because Windows is not case sensitive with respect to path. So lowercase names or uppercase names are the same, essentially. So it is the first one. If we go there, we find the whoami executable. And ultimately, it is this file that is executed by the operating system when we call the command whoami. So for example, if you write a command that does not exist, like asd and so on and so forth, here it says, look, this thing is not recognized as an internal or external command. This means that this command is not implemented internally in the shell and also is not found in any of the directories saved onto the path. This is why you don't find it. If you don't find like a command, it's probably because your path is not properly configured. And so here I can write where whoami. Perfect. Now there are two other commands. We have the get documentation and the clear screen. Now the get documentation is a really important command, of course, because most of the time we might forget about a specific flag. We might not remember how to use a specific program. So what do we do in that case? We can use the command help. So the way the command help works is you can say help, and then we can write the name of the command that we want to understand. For example, whoami. So I say help whoami, and it gives me, okay, this command is not supported by the help utility. So in this case, it doesn't work. It says try whoami / ? So for whoami, actually, it's this other syntax that works. But for like other commands, we can do help, let's see, help dir, and here I have displays a list of files and subdirectories in a directory. So I get the documentation for the command. So I always suggest to first you do help, and then if it says, look, this command is not supported, you have to use this different syntax, you go into the different syntax. But it's really important to say help dir and also whoami / this exclamation mark. It's a different way to access the documentation for that particular command. And finally, to finish off, we have the clear screen command. So notice that so far I have printed into the terminal, into the GUI terminal, a lot of different output. And I can access that output if I go back. So here was the start, and here I can sort of save it until I go down. And here it says press any key to continue, I press OK, and I'm down. So if I want to clear this output, I can say CLS, which stands for clear screen. I press OK, and notice now that I lost the ability to go back. But it also means that that output is no longer saved into memory, so it saves up memory. So when your terminal gets too long, for example, because you execute a command that prints a lot of different stuff, I always suggest to do a CLS. And so with this, we have finished essentially the first batch of commands, which is the basic commands. These are your basic helpers to start understanding a Windows system. Moving on, we find, of course, the file system commands. So how do we move into the file system? So remember, the idea of the file system is that it is a way to structure resources. Because at the end of the day, the operating system has to give out resources like file, processes, programs, and things like that. And they are structured into a file system. So the file system has a tree-like structure. So this is a tree, which is something studied by theoretical computer science. And notice that this tree has a starting point here, which is called the root. And in Windows, for example, the root of the tree is this one. is this C:\\. So this is the root. Notice, for example, this path is a C users quickemu. So we go into C, then into the node users, and then into the node quickemu. So it is hierarchical in this sense. It is hierarchical like a tree, essentially. So that's the idea of a file system. Now, as I showed in Linux, we sort of have to move around into this file system to access different resources. So how can we do that in Windows? So here I put a bunch of space. Here I can actually save this file, save as commands. I put into the desktop, and I think it's, I don't know where it's saved. Okay, here, perfect. And so we need to understand how can we move into this file system. So the first command is to print the current directory. So we already saw this command, it's the cd. This gives us the current position that we stand in the file system. So among all the different resources, we are in the C users quickemu directory. Then we can list the files in the current directory. And for this we have the command dir. So we can say dir, and here it gives us the listing for the current directory. So it says, look, we have all these folders, and then notice that there is the dot and dot folders. This represents the current directory, which is this dot, and the previous directory, which is this dot. By using all this stuff, we are able to go backward and go forward. So notice here, for example, I have a directory test. Here we have the date in which it was created, and here we have the type of the file. So notice, for example, that we do not see here permissions, because to access permissions, we need different commands. And the commands for dealing with permission I will showcase in a different video. So continuing, we can list files in a current directory. So we can say dir, and also we can give various options to the dir command. For example, we can say dir /a. What does this do essentially? It prints all of the file, also the hidden ones. So notice the difference. Before, with a normal dir, it's just this stuff. But if I do dir/a, I get this other stuff. So notice I get this junction, I get like a bunch of files here, end-user.dat, end-user.log, and stuff like that. So end-user ini. So I get other files, which essentially means that with the -a, with the /a, I get more information. So remember, each command has specific ways to be used. Then we're gonna see the commands to create a directory, create a new file, and read the file's content. So to create a directory, we can use the make dir command. So make dir, and here I say new directory. I say new directory, and I've created a new directory. If I do dir now, notice that there is this new directory. And I can go into cd, I cd into the new directory, I do dir again, and there's nothing here. I get nothing. And it says, look, there are no bytes here, and you have all these bytes free in the operating system, which I like a lot. Then, to create a new file, I can do these various syntaxes. If I want to create an empty file, so a file containing nothing, I can do type null, and then I do this redirect, this angular test.txt. So I say type null, redirect test.txt. I go dir, and notice now that I created this new file, but this new file has 0 byte content, so it has no content. It is an empty file. If I want to create a file with some content, like some content, I say new.txt. So I do echo, the string, and then this redirect. Notice now that if I do dir again, I have two files, new.txt, which is a size of 17, and test.txt, which is a size of 0. So I have two files here, and notice here I say type to create like an empty file, echo creates a file with some content. So this of course depends on what I need to do with these kind of operations. Finally, if I want to read the file contents, so the content of a file, I can do type, for example, new.txt. I write type new.txt, and I get some content. I write type test.txt, and I get nothing, of course, because there are no bytes into that file. So this is really important. Now, continuing, we have some permission commands. As I said, we start off also, I have to write here, in this txt file, all the file system commands that we used. So make dir, it's like make dir test, create a new file, and read file's contents. Of course, these are like basic commands, but the idea is first you learn these basic commands and then you can do more complex stuff on top of those. If you don't know this, it's gonna be harder to do more complex stuff. So when it comes to permissions, as I said, the most important thing is to do a good whoami to understand your current user. So this is the first command you should do, whoami, and we write it here, whoami. Then we're gonna list out the groups we belong to, because Windows, similar to Linux, has the concept of group, and a group is a collection of users essentially. Every user can belong to various groups. So I have user 2, user 1, and they belong maybe to the same group. So a group is a collection of users. To understand my groups, I can say whoami /groups. And notice here that I get a lot of different groups. So I'm gonna zoom out a little bit and write it again. So I'm gonna do clear the screen, whoami /groups. So I'm gonna, okay, so we have the group everyone, the group authority, administrator, users, console logon, authenticated users, this organization, local account, local. We have different like groups and they have a specific CID, SID. We will talk about this in the next video. Then we can see the privileges for the current user. This is like one of the most important commands for privilege escalation because depending on the output of this command, you get access to a bunch of different scenarios. So you say essentially whoami /priv, and whoami /priv gives you the privileges information regarding to your specific account. So we have the privilege name, the description, and the state, if it is disabled or enabled. So for example, here there is this impersonate privileges, which is really critical because it allows to do privilege escalation. We will see that in a later video. But essentially, starting from this list, you can then go on and search, for example, how can I do privilege escalation with this privilege? Is there a way? Is there a tool maybe that allows me to elevate my privileges? So this is why whoami priv is like so important for privilege escalation in Windows. Then you can check out the account policy for the current user. This could be very useful. So you do net accounts, and here it says essentially, for example, minimum password age 0, maximum password age 42, length of password history maintained none, lockout threshold. You get a bunch of different information with respect to the password policy and some other policy of the account with respect to authentication. Then another important command is to list out the other users in the system, because of course when doing privilege escalation, essentially the idea is that you might not be the only user, typically you're not, and typically the way you get to the administrator user or to a user belonging to an administrator group is to pivot with different user. So you start with the user 1, then you pivot into a user 2, then into a user 3, and then into an administrator role. So that's the idea. So understanding what are the users is another critical idea, and you can do this with the command net user. So you can say net user. For example, in this we have administrator, default account guest, quickemu, and VWAG utility account. So most of those are service accounts. I mean, they are always there. And we have administrator and quickemu. And right now I'm in quickemu. So let's remember all the commands we did. So it's whoami groups, whoami priv, then it's net accounts, and then it's net user. Continuing, say that you want to understand the privileges, like the details of a specific user. To do that, you can say net user, and then you can put the username, for example, quickemu. So here I say net user quickemu here, and it says, look, full name, comment, password required, user may change password, and logon hours, last logon. We can see the local group membership. We can say, look, it is in group administrator. We can say the global group membership. So for example, this user is in an administrator group, which means that he can perform administrative task, essentially. And notice that, for example, this terminal is running as administrator, so it has unlocked these abilities. So this is like really important. And then finally, we can get the permission of a specific file with these icals commands. So for example, I can say syntax.txt, and here we have this anti-authority built in. So for each essential user of the system, we what the user can do. And we will discuss about how to read this in a future video. And so we write these other commands that we discussed. So it's the net user and it's the ICAX, which stands for Access Control List, ACL. So like ACL is Access Control List. It's a way to implement authorization checks in Windows essentially. So continuing, another thing that we need is to talk about the network commands, also in CMD. So we can list out all the network interfaces with the command ipconfig/all. And this command is really useful, especially when you're doing like a CTF or just, I think it crashed for some reason. I don't know why. So let's say ipconfig/all. So notice that in this case, I have this network interface with the IPv4 address, which is the 10.02.15. So if you're doing a CTF or a penetration test, you get access to the machine and you notice that you have many different network interfaces that are different from the one you use to enter the machine with, then you have a way to pivot, essentially to use the box as a middle point to explore further networks. And this is actually required by the OSCP exam, for example, and by other penetration testing certification. And so here we put a new line and we say ipconfig/all. Continuing, we can display the routing table with route print. So essentially this table says if you want to go into this network, then you have to use this gateway. If you want to go into this network, then you have to use this gateway. This is the net mask, this is the interface, like a bunch of different information with respect to how network packets are processed. This is a bit more advanced, but the idea is that with knowledge of this IP route, you understand where packets are going, if they are going to the right gateway, because essentially it is the gateway that will then process the packet and send it further to other networks to be resolved, to get a response back from the server and stuff like that. So we have it for IPv4 and for IPv6, and we have also a list of interfaces, the loopback and the eternal adapter, which we also saw here essentially. So this is the idea with the print route print. Continuing, we have the netstat-AO. So this gives out all the list of listening TCP addresses essentially. So they are listening TCP like processes. So this means that all of these processes are listening to different TCP ports. I mean, there are a lot. Actually, here it says also UDP. What if I do N? Also, what if I do T? So to actually get only the TCP listening port, I read the manual, which I obtained with the netstat /?. And here it says, look, you can use the -p with the proto to show connection only for the specified protocol, which is like TCP, UDP, TCP v6, UDP v6. So in this case, I say netstat with the -AO, -p TCP, and it gives me the listening TCP ports. So like this is like really useful. So I'm gonna copy this actually. And that's it with respect to networking. And so like this covers the basic command line commands. I mean, are these all commands that you need to know? Actually, let's rewrite this into CMD because it's, how do I rename this? So like copy, I don't want to, what if I want to save as CMD? So CMD, of course, are these like all the commands that you need to know? Clearly not. Clearly there are a lot more commands, but the idea is when you start to do this kind of stuff, you want to start slow, you want to start with simple commands. You learn this well, you learn what they mean, what they do, and then you're able to go into further more complex payloads and commands. So I suggest to start with this. And now we can actually talk about PowerShell. So I have less stuff about PowerShell. I have some basic commands, some process commands, and some service commands. But the idea is that throughout this series, we will use both CMD and PowerShell to do various activities. So we start with some basic PowerShell commands. So now that we analyze the commands for the basic Windows prompt, we can actually open PowerShell this time. So this one, Windows PowerShell. And we can check out the commands for the PowerShell. So this PS, the basic commands. So we start with some basic commands. First, we have list of local user. So we can say get local user. We say get local user. And notice that commands in PowerShell have this syntax, which is a bit more complex than command prompt. So we can say get local user. And here we have the list of the local user to the machine. Then we can list out the local groups. So get local group, we can say this. And here we have the list of local groups. So similar, but not user, but groups. So not this, but get local group. Then we have the members for a specific group. So we say get local group member, and then here we put a group name. For example, if you want to know who are the members of the administrators group, we can say get local group member. We put administrators, which is the name of the group. And here we get the members who are like the users who are members of this group, which is the administrator user and the quickemu user, which is also our user. So this is another important command. And here I just say group name. Then we have once again the environmental variables. So we say dir env with the colon here. And once again here we print out the environmental variables. Notice the app data is the same. Many of them are the same. Maybe there are PowerShell specific ones, to be honest, I don't know. But that's essentially the idea. So we do dir env with a colon. Then we have these commands, which is really useful when you want to search file in the file system. So for example, let's say that I want to search for txt files. What do I do here? How do we read this command? It's like, we say, look, I want to get the items, get a child item. Here I put the path, so the starting point from which to start the search. Here I put essentially the pattern of the file that I want to search, that it is a file. I want to make it recursive, and if there is an error, I want to silently continue. So in this case, here I'm searching for file of the extension kdbx, which is a common extension that is used by the KeePass password manager. So KeePass is a password manager. It is used to store the like hashed password. And of course, if we find the database for the password manager, this is the database used by KeePass, the extension for the database. It could contain sensitive information. Now, in our case, we just want to search for txt file. So we can modify this command and we can execute it. So I am into the here into the directory of the user. Remember that in new directory, here there are a bunch of text files. So when I execute this command, so I have to say get child item path, etc., etc. I press OK, and notice that it gives me all the all the findings with the directory and the content. So we find a file txt written in desktop, which is cmd.txt, 2 file txt in new directory, and 1 file txt into test. So we go into test and we type test.txt to get the content. It's written hello. So this is just a file I put previously during my testing. So with this get child item, it's really useful because you can sort of modify it depending on your need. So here you can modify it by changing the starting point of the path and the pattern that you want to search for, we can say. And so like this is extremely useful command. Going on, continuing, we can find the commands related to the processes. So processes are of course a fundamental part of our operating system because processes are like what does the job. So like we have a program, but a program is just a static representation of a process. When a program is executed, we have a process. The process is the one responsible for doing the actual job, doing the actual work. So at any point in the system, we have a bunch of different processes running. So to get a list of them, we can say get process with PowerShell. And notice here we have a lot of processes. Most of them are operating system processes like cvc host. So like there are a lot of operating system processes. On this Windows it's really like difficult to understand. I mean also Linux, but especially Windows. Then for example, another thing that we might want to do is, okay, now I want to select all the applications that have been installed onto the system. And we can do this with this command. So it's get item property, and we do this HKLM, and here we put a specific path. So this is for 32-bit, and then we have a version for 64-bit application. So for 32-bit application, we do this, and notice here I get Microsoft Edge, and then I get Virtio WinGuest Tools. So here I have a bunch of different application installed. So these are like really useful because maybe one application can be vulnerable. So you want to understand which application you have installed. Also to understand if there are like third-party application. Because, you know, when you see Microsoft Edge, it could contain a vulnerability. But let's be honest, when you're doing a basic penetration test, you're not likely going to exploit a vulnerability in Microsoft Edge, simply because it's too difficult and it's not the right context. Instead, if you have a third-party tool, if you have a third-party application that has a simpler vulnerability, that has a higher surface attack, you can focus on that and probably you get something out of it. So understanding which are the application installed is critical, and this is true for both 32-bit application and of course 64-bit application. So here we have two different commands. Notice that what changes between these two commands is this path. Here we say wow node and here we say Microsoft. So there is not that. So we do this and here we have quickemu guest agent, red dot controller, spice agent, which is the agent that allows me to share the clipboard with my host and stuff like that. So we can copy this and we can paste it here. And here this is like PowerShell.exe. And here I put a bunch of dashes. Perfect. So we have the command processes. Finally, as a last thing, we have the service commands to get information about services. So like services in Windows are like cron job in Linux, sort of, and they represent a really important attack surface for doing privilege escalation, because sometimes we're able to do service hijacking attacks, we're able to modify the path of the services, restart them, and obtain code execution. So stuff like that. How do we do this? With this command, get service with the wildcard. So we can say like get service, and here we have a list of services that are like either like these are not all running, some of them are stopped. For example, now this Xbox Live networking service stopped. So here we are just taking everything essentially in this first. For example, in this get service, in this other command down instead, I only get the one that are running. So in this other, I only get the one that are running because I have here this where object where I put where object like running. So object has to be running, the state has to be running. So this is actually much more useful because while the other tells you all the services that are registered, the second one gives you all those that are also running, and you see like the command that was used to run them. So you see the basic executable that is like that implements that service. So crypt svc, lf svc, and stuff like that. Spooler, spice agent. So spice agent is a C program file. Spice agent voodooservice.exe. So this is like already like a sort of third-party service. Maybe we can attack that and stuff like that. So it's really important to know these commands. So we say get service info. Of course, for the services, I will also make specific videos because, as I said, it's an important attack surface area. I would say that in terms of PowerShell.exe, that's really good. So we have this other file. Actually, not exe, we can just rename it. So do rename it just PowerShell, I suppose. Perfect. PowerShell, and I can remove this. So I have CMD and PowerShell. So I've showed a lot of commands. I mean, these are like basic commands, but commands that you need to know. So we discussed about Windows. We discussed that Windows is a closed source software. So we don't see the kernel. We just have some intuition about how it works, but we never really see it. So it's like really difficult to understand exactly what is going on. And in Windows, we have two different shells, which is the command line prompt, which is like a modern version of the old DOS. And then we have PowerShell, which is a much more modern shell. And notice indeed that the syntaxes of like the CMD shell and the PowerShell shell is pretty different, because in CMD you have simple commands, while in PowerShell you have complex commands that are like combined together. For example, get service, then I do select object. So like this gives me a bunch of services objects, and then I select from this object a bunch of properties, such as display name, status, service name, or the instances of the service, and then I filter out in like a programmatic way Also, this get child item, I have different like paths and stuff like that. So the idea is that PowerShell is much more rich in terms of syntax and in terms of what you can do with it. And of course, it also means that it's much more complex, but it allows you to craft, to prepare specific commands that are really powerful. So I would say that you need to know both, because sometimes you enter with CMD, sometimes you enter into PowerShell. Then there are ways in which you can pivot from a CMD shell into a PowerShell. I think it's, let's say you open a shell like this. You can do PowerShell. If you do PowerShell like this, you launch the PS, like the PowerShell shell. So now I'm inside PowerShell. Now sometimes this behavior is blocked, but you can bypass it with PowerShell EP bypass, I believe. So this allows you to bypass certain restriction, so it's a useful command to know. So I'm gonna put it into the CMD actually, because it's the way in which you can interact with PowerShell. And then once you're in PowerShell, it's easier to do the reverse, because if I'm in PowerShell, I do CMD, notice that now I've opened the CMD shell. So I do not have the PS anymore, but I have the typical command line prompt, the Windows command line prompt. I do an exit, I get back to PowerShell. So PowerShell is the most advanced one. Typically what you want to do is, maybe if you start from a simple CMD, you want to go to the PowerShell. So you want to elevate your sort of like shell to be a PowerShell. And then in PowerShell you have a lot of scripts, a lot of tools, a lot of stuff that essentially use all this power. These are like basic commands that are combined to this one, to give a quick introduction to the system, and in later videos we will explore how we can use the different permissions, how we can read the permission, for example with ICACLs, with the access control list, or how we can exploit the services and stuff like that. So having said this, the video is over. I hope it was an enjoyable video. If you find it useful, please leave some feedback, share this video with like-minded people, subscribe to the channel, and to the next video. Hi everyone, and welcome to this new video in which we continue the Windows Privilege Escalation series. So this is the second video of the series, and in this video we will discuss about Windows permissions. So how permissions are handled by the Windows operating system. As you can see from these titles of these headlines, there's gonna be a lot of definition of terms and concepts. It's gonna be a very theoretical video, so I'm sorry for that, but it's necessary. I will show some commands on the virtual machine here, but really not that much, because this discussion is mostly theoretical to understand what are the main mechanisms that Windows uses to manage permission. However, even though these are all concepts in theory, in practice, when we will actually see exploitation techniques, this concept will be critical to know, because we will exploit various concepts. We will use the concept to actually understand what is going on during the exploitation. So I hope the video is enjoyable. I hope you get something out of it. If that's the case, please let me know. Subscribe to the channel, support me, share the video with like-minded people, leave some feedback, and enjoy the video. So we can start our discussion by talking about authentication, authorization, and session management. Now, anytime we interact with a secure digital system, that means a digital system that has different permission roles. So you have a basic user, you have an administrator user, you have a middle privilege user, and so on and so forth. So anytime you can differentiate between different users, the idea is that you always have the following three aspects, which is authentication, authorization, and session management. Now, when it comes to authentication, the basic objective of authentication is to understand who you are. Every time you authenticate to a system, you are proving a certain identity. You are proving that you are, for example, Leonardo, or you are proving that you know a certain secret. It's like you are proving something, you are proving an identity. This is typically done through passwords. It is not the only way. There are different ways of authenticating. For example, in your mobile phone, you can use your finger, you can use the fingerprint, or you can use your face for biometrics authentication. But regardless of the way in which you authenticate, authentication is about answering the question, okay, who are you? And this is important because we have a server typically that handles a set of resources, and then we have a client. The client, of course, wants to access those resources. But before being granted on these resources, the server has to understand, okay, is the client allowed to access them? And so you have authentication. So typically this is the first thing that happens, authentication. Now, after authentication, and if the authentication procedure has successfully terminated, so it was a positive authentication, the server typically generates some data that gives it back to you, some data that is used to track your session. So we talk about session management because after the client authenticates, a session is established between the client and the server. During this session, the client will be allowed to access his resources without giving the password all the time. I mean, these same concepts apply also to websites. So you have your e-commerce, your Amazon, your whatever site. First, you log in with a password. You establish a session. Afterwards, for doing operation on the site, for example, for buying an item, you do not have to put all the time your information, your password to the website. You do not have to constantly keep authenticating yourself. So the idea is that a session is established. Now there are different ways of handling sessions, but there is the concept of a session. And while the session is alive, we find the authorization checks. So authorization checks are related to what can you do. So it comes after you authenticated, after you established who you are. Then the next question, of course, is, okay, perfect. You are the user Leonardo. What can you do exactly? The server has to know what are your privileges, what are your authorizations, what you are authorized to access. Because the server handles many different resources, R1, R2, R3, and so on and so forth, and maybe your client is not allowed to access all of the resource, but only a subset of them, maybe only R1 and R2, not R3. So understanding what kind of resources you can access or not has to do with authorization. So typically what happens is that in the way the session is managed, if it is properly managed, in the data that the server gives back to you, that you later use to say to the server, look, I am an authenticated client with this session. In the session data, there is also the information regarding the authorization checks that will be performed on the server, by the server. So anytime later during the session you ask something from the server, you ask, for example, I want to change my password, I want to change this group configuration, I want to edit this file. Anytime you want to interact with a system, the server will check, okay, are you authenticated? Do you have authentication data? Do you have session data? More properly, session data. Okay, let's take this session data and let's check the authorization privileges that are configured in the session data, that are written in the session data. So this is like a really general concept about authentication, authorization, and session management. It is not specifically to Windows. We can find it on Linux, we can find it on web application, we can find on IoT devices. Anytime we have the concept of user roles, we also find authentication, authorization, and session management. Now, in the context of Windows, entities that can be authenticated to the system, for example, to the operating system, are called security principal. So this is like a keyword, a key name that you need to remember. So a security principal is anything that can be authenticated by the operating system. So example of security principals are like user accounts, so like my account, your friend's account, and so on and so forth. Computer accounts, which means accounts that do not belong to a specific human being, but that are used for services. For example, a database account, a MySQL account, or also threads and processes. So you spawn a process and the process has its own security principal. Now, to identify which security principal you are and to identify the different security principal, the idea is that each security principal has a so-called security identifier, which is abbreviated as SID, SID. This is like an ID for identifying the different security principals. The SID cannot be changed. It is generated upon the creation of the users or the groups or the processes or threads. And of course, they are generated by different components depending on the context. Because we have to remember that there are many different contexts in which Windows can operate. For example, if we are on a single operating system that is not connected to any networks, then the SID for local accounts and local groups is generated by a local component of the operating system, which is called the Local Security Authority, abbreviated as LSA. So this is just a specific process that runs on your Windows machine. It does not interact with the network, it just runs locally, and it manages the local security identifiers. However, a key aspect of Windows is that it can also be used in different contexts, more complex contexts, which is the context of Active Directory. So when we have an Active Directory, and I will make a specific series about it after I'm finished with this base Windows series, but when we have an Active Directory network, we are not dealing with a single computer anymore. We are actually dealing with a network of computers where there are some specific elements in the networks, some specific servers which control everything. And these are called domain controllers, abbreviated as DC. And in the context of domain users and domain groups, this security identifier is actually generated by the domain controller. So in those cases, the management of security identifiers become more complex because of course we are not dealing with a single computer, we're dealing with multiple computers, and the cool thing about Active Directory, which is also makes it complex, is the fact that I can authenticate on a single machine, but then I can access services on different machines, thanks to Active Directory authentication management, essentially. So that's the idea. Now let's talk about the structure of these security identifiers, because it's really important to understand. Now, this security identifier is made up of different parts, and these parts are as follows. So we have an initial letter S, so it's sort of like we have strings, and then we have dashes that separate the various elements. So the first is always an S, which indicates that this string is a security identifier. It is an ID for a security principal. Then there is R, which is the revision version. It's sort of like the version of the structure, and typically it has a value of 1 because there's only one structure used and it did not change throughout the years. So it's sort of like your version number, typically it's 1. Now after the revision, so after the revision here, which is typically 1, we have this X, and this X represents the identifier authority that issued the SID. So this X is the SID of the component who generated your SID. It is the ID of the one who generated your ID. And we said that depending if you are a local account or a domain account, this is generated by different people, by different entities. For local accounts is the LSA, Local Security Authority. For domain accounts, this is the DC, the Domain Controller. Now continuing after the X, after the third, now this gets a bit more complex because we have the Y value, which is typically like multiple values concatenated together. So these are called the sub-authorities. Now the sub-authorities is actually, as I said, it's not one single value, it is actually made up of multiple values. The idea is that all values up to, but not including the last value in the series, collectively identify a domain in an enterprise. This part of the series is called the domain identifier, and the last value in the series, which is called the relative identifier, RID, identifies a particular account or group relative to a domain. Now this can be confusing, so let's make some example. Now consider the following SID. So we start with S because it is the ID for a security principal, so it is a SID. Then we have revision level of 1, as I said. Then we have the SID of the entity who generated this SID, this SID, which is This value 5 represents entity authority. So like they are mapped, there are also like this kind of names that are easier to remember, like entity authority. Entity authority is the security principal with seed 5. This is the entity who generated this ID. Then we find the domain identifier, so the identifier of the domain, which is 32, which means built-in. So it is sort of like the domain that is built in into the computer. It means essentially that there is no external domain. Everything is local. And finally, 544 is the relative identifier, which means within the domain built-in, the security principal I'm referring is the administrators. So this is the RID, relative identifier. Now this was a simple seed, right? So let's consider a more complex one. And these examples are taken from Microsoft official documentation. I will put all the links into the description, so don't worry about that. If you like confuse yourself with this, just take some time to read it, to see through this example, because at first it can be confusing, but it's really important to understand. So let's consider this other SID. Now, the following SID represents the SID for the domain admins group in the Contoso LTD domain. So we are talking about a specific domain here, and we're talking about a specific security principal. So how do we read this? We start from S, which just indicates that this is like a seed. Then there is the revision level, which is always 1. Then we find the entity authority, which is the entity who generated this seed. It's 5. Then, notice here, now we don't have 2 values anymore. We have a bunch of values. Now, all values until the last, excluding the last one, all these values, they identify a domain in the network. And in particular, this is a domain identifier which identifies the Contoso domain network Active Directory. And finally, the 512 is a relative identifier that identifies a specific group or user within that domain, which is the domain admins. And the most important thing to understand is that the first part of the series, excluding the last, is the domain identifier. And in an enterprise network, no 2 domains share the same domain identifier. And the last, the relative ID, we have that within the same domain, no 2 accounts or group share the same relative identifier. So why is the concept of this ID a bit more complex to understand? Is because we have to remember that in Windows, especially in Active Directories, we have multiple domain networks. So we have multiple networks made up of multiple users and groups. And sometimes those groups in different servers, in different domains, have the same name. So maybe they have the same identifier, like the same 512, right? So to distinguish between them, the idea is that we have sort of like level of hierarchies. So the first 3 information are just related to, okay, it's a seed, it's a revision level, it's who issued the identifier. Perfect. The most important part is this one. This is where it is actually identifying something. So in an enterprise network with multiple domains, the first thing that we have to ask is, okay, which is the domain of interest I'm actually looking for? And this part of the seed, all the values up until the last one, it identifies a specific domain. It's like, okay, it's actually this domain. And the last part identifies a specific security principal within that domain. And the seed is generated by the network in such a way that no 2 domains share the same domain identifier. So the domain identifier allows you to identify specific domains within an enterprise network. And the same applies for the relative identifier. It's just that the relative identifier works locally. It means that you can have a 512 here, but also here 512, and there's no problem with that, because to identify the single entity, here you will use a specific domain identifier, while in this other domain you will use a different domain identifier. So by combining the information on the domain identifier and the relative identifier, you actually get a single ID across all the enterprise network. So essentially this is the basic idea for this stuff. And for example, the seed for Contoso domain admins is distinguished from the seeds of other domains in the same enterprise by its domain identifier. And the same thing applies to the local identifier, to the relative identifier. Now there are certain well-known seeds. The values of certain seeds are constant across all systems. They are created when the operating system or domain is installed. They are called well-known because they identify generic users or generic groups. There are universally well-known seeds that are meaningful on all secure systems that use this security model, including operating systems other than Windows. So the idea is that you have a certain set of identifiers which are created automatically when you use Windows. And to some of them, they're actually labeled with specific names. How can we enumerate, for example, the seed on our system? Well, to understand the identifier for the security principal that is our user, we can use the command whoami/user. So we go into our shell, we write whoami/user, and we get our security identifier. So notice, as we said, let's read this. It says S, which is a security identifier, the versioning version, which is 1, the versioning level, which is 1. Then all of this identifies the current domain, and this identifies the specific entity. So in this case, it is a user. Now, if you want to enumerate all seeds of the system, we can do with WMIC. With this command, we do WMIC user account get domain name and seed. So this is for all the users, the seed for all the users in our system. So for example, we have the seed for the administrator, for the default account, for the guest, for the quickemu, for the WDAG utility account. And notice that all of these have the same initial portion. The prefix is always the same because it identifies the machine itself. So it's meaningful just to say this machine, which is the local machine. And the only thing that changes is the relative identifier. It's the RID. And we have 500, 503, 501, 504, 1000. The 1000 is a user we created custom on top of the default ones created by Windows. And all this information about the security identifiers, you can go into these links, which I will, of course, put into the description. And for example, in this page, you can find the well-known SID type enumeration, and essentially it tells you, okay, to 5, I do this one. To another, I do this other. Indicates a null seed, a seed that matches everyone, a local seed, the owner of the seed, like all this kind of mapping, essentially, you can find it here. And for even more information, there is this page which describes everything, essentially. How it works, how they are structured, essentially what I described in way more detail. And for example, this prefix matches this authority. So the idea is that, of course, it's not useful to work with numbers. No one remembers numbers. So what they did is that they associated specific descriptions, specific labels to well-known and used SIDs. Because those are used anytime we authenticate, for example. And so like instead of talking about S1532, we just say, okay, replicators, backup operators, print operators, it's like well-known stuff. And this is the list. We are now ready to talk about the access token. Now, as I said initially, when I talk about authentication and session management, after an authentication procedure, typically the server has to generate some kind of session data. Now, this is implemented in Windows through the usage of access tokens. Now, upon user authentication, an access token is generated by Windows and assigned to the user. The token contains data that determines the security context of the user and is later used for performing authorization checks. So, the access token essentially says that the user is properly authenticated and has a currently active session. Later on, when the user tries to do some operation on the system, like accessing some file, modifying some files, and things of the sort, the operating system Windows will take the access token that was granted to the user and will check its values for performing authorization checks, for understanding if the user is actually allowed to do that kind of thing. Now, access tokens contain the following information: the identifier for the user account, the identifier for the groups of which the user is a member, a logon identifier that identifies the current logon session, a list of privileges that are held by the user, an owner seed. So like you have a bunch of different stuff. When a user starts a process or threads, a token will be assigned to these objects. The token is called a primary token and it specifies the permission of the process or threads. So essentially, when we start a process, the process will have permissions, will have privileges that are inherited from our privileges. So we have the concept of primary token. However, it is really important to understand that Windows allows also for the usage of so-called impersonation token. Now, impersonation token are used to change the security context that the process owns or the thread owns. So even though by definition at the start we have the concept of primary token so that the process is started with our privileges, actually we can change that by using impersonation tokens. And there are a series of exploits that go and attack a specific configuration in which we can impersonate different security context. Now here I mentioned some APIs to retrieve this information, and in the reference I have a bunch of articles where they play around with the window API. Now, in our series, we will not delve into the depths of access token implementation and details. This is because at our level, we do not need to know these details. However, it is important to know that they exist. And later, when I'm done with this series, when I can do more advanced stuff, then maybe yes, we can play around with these kind of things to see how things are implemented underneath. For an OSCP level target, the idea is to understand how to use the exploits and why they work. So what are the underlying implementation and mechanism that make the exploit actually work? Because that's key. So we talk about access token, now we can talk about file permissions. Now to check permissions on a file, we can use the command icalcs, so icacls. So for example, let's say that we create a file. So I go here, let's go into the desktop and I say echo, please subscribe. And I write into a file, please.txt. So I write into this file. Notice that this file has been just created here. I can click on it and I get my content, please subscribe. Now, if I'm interested on, understanding what kind of permissions are set on these files, I can use the icacls exe, I do please like this, and I get essentially an output. This output describes the base accessing rule, the base authorization checks that are performed to access the file. And it tells you who can read the file, who can modify the file, and where those privileges come from. So specifically here I have two outputs, but before we read them, let's go further. So the program displays ACLs, where ACL stands for Access Control List, and each access control list is made up of various ACEs, Access Control Entry. So here I have to write access properly. Now each access control list has the following instructions. So there is a SID, an identifier, which identifies a security principal of the system, and then a bunch of permissions. Now an access control entry is an individual permission rule which controls the individual permission of a security principal on a file object. So these are the following, the simpler one. So like they are not fully, I'm not covering every detail on Windows permissions because it is hell, it is really hell. I'm just giving you the most important knowledge for starting out. So for example, you can have F, and F means full access to the file. You can read it, you can modify it, you can delete it, whatever you want. You can also have modify access, you can have read and execute access, you can have read-only access, and you can have write-only access. So these are really important, and essentially how do we read this output? It is saying, look, this particular security principal, that is the security principal identified by this name, which in actuality is just a SID. It's just that instead of displaying the SID for anti-authority system, we display the string which is easier to understand. But underlying Windows sees the SID, the series of bytes that represents the SID. So it says, look, if you are anti-authority system, that means if you are system in anti-authority, you can have full control over the file. And this also applies if you are built-in administrator or quickemu. So like all these three security principles have full control over the file. So here I showed another example where we have a general binary.exe. And essentially what happens here is that here everyone has full access over the file. Administrator has full access, users have read and execute, and authenticated user have modify access. So depending on your particular SID, depending on which security principal you are, you can do different things on the file. This is like a bit more complex than the Linux read, write, execute. The Linux system tends to be simpler to understand. Windows is always a bit more complex for one reason or another. So this is the basic idea. So for example, if for an exploit you need to modify a file, you need to check, okay, what is my security principal? You do this, who am I user? Then maybe you can check your groups. So you can check your groups essentially here for their security principal, here seed. So this is the seed for all your user, for your groups, the groups you belong to essentially. And then you can check, okay, do I have some privileges over this file? And you can do this with iCalcs. So in this case, it's not desktop, but it's, I think, please. It's please.txt. You check if you have access. If you have access, you go and modify it. Understanding this is useful, for example, when you have to hijack some services. Because to hijack services, you have to modify the binary of the service. So you have to have write permission over the binary to modify it, actually. So that's the idea. And there are more advanced permissions. I mean, we don't really care about that because they are not important for an OSCP level, but it's still this is not all the story. This is just the beginning. Now, if you actually want to change the permission, you can also use the iCalcs with the /grant. So /grant, here you put your seed, then you put a colon, and then here you put the right that you want to grant. And here the /t is used to set permission recursively, and the /c tells the command to keep going in case of an error. So if you, for example, have some error in a big folder structure and you want to keep going in order to change the permission of all other files, you can do as follows. There is also the PowerShell command getACL, which is in PowerShell this time, so we have to open a PowerShell. It's essentially the same thing, but in PowerShell. So I do this, I getACL, please. So getACL, okay, it's a bit slow. Allow full control. So essentially it is similar, it's just that it has a different interface because it's from PowerShell. Honestly, I really like the iCalcs, so I see no reason why not to use this, it's pretty clear to me. But there is also getACL and setACL that are the PowerShell respectives commands. So for file permission, your go-to is the iCalcs. Now, when we talk about this mandatory integrity control, this is an additional system that is built on top of, for example, file permissions. And essentially, the idea is that security principal have 4 different integrity levels. So we have system, we have high, we have medium, and we have low. Standard users, for example, receive a medium integrity level, while elevated users receive a high integrity level. Now, when a user attempts to launch an executable, the new process is created with the minimum of the user integrity level and the file integrity level. So this is important because this integrity level is both on a file and on a user. So we have integrity over the file and integrity over the user. Now, when we, for example, execute a process, what happens is that the integrity level of the process is computed by taking the minimum of those integrity level. Now, what does this mean? It means that the new process will never execute with higher integrity than the executable file. And so it means essentially that if an administrator user executes a low integrity program, that is a program that is marked by a low integrity level, then this new process will not inherit automatically the integrity level of the administrator, but rather the integrity level of the file, which in this case is the low integrity level. And so this is an extra mechanism on top of the file permission that we saw previously. Now, to understand your current integrity level, you can execute the command whoami/groups. So we can do this. I'm gonna clear. I say whoami/groups here. And notice that the last group that we see, so I'm gonna zoom out a little bit to see it better. The last group that I see is mandatory label / high mandatory level. So it means that I'm a high integrity level because I'm running as an administrator, sort of. Now, if we want to make sure that a file is only read by a certain integrity level, we can change the minimum integrity level that we need. So we can say, for example, we can set the integrity level of the file test.txt to high with the following command. So we take this, we put it here, but of course we have to change the name of the file. It is not test, it is please.txt. So this is the command to change the integrity level. And then we press OK. And notice now that we change it. So if you do icalcs, we have a new mandatory label, which is high mandatory label. Of course, we can actually, we are at that level, so we can read it. But if we were a user with a lower integrity level, we wouldn't be able to read it if we did not have this high mandatory level. Now, notice that previously we did not have this mandatory label, so it means that there was no integrity level built in, sort of, but now we have added it, and so, like, we have added a new check. So sometimes it might happen that you have technically the rights to read the file, to do stuff with the file, however, you do not have the integrity level required, so be careful about that. And so discover this extra mechanism called MIC, and then this also let us talk about the user account control, UAC. Now, UAC is a Windows security feature that once again is added on top of everything else to protect the operating system. So the idea is that most applications and tasks are run with standard user privileges, even if the user launching them is an administrator. So this security feature is similar to the other, but has to do with least privilege. So the idea is that we want things to run with the least privilege required, because if a program does not technically need administrator, we don't want to run it as an administrator, because if it runs as administrator and it is compromised during its run, then we compromise the entire system. So a better idea would be, okay, let's segregate the application. Let's make sure that each task, each process runs with the minimum level of privileges, so that even if it is compromised, it will not compromise the entire system, but only a part of the system. And with enough segregation on this case, in this context, we can make our system way more robust. And the concept of least privilege is implemented with this user account control. So specifically, after a successful authentication, an administrator account, an administrative user, actually obtains 2 access tokens, not one. The first one is a standard user token, which is used to perform all non-privileges operation. This is sometimes called filtered admin token. And the second token instead is a regular administrator token that is used only when the user wants to perform a privilege operation. So to leverage the administrator token, a UAC consent prompt needs to be confirmed. So you have a prompt, a specific prompt that says, look, do you really want to launch this application as administrator? And so the system knows that it has to use the administrator token. Of course, I'm not sure about this, but probably it is the case. All of this stuff can be configured by changing some key in the Windows registry, which is an internal database that governs how Windows is run and configured. But the idea is that in a secure system, you have this sort of extra control on top of everything else that change how checks are made. So this is it for this video. To give a quick recap, we talk about, in general, authentication, authorization, and session management. We discuss the way that security principles, which are the entities that authenticate and that do stuff on Windows operating system, are identified. So the SID, the security identifier, and here we gave some example. For example, this one is a SID, this one is a SID. So if you see stuff like this, do not be afraid, because it is a very simple structure. We have a bunch of information at the start, we have the identifier for the domain, and we have the identifier for the local entity within that domain, which can be either a user or a group. Then we talk about the concept of an access token, which implements the idea of session. We talk about file permission that we can check with the command icalcs, and we can also set with the same command. We talk about the mandatory integrity control. So we have 4 integrity levels: system, high, medium, low. So be careful about the integrity level. And finally, we talk about the user access control, which is another mechanism to protect Windows. And so this is it for this video. I will link all the references that I use to study for this stuff here about security identifiers, access tokens, mandatory integrity controls, file permissions, and also some blog posts on playing with Windows API for those interested. Now, I understand that this video was extremely theoretic and probably heavy. I am sorry for that, but with Windows, there's no getting around that. Windows is just much more complex than Linux for a series of reasons, some of which I don't understand honestly, but the idea is that now with all this concept we can not only do the attacks themselves, not only showcase the exploitation techniques, but we have a conceptual ground to understand what is happening underneath. We don't need to know all the details, but some understanding is important to understand, okay, like this is not magic. The way we do the exploit is because of all these underlying mechanisms that implement how authentication, authorization, and session management work in Windows operating systems. So, having said all of this, I hope the video was still somehow enjoyable. If it was so, please leave feedback in the comment and see you to the next video. Thank you for watching and for your attention. Hi everyone and welcome to this new video. In this video, I continue my Windows Privilege Escalation series. Now, in the previous episode of this series, it was very theoretical, it was very boring. We talked about Windows permission. It was a video that had to be done. So in this video, we'll talk about the difference between reverse shell and bind shell. We'll showcase some commands to do file transfer. So to transfer the file from your attacker box, from your attacker machine, which could be a malicious server, to the victim operating system, which in this case is a Windows operating system, to the victim machine. And finally, we will showcase how to spawn a reverse shell. Given that Windows has different shells, we have CMD and Powershell, I will show different payloads for the different types of shells. So this is gonna be the content for this video, and for every payload that I will show, I will first describe it theoretically, and then I will show it in practice with a virtual machine. So this is a Windows 11 virtual machine. It's gonna be our laboratory, and we're gonna spawn various reverse shells from here, and we're gonna see how it all works. So I hope the video is enjoyable. If you have any feedback, please leave it in the comments. Please share my videos and my channel with like-minded people to help me grow. And that's it. Enjoy the video. So to start off, let's discuss the difference between a reverse shell and a bind shell. Now, when we obtain a code execution onto a vulnerable system, one of the most useful things to do is to spawn a shell on that system. And specifically, we don't want any shell, we want a shell that can be controlled through a remote connection. Now, why is this useful? It's pretty basic, really. If you have code execution, it means that you have found a way to execute code on the remote server. However, the way to execute this code could be very complex. For example, the way to RC, to remote code execution, could involve sending a lot of HTTP messages with specific flows that can be hard to just replay all the time, all over again. So what's the idea? The idea is that with the first code execution that you get on the server, the command you actually execute will allow you to establish a remote shell onto the target, into the target you're trying to attack. Once you have a remote shell, then you can execute any command you want directly, without going through the original remote code execution path. And once we have a remote shell, then we can execute any command as if it were a local shell. Like for example, this is a local shell, I can do UMI, and it's gonna answer me with the answer and stuff like that. Of course, the power here is that this shell, the shell that we want to spawn, is actually remote. So the image that can help you to understand this setup is as follows. We have our attacker machine, and then we have the victim. We want to spawn a shell process on the victim machine here, but then we want to communicate with this shell process using the internet. So using the normal protocols that allow you to connect with the internet, which specifically, this is the TCP IP stack. So this is the protocol, the TCP IP protocol stack, which allows you to talk with anyone. It's a TCP socket at the end of the day. So the idea is the shell process has to run on the victim server, but we're able to interact with it remotely. Now, in order to spawn this remote shell, there are actually two main techniques, the bind shell and the reverse shell. Let us first analyze the bind shell. In the bind shell scenario, the attacker forces the vulnerable compromised server to open a port and to listen for incoming connections. The compromised server acts as a server because it listens to a TCP port, while the attacker machine acts as a client. So the attacker connects to the listening port, and once the attacker connects to the listening port, a shell process is executed, and we obtain a remote shell. This is sort of like an abstract description of what happens. This is the main idea. In a bind shell, the server has to open a port. And this is actually why bind shell are not really that used. Why? Because for a bind shell to work, the server has to open a port. And when you compromise a system, opening a port can be seen as a malicious activity because this port is open for listening for incoming connection. And one might wonder, why is suddenly this server opening port for incoming connections? This is really not like, it could be a sign of compromise. So reverse shell tend to be better. Why? Because in a reverse shell, the attacker forces the vulnerable compromised system to initiate a connection to the attacker machine, and the one who does the listening this time is not the compromised system, but is the attacker machine. It is the compromised system that connects to the attacker machine. So the attacker machine now acts as a server, listening on a public IP and on a TCP port, listening for incoming connection, while the compromised system simply acts as a client. And the fact that now the roles are switched and it is the attacker who listens on a port and the compromised server who connects to the attacker is exactly why reverse shells are typically better than bind shells. Since using reverse shells, the connection is outbound, which means that it goes to the outside network, something that even normal clients do, like everyone's clients will do outbound connection to watch YouTube videos, to do Google searches, and so on and so forth. Like every sort of request, you have to go outside the network, typically, in most scenarios. So it is typically okay to connect to the public internet, while it is more dangerous to open a port in your network infrastructure to listen for incoming connection. And even if you are able to open a port, most of the time that port is not open publicly. It is not open to the public internet. To give a concrete example, suppose that you are in your home. So in your home you have a bunch of devices, and here you have a router. So you have a router, and they are connected to the router. Now typically there is the NAT technology, which allow essentially all your devices to share the same public IP, so that in the internet, like all your devices come out with the same public IP. This also means that if you open a port on your machine here, you open port 7777, this port is actually not open to the router. There are other ways to open a port to the router and connect to your open port within the internal network. So in general, in this scenario, for example, if you open a port for a bind shell, an attacker from the outside cannot actually get in that simply. He also has to open a port on the router and connect that port on the router to the port on your particular machine within the internal network. Instead, if the attacker is the one doing the listening in port 777 on a given public IP, you are able to connect to him, even in this NAT configuration. So this is exactly why reverse shells are better. That is, it is typically okay to connect to the public internet. In both cases, however, the idea is to obtain remote control over a shell process. This can be really dangerous for the security of a system, of course, because a malicious actor, an external entity, is able to execute commands on your server, is able to read all the contents of all the file in the file system of your server, and is able to arbitrarily modify the state of your server, assuming, of course, he has the right privileges and permissions. So this was a theoretical introduction on reverse shell and bind shell. But let's make things practical now. File transfer commands. Now, as I said, in Windows we have cmd.exe and PowerShell. So we'll show two different commands to transfer file. So starting in the cmd shell, in the command shell, we have the certutil command. Now, funnily enough, certutil was not meant originally to be a file transfer utility. It is rather a Windows utility that is related to the managing of Windows certificates. So we are talking about TLS X509 certs in the Windows ecosystem. Now, one of the things you can do with this tool, however, is to download files, and so people have started to sort of abuse this utility, and specifically its file transferring capabilities. So, how can we download a file with certutil? The syntax is really simple. We call the command certutil, we do -URL cache, -split, -f, we put the URL and we put the output file. So here is an example where I'm downloading a specific file taken from my website. So if we go here, we open it with the browser, we go here, we say, please subscribe. This is the file on my server. So how we can download it within the Windows machine? We copy this, we go into Windows, we have to open here a command CMD. So this is a PowerShell, so I go in this little arrow and do command prompt. This has to be a command prompt. I go into the desktop. Here I just have this stuff which I will later explain, and I do certutil URL cache split f the URL and file.txt. I execute this command and it says access is denied. Now, why does it say this? It says this because Windows Defender is activated, it is on. So like the protection given by the Windows antivirus system is actually activated. And since people have started to use this, Windows has started to recognize the malicious usage of certutil and it actually blocks it. So the idea here is that since people started to use certutil to download files, here I can actually remove this for now, to download files, Windows Defender, the antivirus within Windows, has started to catch such events. So how can we avoid this? Well, for now, at our level of expertise, the idea is that we can just disable the Windows firewall. Why? Because for doing, for example, OSCP, for doing an OSCP certification, you actually don't need this sort of thing. So you can go into here, into, I think, scan option, full scan, quick scan, not scan option actually. Virus and threat protection, manage settings, real-time protection of virus and threat protection. You can turn it off. You can turn it off and that's it. Now, of course, we turn it off, so we are losing the antivirus, but we don't care. This is just for teaching purposes and for OSCP-like experience, for OSCP-like certification, there is no antivirus. Later on in the future, I will also make videos where I show how to bypass this sort of controls because it can be done. It just requires different and more advanced techniques. For our level of expertise, we can just do the simple commands. So I do it again. And notice that this time it works. It has downloaded it. Notice it appears on the desktop here. And I can click on it. I can click on it and I have my please subscribe file. So this is a first command. If you get a reverse shell within Windows and you want to download file, if you get code execution within Windows and you want to download files, this is the first thing you will do. And so we saw our first command to download files. This is a really simple command, and the useful aspect of certutil, it is that it is built in. So we don't need to pour it into the machine. It is simply there. It is a utility that Windows offers, and so it is extremely useful. Of course, if you try to execute it and it says access denied or it doesn't work for some reason, you can expect that probably the Microsoft antivirus is running, either the Microsoft one or someone else's. In that case, you need to do more advanced techniques that we will see later on in the channel, not in this series, but later on in the history of the channel. So this is the first command and it works on the command prompt on cmd.exe. So another utility that actually works in PowerShell, it is the invoke web request, which is abbreviated as IWR, invoke web request. So the syntax, it is the long name and the short name. Once again, really simple, even simpler than certutil actually. It is like this: invoke web request, or the shorthand IWR, -URI, -out file. So here put the URL you want to download, and here put the output of the file. That is where the file needs to be stored and with which name. So for example, let's download the same file with invoke web request here. Of course, this time we cannot do it on a command prompt. We need to go into a PowerShell. So we do this, so we go into the desktop. So we do here are the files, here I do the command, and I downloaded it again. To actually check it, we can remove it. We can also remove this file. I'll talk about that later. We can do this, and look, it appears again because we have downloaded it, and here is our please subscribe file. So that's the idea. Of course, this is something that I did not mention at the start, but it is important to mention. To do these experiments, we need to make sure that our host machine and the virtual machine on which Windows 11 runs share the same subnet. That is, there is network connectivity between them. In this case, for example, here I have the IPv4 address that is assigned to the Windows virtual machine, which is 192.168.122.227. And if I go here into my host machine, and essentially I can do ping, I can ping it. So I can ping it and it replies. So this is really important. I will not show how to configure this thing because it goes beyond the scope of this video. This video focuses on Windows reverse shells. Later on in a future video, I can talk a little bit how to configure it with quickemu and quickemu. So the idea, just to be really fast about it, is that with quickemu, I download the ISO, and then I manage the image with the Virt Manager and Quickemu, essentially. So this is the basic idea. This is the basic setup. So this is the second command that we can use. We can use the long version, invoke web request, or the short version, which is IWR. And of course, I suggest the short one, IWR. This is especially useful if you cannot copy into the machine, you have to type manually. So just to IWR, and notice here I'm removing the file, I execute the command, and boom, I have it once again. So we are able to download the command. So this is it when it comes to file transferring commands. We have seen two commands, certutil for command prompt and IWR for PowerShell. Of course, these are not the only ways in which you can download file. There are lots and lots of ways. These are the most basic one and the most trivial one that most likely you will find in any Windows target that you are trying to attack for, like OSCP, in ActiveBox, and in machines like that. So we can now talk about spawning a reverse shell. Now, even when it comes to spawning a reverse shell, I splitted the content into two parts. One when we want to spawn a command prompt, and another when we want to spawn a PowerShell shell. So that's the idea. The only thing that changes is that in the command prompt scenario, the shell that is spawned remotely is a command prompt shell. It is a cmd.exe. So how can we do this? Well, the idea is that we can download this binary, which is called netcat. It is the netcat version for Windows, the netcat binary. There are many places on which we can download it. For researching this video, I found the following one. So I found the following one, nc.exe. It is netcat for Windows 32 64-bit. It has a bunch of stars, so I suggest this project is just useful, honestly. And so how do we do this? Well, we can download it. So suppose that you have remote code execution on a system, then you have to do this command. So this command is the IWR. It is the PowerShell to download files. Here you put the raw URL of GitHub to download this file, and then here you put the out file. Of course, if you do this command, you have to make sure that you know the current directory of the shell process that is used to run this command. What do I mean? I mean that if I just run this command, for example in this shell, I know that currently I am in C users quickemu desktop because I have a graphical terminal which allows me to see this. However, if I have a remote code execution and I don't even know what is this current directory, it could be dangerous. So another way in which you can deal with this is just put an absolute path here in the out file. So for example, let's do this. Let's just download it. It takes a bit, and now we have downloaded the file nc64. We do a dir, a directory listing, and we see this nc64.exe. So that's the idea. We have downloaded the file. Perfect. So the next two steps to do for spawning a reverse shell are as follows. in our attacker machine, we have to listen with netcat, with our netcat, with the netcat in Linux. And then from the Windows machine, we're gonna connect also with netcat to our attacker netcat. But in the meantime, we will also spawn a CMD process. So the idea is that the attacker sets up a listener, the Windows connects to the listener and spawns a shell. And now the shell will be shared throughout the network, so across the network, and we will have a remote shell. So that's the basic idea. So how do we do this? We go here. Here we put essentially my listener. So I put my listener here. Notice I'm listening. It doesn't print anything. It's NC netcat. LMVP are the flags for saying listen on this port 7777, and V is for like verbose. And so this is the basic idea. And then on the Windows target, I call the ncat binary that I just downloaded. And this is really important. This is really, really critical. Here I have to put the IP of the attacker, the IP of the attacker listener endpoint, and the port. So here I have to specify exactly where my attacker is listening to. But once I specify it, it works. So we do this, we go here. Notice that here I need to be into a command prompt, here into a CMD. So I go into this CMD, not in PowerShell. I do this. Okay, let's copy it again. So this is the command. I execute it, and notice now what do I get? I get a connection back from Windows, and it is the prompt that I see. It's the command prompt. So here I can say, who am I? Here I can say, who am I? Give me all the privileges, and stuff like that. Notice that now I don't even see graphically, right, the Windows VM, because I've spawned a remote shell. So this is the way we spawn a remote shell within Windows. This is one of the many ways in which this can be done. And to review what we did, so here let's just quickly recap what we did. To spawn a reverse shell in Windows with the cmd.exe, there are 3 steps. First, we have to inject into the target machine, into the Windows box we want to attack, an ncat binary. And I suggest this one. I mean, it worked for me. You can see the code. So it's like any sort of reverse payload, you can use it. In this case, it's a simple ncat. I like it because it is simple. Of course, even this file can be picked up by antivirus software. So if you want to bypass antivirus software, you have to use different techniques once again. We don't care about that because we are trying to be simple here just to get foundational level understanding, and then in later series we can be more complex. So we download this binary, we set up a listener on our attacker machine. This is really important, which means that the box, the machine in which we set up this listener, has to have a public reachable IP address if we want to attack a remote target, right? In this case, it does not have to have a public IP. Why? Because the VM shares with the host a network interface, which is the 192.192.168.122 network interface. So that's the idea. Essentially, we set up a listener, and then from the Windows, we connect back to the attacker. So we connect to the attacker, and this -e flag says, when you connect, spawn a process, the cmd.exe process, and connect all the pipes, all the outputs, the inputs, and stuff like that from the process to the shell. So now, who is in control of the shell is actually the remote attacker, the one who started this listener. And then this is how we have our remote shell here. And notice here that it is stuck, this process, of course. If I quit here, if I do an exit, here also gets freed up. So that's our first shell with cmd.exe. Okay, now we are able to see how to spawn a reverse shell using PowerShell this time, not cmd.exe. Now for PowerShell, there are actually 2 ways to do this. The first one is similar to the cmd.exe, but I will also showcase a cool trick, a cool technique, which is to use a custom HTTP server. So this is like a useful technique. And the other way is by using this Python script that I will link in the description, and it will be available for you to use. And the way you use it is pretty simple. You just specify the IP and the port, it generates the payload, and you use the payload, and we will analyze and read together the code. So essentially that's the idea. We can start with the first method. So the first method works as follows. First, we download this script, this invoke PowerShell TCP script, this one, with wget. So here I will put all the link in the description so you can just check that out. So we're going to download it here. I do wget. So this time I'm actually downloading it in my machine, in the attacker machine, and we can analyze this script. This script implements a reverse shell in PowerShell. So that's the idea. So first we download the script. Now the script itself, however, does not spawn the PowerShell. If we execute this code, we are not actually getting the PowerShell itself. We are just defining this invoke PowerShell TCP with this function. So to actually make sure that this script defines this function and then calls this function, we have to modify it as follows. We do an echo of this line where, here we have to be careful, we have to specify the attacker IP and the attacker port in their respective commands, in the respective arguments. So how do we do this? Simple, we just go here, we do an echo of this. So now the file looks as follows. So now the file is changed, of course, because we still specify the function invoke PowerShell TCP, but then at the end, we actually call it with our IP and port. And this information has to be critical once again. So once we do that, how do we transfer into the Windows machine? Well, the idea is this: we start a Python server. So we start a Python server right here, right there, at the port 1337, and then we can download it and execute it with PowerShell as follows. So notice here what happens. So here I have started an HTTP server with Python with the command python3-m HTTP server 1337, and then I'm gonna start also an netcat listener. So I've started two things. Now I'm gonna do the following PowerShell command: PowerShell.c to execute this thing. This thing is gonna download the string and execute the PowerShell code. So what is this string? Well, this string specifies the endpoint of the attacker IP with the attacker port with the resource we want to download, which is the PowerShell reverse shell payload. So once we do this, notice here. So here I have terminal 2 and terminal 3, actually terminal 4. So I'm in the PowerShell here. I paste this command. When I execute this command, what's gonna happen is as follows. So the first thing is Windows is gonna go to my HTTP server, is gonna request for invoke PowerShell TCP. My server is gonna give it back to Windows. At this point, Windows, the PowerShell specifically, is gonna read the content and execute it, which is gonna trigger the reverse shell, which allows me to have a remote shell on the system. So we are now ready to execute this payload. So if we execute it, notice that we get an error. It says the string is missing the terminator. Why? It is because it is actually more simpler to just use this, the single hyphens instead of the double hyphens. So we just do single hyphen. I think it has to do with escaping. Like this one, it understands it is escaping, but this one doesn't really. So there's something wrong with that. I don't know exactly. Whatever, we'll just do the single one and it will work. So let's see what happens. Okay, something has happened. So notice, this thing here has triggered the HTTP server, which actually, notice here, it received an HTTP request. So this is the first thing that happened. The server replied back to the PowerShell process and says, look, this is the content. At this point, the PowerShell read the content, executed it, and this started the reverse shell. So now here I have a reverse shell with PowerShell though. Look at this, PS. So this is a PowerShell. I can say, okay, who am I? Who am I, priv? Let's delete, for example, delete file. Delete the file in the operating system. Actually, let's see if delete del file.txt. So now the file is gone because I've deleted it and stuff like that. We can do delete and c64.exe. I also deleted the netcat. So I can do commands from my PowerShell reverse shell, and this of course reflect back on the state of the system. So this is the second way, and it is the first for PowerShell, and this technique is really useful. So like I suggest you, because in one command we are able to obtain the shell. So we are able to unify in a single command the downloading of the payload and the execution of the payload. But this time we also have to specify the web server. So we specify web server, we specify the listener, we do this single command, and boom, we have our reverse shell. So this is pretty straightforward, nothing much to it. It is a robust technique. Okay, actually now I understand why there was a problem. And there was a problem because actually this command can be done by both cmd.exe and also PowerShell. Now, if we started from the cmd, however, we have to do this PowerShell-c, while if we started from PowerShell itself, we can just do this command. So let's go back to this. So what's the idea here? Let's say that I break this, so there's nothing here. So I go into the command prompt. If I am in the command prompt, I can actually use this code, the one before. And of course it works, but I did not get a shell because I was not listening. Now I got a shell. So now I got a shell as PowerShell starting from the command prompt. So from command prompt, I have a shell as PowerShell. Really important. However, if I start from PowerShell directly, I don't need to do this PowerShell-c. I don't need to do this wrapping. I can just do directly this code. So I listen again here down. I do this code. So I just copy this and boom, I have my shell. And of course, all these commands will be down written in the description, nothing to worry about. So this was the second way, as I said, and to finish off, this is the third way. So I have a script actually here, this is a script. It is this encode directory base64 PowerShell. So what's the idea of this script? First, let us use it and then let us discuss it. So we do Python 3 base PowerShell in our attacker machine. And it says, okay, look, I'm generating a payload for a specific IP and a specific port. If I don't specify any IP or any port, it generates a payload for the specific combination of IP and port. However, let's say that I need to specify different IP, like 192, 168, 122, 145, and a port 1234. I just do this and notice that the payload I get is different. So it generates a new payload depending on the combination between port and IP. Now, in my case, actually, we're interested in this one, the 777. So that's where we're going for. Now, once it has generated this payload, we can just copy it. We can go into Spicy here. We can exit this and we can restart here the listener. I can just copy into a PowerShell session, however, it has to be a PowerShell. I can just copy the output, this PowerShell, no IP, then etc. And notice here what do I get? I get a connection, and if I do something here, I get my shell. So it hides the terminal. I mean, it's still open, but it hides from the view. But here I still have my things. And for example, I can go into desktop, and I can say, please subscribe hello.txt. I can create a new file. It has been created. I do this. I can also start, for example, a calculator, and I have this calculator. I can do 1 + 1 = 2. Perfect. So this is the essentially third way of spawning a shell. It is the second way specifically for PowerShell. And so before finishing the video, I will just quickly analyze this code. So I will in the future do more Python scripting. For now, I just want to explain it without going to too much detail. So here we specify that this is a script that has to be interpreted using the Python 3 interpreter. Here are the main imports, the library we use, which is the sys library, which is used to obtain information about the arguments we use to call the script, and then the base64 to do base64 encoding. And if you're interested in knowing what is base64 encoding, I've made a video about that in the channel, so you can go and check that out. Then we define two global variables, the IP and port. These are the default IP and the default port. Here there is this gen payload function, and then here we have the main function. Here we have the caller to the main function, which has this sort of guard, that is if statement. These if statements make sure that the main code is only executed when we call it from the command line. So if we have to import this code into another package, main is not going to be executed. So this is really important. The main function, which is a global entry point, sort of. So we say, look, if I don't have enough arguments, I'm going to use the default one. Otherwise, I'm going to take them from the sysargv list. This is a list populated by Python that contains the different arguments. So for example, if I say this, the arguments are 192, 168, 122, 777, and also the name of the program is also an argument. Indeed, I start from 1 and not from 0. because 0, it is exactly the name of the program, essentially. So once we obtain the IPM port, either the default one or the one supplied by the user, I'm generating the payload, and then I just print it. The payload generation itself is a simple format string in Python, essentially, that takes all the string, which represents PowerShell code, and the only thing it replaces is the attacker IP and the attacker port. And here I just have to do some escaping to put the hyphens, essentially, because it is a string. So I prepare the string, and then the payload itself is prepared by base64 encoding the string. Why? Because essentially with this, I'm saying, look, decode this code and execute it. So this essentially is the idea of this code, and the way we use it is pretty simple. So let's say we want to use it. Here I put a listener. Here I put the code generation. I put the IP 127.1.777. I take this code, I put it here, I copy it, and here I have my shell. If I'm listening on a different port, I do 4444, for example. I just generate it for a different port, I copy it, and boom, here I have a different shell on a different port. So this is it for this video. In this video, I showed the basic strategies that you can use to spawn reverse shell in Windows. In particular, this has to do with the downloading of netcat and the execution of netcat, essentially. And then there are two for PowerShell, which have to do one with the downloading of this invoke PowerShell TCP script, and another with this custom Python script that generates a PowerShell reverse shell. So essentially that's the idea. I will put reference into the description, all the links, stuff like that, all the code. If you're interested for more, subscribe to the channel, share with like-minded people, and see ya to the next video of the series. Hi everyone, and welcome to this new video. In this video we continue the Windows privilege escalation series, and specifically we will show a really important exploitation technique which has to do with abusing the SeImpersonatePrivilege. So the basic idea is that most of the times if you have this privilege, then you are able to obtain a system administrator shell, which is a really important technique. So we're going to talk about Windows setup, the privilege itself, how to exploit it, and then I will leave some reference in the description down below, and I will show practical exploitation with a Windows machine, so a virtual Windows 11 machine. We're going to exploit it there. So I hope the video is interesting and useful. If it was so, please leave some feedback, subscribe to the channel, and just let me know what you think of it. So we can start with respect to the Windows setup. So we're gonna assume that we have a user, which is a really basic user. However, we're gonna assign to that user the SeImpersonatePrivilege. So for example, in this machine, in this Windows machine right now, I'm actually logged in as the quickemu user, which is an administrator, because if I do whoami all, I get all the privileges, and notice that here I have, actually here I do not have a lot of privileges because I'm executing this shell with mandatory level medium, so it's like it's limited with respect to what I can do. However, I can simply click on it, and I think I can just say terminal run as administrator. So I'm gonna give it the maximum integrity level, and now if I do it again, here I have all the privileges, and notice that I just belong. If I say net user quickemu, I belong to the group administrator, so that's it. However, I've created other users, and in particular I have the Leonardo user, and if I check Leonardo, net user Leonardo, this user is just a normal user. It doesn't belong to any specific groups, just to the user groups. However, he does have the SeImpersonatePrivilege because I edited the group policy. So if you want to assign the SeImpersonatePrivilege to any user, you can go as follows. You can go into the Windows system, then you say edit group policy, so this one, and then here you just open this up a little bit. You go into Windows settings, then into security settings, then into local policies, then into user rights assignment. And this opens up the following thing, where we have the policy and the security setting, which means to which like users and groups this policy is applied. The policy we are interested in starts with the I, so we go here, impersonate a client after authentication. This is the SeImpersonatePrivilege. So we go here, we go into properties, and notice here that I have added, I did add user or group, I write Leonardo, I do write check names, and I write OK. So I already done this, as you can see here, Leonardo. So this policy is already applied to Leonardo. And if we just log in as that user, so I log in as Leonardo, we will see essentially, so here I put a password, we will see that if I open a shell, I will get the SeImpersonatePrivilege. So here I am in the system, then I say console, I think, or terminal. Actually, let's do terminal. Let's do terminal, then I say run as administrator. Then I put the password of my account. And here I have a PowerShell. And then if I say who am I priv, notice that I have the SeImpersonatePrivilege enabled. So here I have this netcat, but I'm gonna remove it because we don't need it for now. So essentially this is the setup. We must start with this account, and by starting from this account, we're able to exploit this to obtain essentially administrator shell. Look, because right now we don't have an administrator shell. So what's the idea? Well, the idea is that this SeImpersonatePrivilege is also called the long name impersonate a client after authentication. It is a right to a user to a service account typically that is assigned, for example, to the web server account or to the database service account. And essentially, it allows you to have a program that runs on behalf of the user that authenticated to you in order to impersonate a client. So essentially, the idea is that we have a service. This service, of course, accepts clients, accepts like users, essentially. And of course, before the user is able to interact with the service, user service, there must happen some sort of authentication, some sort of like auth procedure. And typically in this auth, the user gives his passwords and authenticates. So the idea is that with this particular privilege, if the service that runs, if the process that runs this service has this particular privilege, what it can do is, after user authentication, it can impersonate these users. That is, it can access the token of that user, and therefore it can access with the user of the same privilege. Sort of like it can borrow the privileges from that particular user. And this is how it's used maliciously. An attacker with the SeImpersonatePrivilege can create a service, mislead a client into connecting to that service, and then impersonate that computer to elevate the attacker's level of access to that device, essentially. Now, if you're interested more in the details of how all of this works under the hood, here I prepare a bunch of references that I suggest you to read. In particular, there's this article, Fox Global Security, which represents sort of like the introduction of this privilege escalation technique from what I can remember and understand. And this dates back to September 2016. If there was something earlier, please tell me. But essentially in this article, they go through all of the detail that makes this work. But essentially the idea is that you force a privileged user to connect to your service and then you steal their token. So that's the general idea. If you want more in depth, maybe in the future I can do more in depth video, but the objective of this video is not to go in depth under the hood, rather is to understand how to exploit this. Because when you're doing, for example, the OSCP exam or other machines and you find a user with this privilege, then the exploitation part is quite easy. So you should just learn how to do it and then how it works under the hood. And so now we can talk about the exploitation. So assume that I have this privilege. Assume that when I do whoami priv, I have this SeImpersonate privilege. What can I do to exploit it? What can I do to obtain an administrator shell? So there are actually many exploits that you can use to exploit this thing, this privilege. In particular for OSCP, I just use the following two: print spoofer and god potato. Sometimes the print spoofer exploit worked, other times I had to use the god potato. Now god potato refers to a specific class of exploits called juicy potato, and then it like changed name throughout the years. But the idea is that god potato is one of the latest advancement of this chains of exploits, of this type of exploits, I would say. So you can either do this, you can use these two exploits. They work for me for the OSCP exam, so I think they will be fine essentially. Now, in all cases, however, we first have to do some setup. So in our local machine, we have to set up a local listener. So there's not much to it. We just write an encat and boom, we have our local listener. The next step instead is to download netcat in the remote machine. So the local listener we have to set up on our attacker machine because we want to do a reverse shell, and then we want to download netcat, the binary version of netcat, into the Windows machine we want to attack. I showed how to do this in the previous video on the reverse shells in Windows, but here essentially is the command. We use IWR in PowerShell. So we go into our shell, here with the user Leonardo, we go into the desktop, let's say, and then here we can just put the command. We put the command, we download it, and here we have our binary, netcat binary, perfect. Now, how do we use the virus exploits? So here I show how to use the sprint puffer, the GotPotato net2, the GotPotato net4, and the GotPotato net35. Now notice that for the print spoofer, there is a single exploit that, however, you can download for both the 32 version and the 64 version. This is like with respect to the architecture of your processor. If you're running in 32-bit or in 64-bit, and specifically 64 is also called x64, and this is x86, 32-bit version. How do you know which version you're running? You can do a system info, and it gives you information about your processor, and among this information you find if it's 32 or 64. In this case, what we see here, we see x64, so this is a 64-bit processor. Nowadays, most processors are 64, the ones that were built somewhat recently, so typically you want to do a 64. So we can download the exploit. It's really simple. We can download the exploit, and then after we downloaded our print spoofer, to test it out, we can call it like this. So we do print spoofer -c, and here we put the argument that we want to be executed. So in this case, actually, it's not in C temp netcat, but it is in C users Leonardo desktop nc64.exe. Here we put the IP address we want to connect to. In this case, it is not this one, but it is 192.168, I think 121, because this is the network interface that the machine is running on. If I do an ipconfig all, here I get the network interface. It's 192.168.122, and then .1 here. And then here I put the port that I'm listening on, 5555-ECMD, to execute the CMD command. And then here too, if I do this, I think it's not going to execute because it doesn't understand the binary essentially. So like if I do this, can I give me an error? Maybe yes. And instead what I have to do is I have to do //. So I have to // to say the binary in this particular directory. So I execute this. Notice that nothing is happening. So here I'm not receiving a shell. Why this is the case? Because sometimes these exploits do not work. So this is why I'm not only showing you print spoofer, but I'm showing you other exploits such as the GotPotato one. So since the print spoofer exploit did not work, let's try with the 3 GotPotato version. And notice here that I have net2, net4, and net35, net3.5, because these are the different version of .NET. So technically, if you want them to be ordered, we would just put like first .NET2, then 3.5, and then the 4 version. So that's the idea. We have different version for different .NET version. So let's start with the 2, the earliest one, the oldest one. We download the exploit. Of course, if you download this exploit with the antivirus turned on, with the active protection, with the active scan going on, Windows will recognize this because we did not apply any obfuscation and packing strategies, so it is clear and it is able to understand it is malicious. And then we can execute it as follows. So we put the name of the executable -cmd, and here we want to put the program we want to execute, and this program simply starts a reverse shell. So we executed it, and it says, look, you need to install the .NET version. And of course, we don't need this because we cannot install this on a victim target. So it means that we don't have this .NET version, so we cannot use this. However, there are others like 3.5. We can try with the 3.5. We can just download it and we execute it the same, essentially. So let's execute it. Once again, it requires us to to download the .NET framework, which means that we don't have this version. And we have the .NET 4. So we downloaded it, we executed it. And notice now, this time it's not asking us for downloading anything. And it actually spawned a shell here down. It did a bunch of stuff. And notice current user NT authority system. And indeed, the new shell that we have just spawned, if I say UMI priv, I am all of these privileges because UMI is NT authority system. So essentially, I was able to spawn a shell as administrator of the machine. I'm in all this group. This is my SID, and I have all these privileges. So at this point, I can go into the administrator. Typically, for example, in OSCP, you go into user, administrator, desktop, and here, actually, I don't even think there is an administrator user here. The administrator is the quickemu, so there's just quickemu. You go into its desktop, and in the administrator desktop, which in my case is the quickemu, you can find the flag of the user and do the machine, or of course in a real assessment, now you are able to execute code as administrator. You can enumerate much more the surface attack, you can extract critical assets, and you can put all this stuff into your penetration testing report. So essentially this is the idea. And it worked after a bunch of tries because we have the .NET 4 version here apparently. So this one triggered the exploit, the previous one did not. So the idea for exploiting the SeImpersonatePrivilege is pretty easy. You go into the machine, you do a UMI priv, you check that you have this privilege and that it is enabled. And here I also show how to set it up by going into the edit group policy. And you just follow this bunch of UIs and then you add this privilege to your user. So if you have this privilege, then you can exploit it. There are many different exploits going on in the internet. I suggest the following 4 essentially. One is the print spoofer. You just download the binary and you execute it as follows. Of course, remember to change the path where you have the end cut, the IP and the port. And then you have 3 versions of GotPotato depending on the .NET framework that is installed on the server on the victim that you're trying to attack. So we have version 2, 3.5 and version 4. For each version, you just download the exploit and you execute it. It's pretty simple. You just try the various exploit until you get the one working, or maybe you can enumerate the system better to understand which version of the framework you're running on. And actually, if you don't want to try to download all these various binaries, the .NET 2, 3.5 and 4, to quickly go to the version that you installed, you can execute this command, reg query with this HKey local key, which queries the local registry of Windows, and it tells you the net framework installed, the version of the .NET framework that you installed in your system. Notice, for example, in this case, I have the version 4, which means that by executing the net 4, this one, the GotPotato net 4, I'm able to obtain code execution. So I'm just gonna take this and I'm gonna put it in the notes, like to understand the version of .NET with the following command, and then and use the relative exploit. So the exploit here depends on the specific version of the .NET framework, which can be 2, 3.5 or 4. And to finish off, here are all the references that I used to prepare for this video with the relative GitHub for the exploit. I thank all the authors for it, and that's it. I hope the video was interesting and enjoyable. If it was so, please leave some feedbacks in the comment, subscribe to the channel for more content, and keep following for the continuation of this series. Hi everyone, and welcome to this new video. In this video, I continue my Windows Privilege Escalation series, and specifically in this video, we will talk about cross-compilation, which is a technique, a very useful technique we can use to compile programs using a Linux operating system and then to run the compiled binaries directly in Windows. This is very efficient when we want to develop a reverse shell, for example, or any kind of software that we want to run on our target on Windows machines, like for example a service program or anything that we need to run, like any executable. With cross-compilation, we can compile the executable on our Linux machine with our Kali setup or with whatever distro we use, and then run the compiled binaries directly on Windows. As always, I kindly ask of you to subscribe to the channel, to share this video with like-minded people, and to give me feedback if you find this video useful. If you think I missed something or I explained something wrong, just let me know, I will try to improve. And that's it. Having said that, you can now enjoy the video. Thank you very much for watching. So, first things first, what do we mean by compilation? Because to understand the idea behind cross-compilation, we need to review, we have to have solid grounds on the idea of compilation. Now, when in computer science we use this word, compilation, we are referring to a very specific activity. So with compilation, we refer to the act of translating. So we are translating one language into another language. And specifically, we are translating a source code language, so a high-level language, into another language. And the characteristic of this other language is that we are able to execute this other language directly on a given CPU architecture on a given operating system. So essentially the idea is that we start from a source code. This is the high-level language. For example, the C programming language represents a typical source code. Then we use a compiler like GCC. So the compiler is the tool that performs this translation. And then we obtain a binary program. Now this binary program wraps the machine instruction that are used to execute the program into sort of like a wrapper, a data structure wrapper that our operating system understands in order to load the program into the memory and to actually execute it. This means that the binary contains part that is dependent on the CPU architecture and on the CPU, which is the instruction part, the assembly instruction part, and another part of the binary is actually depending on the operating system. So of course, compilation can be a very complex process involving multiple stages. Here I showed it simple, but in actuality it can be very, very complex. The general idea, however, if you want to abstract a little bit, is that compilation allows us to obtain binaries. We start from source code and we obtain a binary. And binaries are compiled for specific environments. So here, what do we mean with the word environment? We mean a combination of the hardware architecture, and specifically the CPU that our computer runs, the operating system, and eventually other user space program and configuration. So the most important one are the hardware architecture and the operating system. This means, for example, if you download a program, this program typically has many different builds, has many different binaries. You want to download the program that matches your hardware architecture, which means your CPU type, and your operating system. Like for example, you can have x64, which is the most common architecture, one of the most common architecture with Linux. But you can also have ARM with Linux. And the difference is that the architecture of the CPU is different between x64 and ARM. It's a different architecture. So if you compile a binary for an ARM, it's not gonna run on an x64 CPU. So this is why it's really important to understand that when we compile, we are sort of like preparing the code for our specific machine. So let's show a simple example of compilation. Here I have a source code, and here I have an hello.c. We can actually remove this shell because we're going to talk about that later on. So here I have this hello.c. Now this hello is actually very simple. We can forget about this command for now. Later we will use it to cross-compile. So this hello contains the definition of the standard C library that contains the function printf. We have a simple main. This just prints hello world. So when we compile it, how do we compile it? Well, we use the compiler GCC. We do GCC hello.c -o to specify the name of the output. I just wanted to call hello, that's it. I just compile it, it's very fast. And now if I have ls, I have this green file here, which is the executable. And this executable, if I analyze it with the command file, I do file hello, and it tells me like, look, I am an ELF 64-bit Pi executable compiled for this AX86-64 architecture. And I'm also dynamically linked. So it means that it requires to run libraries that are found on the operating system, in the file system of the operating system. So this is the way we compile it, and the way we run it is just we do /the name of the program. We run it and it says hello world. So this is all very simple. And so with this very simple example, we showed how to compile for Linux. However, this is not what we are trying to do here. We are trying to use Linux to write the code and to compile it, but we don't want to run it on Linux itself. We actually want to run it on Windows. Now, in the previous video, I showed how to use netcat to transfer files. So we can use netcat to transfer some files. So let's try to transfer this executable bit. This executable is hello, which is an ELF binary. So we're gonna do netcat, and I'm gonna just transfer it like this. And then I'm gonna connect with my server to the port, and I'm gonna write hello.exe. So I have a connection here. So I have downloaded it essentially. I can just check it that it's here. Hello.exe. If I try to run it, of course, it's not gonna work. It's gonna create compatibility problems because Windows is gonna tell me, look, I cannot really run this binary. It's not a binary that I understand. This is because the binary itself is structured in a way that is not understood by Windows. And this is because the machine code that we use, even though the machine code doesn't change, what changes is all the loading of that machine code, is all the wrapping of that machine code. Sometimes also the machine code changes between an operating system and another. This means that even though we might have the same CPU, so like you might have the same CPU between two different computers, if the operating system changes, you need to employ a different compilation procedure. This translation has to be done differently. So how can we cross-compile? So the idea of cross-compilation is very simple. In cross-compilation, we want to compile on one machine, say M1. So this is where we compile. And this machine has a specific configuration of hardware, which specifically is the CPU architecture, is the hardware architecture, of operating system, OS, and of other software, like libraries and stuff like that. So this is where we want to compile our program. And then we want to run it on a different machine. We want to run it here. And these machines are different. They are very different. Maybe one runs Linux and the other runs Windows. So we need to solve this problem. The idea of cross-compilation is I compile in the current environment, so in environment A, but I want my binary to run in environment B. And getting familiar with cross-compilation is extremely useful because when we want to do red teaming for a client during work or like for your personal research, the idea is going to be that the environment of the target is going to be very different from your current environment. So you want to study the environment of the target and you want to cross-compile for that specific environment. If it runs a specific version of Linux, of Windows, if it runs a specific hardware architecture, you want to make sure that the binaries you drop on the target are able to execute on the target and they do not create compatibility problems. So the cross-compilation is a good technique to have in mind. So to finish off the video, let's see now a practical example. So how can we compile something that actually runs on Windows? So we can click here. So how can we do that? As we saw, in Linux, the binary format used is the ELF format, and ELF stands for Executable and Linkable Format. It's just a short name. There's nothing special to the name. What's special is about the structure of the binary. Now, what if we want to compile a program that runs on Windows? Now, the format that is used in Windows is called a PE, which stands for Portable Executable. Now, these two methods of saving the binary that will run on the CPU, of course, they roughly contain the same kind of information because they solve the same problem. However, in computer science, it's not what you're trying to solve that is important, but rather how you go and solve it. It's the specific structure that changes between these two different formats, which means that if we want to compile to produce a PE, a portable executable, we have to use a different compiler. So consider the following code. This is the simple hello world that I showed. Our objective now is to run this code not on our Linux box, which is easy to do. Just use GCC and you're good to go. But rather, how can we compile on Linux and then run on Windows? So that's what we're trying to understand. If we simply compile with GCC, we obtain an ELF. So like the executable and linkable format, nothing special there. We cannot execute this on a Windows machine. Now to actually cross-compile, we need a different compiler chain. We need a different toolchain technology that will allow us specifically to cross-compile. And this is the MinGW W64 GCC. So we install it with the package manager of your distribution. I'm using Arch, So I'm using pacman, so I use pacman. And after we install this package, we have access to 2 new compilers. Actually, to a lot more than that, but for now, let's just use these 2. So this one, x86-64-W64 main GW32 G++ for 64-bit architecture, and this one also for 32-bit architecture. So GCC or G++, depending if you're compiling C++ code or normal C code. For us, it's kind of the same. It doesn't change too much because we are simply writing C code. So depending on your target architecture, you can compile it for this kind of architectures. So with this, we obtain, for example, let's do the 64 version, because my machine, how do I know which architecture runs on my machine? Well, I did the first video of the series that showed us the command systeminfo. This command systeminfo can be used to obtain information about the system. Specifically, to understand the architecture, we go into the system type. It says x64 base PC, it means that it runs a 64-bit architecture. If it did x86, then it would imply a 32-bit architecture. So 64 is for 64-bit architecture. So that's the idea. So let's use this. So let's go here. Let's open a terminal here. And let's try now to compile an hello.exe. So let's do it like this. Notice here I have hello.exe. And also I use the flag static. So if I do a file on this, it says it is a PA32 plus. So it is a portable executable for 64-bit architecture for x86-64 for Microsoft Windows, 20 section. So now let's try to send this to the Windows machine and let's try to see if it works. So I do netcat as a listener, and then here I just executed the netcat here with the IP address of the machine with hello.exe. So of course now I got the connection. Here it says connection from etc. So I can just quit it, and now I have this hello.exe. We execute it, and notice I get hello world. So I'm able to execute the code. Now with respect to the static keyword, sometimes without the static it doesn't really work. I believe is when we're talking about static binaries and dynamic binaries, what's the idea? The idea is that a static library does not have any dependencies with the outside system, while a dynamic library does have dependencies, meaning that when you compile a dynamic library, they don't put all the code in the binary, in the final binary. They rather put references so that your binary has references to other files in the system. For example, in Linux, these files are called shareobject.so. So for example, the first file that we compiled, this hello, is actually a dynamic executable and is dynamically linked with the standard C library. And I can see that because if I do the command file, it says dynamically linked. And if I execute the command ldd on hello, it gives me the path it depends on. So it depends on the user libc.so and the user lib64 ld linux. This is the loader used to actually load all the other stuff. So this is essentially with respect to the Linux binaries, however. Now to the Windows, sometimes it doesn't work if you don't put static. So if it doesn't work for some reason, try to put static and maybe it works that way. So let's try without static to see if it works. Just a quick test. So we put hello.exe here, and then here we can just use the previous command to actually re-download it. So here I have downloaded it, perfect. So I can just execute it again, and it still works. So in this case, it's not really needed to add the keyword static. Now, having said that, however, this simple hello world example is not really that interesting. So I want to finish the video by showing a more complex example, a more sophisticated example that essentially spawns is this code that I'm going to describe in a second, that essentially can be used to spawn a reverse shell. And actually, I did not finish to write this code the way I wanted to, because I'm gonna leave it as a sort of exercise for those of you interested. In the future, I'm gonna finish to write it in a way that is more useful, let's say, because there are some limitations of this file, but I just wanted to showcase it in this video because we are talking about cross-compilation. So the idea is, let's build a binary that will spawn a reverse shell in PowerShell when we give it an IP address and a port. So like our own custom reverse shell. So that's the idea. Now, how do we do this? Well, first of all, let's try if this works. We can try with this flag, with this compiler flag. So we say the name of the script shell.c. We do /static to have a static binary so it doesn't depend on other libraries. Then we compile it with this specific library because we are using some Windows sockets API. And then we put the output of shell. So this also to showcase how it looks like when you build a little bit more complex script than a simple hello world when it comes to cross compilation. So now you have to cross compile against Windows libraries. But this toolchain allows you to do this with this flag -l, which says link this library. WS is like Windows stuff. So let's see this in action. So let's compile it first. So I'm gonna compile it. I'm gonna wait a bit. Perfect. I have my file shell.exe. Perfect. I'm gonna write it on netcat shell.exe. I'm going to download it. So let's do this, but now it's shell.exe. So I have connection. I've downloaded all the bytes. I mean, we're not talking about many bytes, so it's like super fast. Now, at this point, how does this shell.exe work? Let's try it out. So if I just execute it, it's gonna ask me, okay, give me an IP address and give me a port. And when I give it an IP address and a port, the script is gonna generate a PowerShell here code, and it's gonna use this PowerShell to actually connect. So here I'm gonna put a listener. Actually, let's do it directly in here. So I'm gonna open this and then I'm gonna open this. So let's gonna put a shell here listening on port 7777. So how do I use it? Well, I'm gonna put my IP address. So this is the IP address of the host. Here I'm running a quickemu machine. So I'm gonna put the IP address of my current host, which is 192.168.122.1. And then I'm gonna put the port, which is 7777. I execute the program with these arguments. It's gonna generate the payload, the specific payload, and then it's gonna execute it to actually obtain a reverse shell. So here I have a reverse shell with PowerShell, and I am the quickemu user. In the file system, so like when I, let's say, close this thing, the binary also is gonna close, and in a file system, I have written this PowerShell script. And this PowerShell script contains exactly the specific reverse shell with the given IP address and port. If I choose another port, so let's say that I have a different target, so I want to move into port 888, I can just call the script again, but with saying 888, and it's gonna connect to this other port. So in this case, it's 888. So this essentially is the idea of how you use the script. So WMI once again is quickemu, and the host is the quickemu virtual machine with quickemu. So this is basically the idea. Now, how does this script work? So we're gonna read it together to see how essentially I wrote it. And also at the end, I will showcases essentially the places of the script that I want to improve, because there's some work that needs to be done. So this script is really simple. We're talking about 65 lines of code. So we can start directly from the main routine. Here in the main, I check that I have enough arguments to do the proper work. Specifically, I'm interested in the two arguments, which is the IP address and the port. If I don't have those, then I just cannot work. So I just exit the program immediately. This is gonna stop the program. Before doing that, I print out in the standard output a typical usage message saying, look, you use this program by calling the program itself with the IP and the port. And remember here that argc initially has the value 1 because the 0 element, which is the first element of the argv array, is the string that represents the name of the program. Like in this case, for example, let's say that I close this and then I just call this shell.exe. The first program is the way I call the program. So //shell.exe. So this is why I need to check if this is less than 3, because if it's less than 3, it means that I have less than 3 arguments. I need exactly 3 arguments. The first one is the name of the program, the second one is the IP, the third one is the port. If I have more than that, I don't care. I just take essentially the first 3. Then I read all the input, and specifically I save the pointers. So this C syntax can be confusing, but the idea is that I deference the first value because the first value actually contains the first pointer, and then I increment argv because here essentially the idea is that argv is an array of pointers. So here I have essentially 3 pointers. So 1, 2, and 3. Now the values of these pointers, they point to memory addresses, right? So the value of the first value of argv is the first pointer. The second value of argv is the second pointer, and so on and so forth. So I deference the value, which means I access the first value of argv. I can also write it as argv of 0, and then I do plus plus to increment argv, to point to the next element. So essentially it's sort of like I do this, and then the next time I'm gonna reference argv, it's gonna be argv of 1. This is just like a quick way to do this. Working with pointers can be dangerous, but it's just a quick way to read and validate the input. And also, if you have improvements on the way I write this thing, feel free also to tell me, because it can be useful. Then I just print out the arguments that I read, so the IP and the port. Now, for now, both IP and port are strings, and then I start to validate the input. So an interesting thing is that if, for example, here I put something that is not an IP address, it's gonna, for example, in this case, I have to put two things. It's gonna say, for example, look, this is not a valid IP address. I cannot work with that. So I'm not even gonna try to spawn the shell because I don't want to do that. So there is some validation, input validation going on. If instead, for example, let's say I put something like this. Once again, this is not a valid IP because a valid IP has to have 4 decimal numbers, each one between 0 and 255 actually. And like, for example, in this case, it's gonna work. It's gonna spawn a shell for this particular endpoint. Of course, no one is listening to that endpoint, but that's a different story. And I also do validation with respect to the port. For example, in this case, I cannot have negative port numbers. Since I know the domain that I'm working with, so an IP address and a port, I can apply proper validation routines. And this is actually a secure coding way of writing code. It's like writing code in a secure way. Means that I know the domain of values that my input can get. I make sure to check that that value, that domain is respected. And anytime I go outside of that domain, I throw an error. This is how our secure code should be. Of course, people don't do that in real life. This is why you have vulnerabilities. If everyone wrote code like this, most of the vulnerabilities would simply disappear. So we sort of like are in this state where it's okay also if you don't validate, because then you have vulnerabilities. So that's the idea. Now, how do we perform this validation? For example, for the validation of the IP, which is a little bit more complex, I actually refer to the inetPython call, to the inetPython function, which is made exactly to validate an IP address. So it returns 1 when I have a valid IP address. It returns something different than 1 in case of failure. So here I just call the window function inetPython, Python. So that's the idea. So I just call another function. I don't actually implement the logic itself. Also for the validate port, first I transform the value into an integer, and then I check if this integer is greater than 0, and also if it is less than 65,000, and this particular value, so 65,535. Why is that? Well, this is because port numbers, port, have 16-bit of space. So it means that they are bound between 0, like greater than 0, so like between 1, and 2 to the 16, I think minus 1, I believe. So let's do a quick computation on what is 2 to the 16. I think it should be that value, 65,536. So we go into Python 3, and then we say, we can actually do 2 to the 16 like this, and then minus 1 is this particular value. So this limit is given by the fact that a port has only 16 bits of space, so this limits the value. If I have a value that is not a number, the atoy function will actually return a -1 as an error code. So by doing this check, I'm also checking that the value itself is a proper number, and it also is included in this range. So if the validation is okay, I return this value, success, which has defined as 0, otherwise I return failure. I mean, here it doesn't really matter, they're just labels that are useful to have. So after I validate the input, I'm actually gonna generate the payload string. So here I'm gonna generate the payload string. So the payload string is this payload. It is an hard-coded string. This is a format string in C. However, it has two format variables, which is the IP address here and the port number here. So once I have the input, I can just sort of like instantiate that template with a specific value that the user gave me. And I do this with the function sn printf. So of course, when you deal with function in C, you always have to be careful with how you deal with memory. So I made this computation, which should be correct. If it's wrong, also tell me. And the idea is that this is gonna compute the final amount of space for the string once I put the IP address and the port. So I allocate the memory in the stack, and then I sort of write the final string, which is taken from the template. After the template has been instantiated with the IP and port value, I write it into the output, and I also like write it at most this particular length, so I don't go over that particular length. So in the worst case, I'm not gonna overflow the memory, I'm just gonna have a payload that doesn't work. And then, for debugging purposes, I just print out the payload. Finally, I write the payload into a file, very simple, and then I execute it with a very simple system. So that's essentially the idea of the thing, and that's how it works. Now, what can we improve on this design? Actually, a lot. For example, I want something that every 30 seconds or so calls back the shell. This can be useful when debugging maybe an exploit and you want constant connectivity on the target. It can be very, very useful. So another thing that I want to do in the future is make it periodic, like a timeout. So every 1 minute, every 30 seconds, it calls me back. So of course, this would increase a lot the noise that the shell makes. And right now, the shell does not try to hide itself. It's a very noisy reverse shell. So it's not really that good to avoid antivirus and other software like that. This is because, first of all, I just use a simple payload without proper obfuscation, without methodologies to hide the malicious intentions of the software. And most importantly, I also write this shell to the file system. Now, typically, this is like a horrible operation to do if you want to hide what you're doing. In this case, I'm not interested in hiding. A better approach would be to actually execute it directly on the RAM, directly on the memory of the process without hitting the disk. So this is another thing that can be improved upon. But in this video, I just wanted to showcase the code to show what it means to, let's say, compile a not trivial, also not too complex program, like a middleware program using cross-compilation techniques. And if for example, I forgot this -l flag, this compilation would not work. So let's go here. So here I have the shell. Let's copy this and let's remove this, because it's gonna say, let's see, it's gonna say, look, you try to use the inetPython Python function here, but I don't have the actual implementation. I don't have actually the reference of it. So like, I cannot use it, right? So to actually use it, you need to put this flag. Now let's do a last experiment here. So I'm gonna remove the static flag. So let's remove the static flag. And let's see now if I just transfer this shell.exe. So I transfer this, I go here, and I do 64.exe. I'm gonna do 1221, and then I'm gonna do shell2.exe. So I have connection, I have downloaded it. Let's see if it works. Shell2.exe. Okay, it works. So even in this case, the static flag was not really necessary. Maybe it's not even needed that too much. I think it depends on the library you use, essentially. But in case, if you cannot compile it, if it doesn't work, maybe try to add the static flag. If it doesn't also work that, it depends maybe on the specific setup. So essentially, this is it for this video. I hope it was interesting. And with this technique, which we're gonna use throughout the course, we are able to compile binaries that we can then run on Windows. And the cool thing is that on Linux, it is much easier to develop and to actually compile the software. And then of course we can test it on our Windows box for like understanding the effect that particular program has. So it's a very, very cool technique to do cross-compilation. It's useful also during active engagements, because you cannot like compile directly on the machine. Compilation is a noisy activity. You want to hide that. So you want to compile on your machine, on your environment, but you want to make sure that the artifacts you produce, like the binaries, are able to be executed on the target environment. So the first step is to research the target environment and then to understand the right cross-compilation toolchain that allows you to target specifically that environment. So this is it for this video, and to the next video where we continue the Windows Privilege Escalation series. I hope it was fun. Subscribe to the channel, share this with like-minded people, and to the next video. Hi everyone, and welcome to this new video in which I continue my Windows Privilege Escalation series. Now specifically in this video we will analyze Windows services. So we will introduce them, we will talk about what are Windows services, how can we manage those services? So with commands, both CMD and PowerShell commands, and then I will show how we can add a new service, our own specific service. And in this video, of course, I will use a virtual machine to explain all this stuff and to make practical example of this stuff. Now, why Windows services are important? Because as we will discuss, they are an extremely interesting attack surface area. So, if you want to do privilege escalation on Windows, you must enumerate the Windows service surface area, and you must understand if there are misconfiguration, if you can exploit those misconfiguration to obtain privilege escalation. Now, in this first video, I will just describe the services without giving specific exploitation techniques, because those will be the topics for later videos. So as always, I hope the video is interesting. If you have any feedback, please leave it in the comment, subscribe to the channel, share this video with like-minded people to help me grow, and enjoy the video. Let's start our discussion by introducing the idea of the functionality. Now, when we want to exploit something, first we must understand how it works. And this is something that I often repeat. I also repeated in the Linux privilege escalation. Before showcasing specific exploitation techniques, we needed to have a good overview over that specific functionality. Now, what are Windows services? Well, Windows services are essentially special processes. So they are processes that run like any other code runs in the system. However, they are special in the sense that they are treated a little bit differently. Now, specifically, Windows services can execute without user interaction. In the Linux land, these are also called daemon. It's like system services that run in the background, they set you up stuff, they prepare the services for the user to use and stuff like that. So they run in the background without user interaction. And sometimes they continue to execute even when they are not, even when the user is logged off, or even when the user is not using the machine. As soon as the machine boots up, a lot of services are enabled. So they are enabled to be started at boot time, essentially. Like after the operating system has taken control in the boot operation, when the operating system starts, it activates the startup services. So they usually run in the background when the machine is booted. Now we can manage the services through a graphical interface which is called the Service Control Manager panel. And this essentially, we can access this in a Windows machine. We just type services, and here we have essentially the control panel, which lists out all the services. It provides essentially the status of the service, which means those that are running, the description, and the name of the service. And then it's like it says the account, logon as local system, network service, and stuff like that, and then the status type, like manual, trigger start, automatic, delayed start, automatic, manual, if it's automatically activated or not. So this is like a first introduction. However, what I like to do is use the command line, because it's much faster. Also, if you get a reverse shell into a Windows box, you cannot access this graphical panel. So this one can be useful when you want to debug something with the services on your machine or on a testing machine. When you have a reverse shell on your target, you usually want to use the commands, which we will see in this video when we talk about managing the services. So there are different types of services, and here we use the word type. So what's the idea? For example, we have local services, we have network services, we have system services, and also we have third-party application services, like I install an application. The application downloads some binaries, maybe a client application, and also some services that is running in the background. And maybe the client interacts with the service and so on and so forth. So that's the idea. Now, what's the difference between these types of services? Well, the idea, as we said, is that a service is a process. Now, when user runs, each process has to be associated to a user account. To a user, has to have the concept of a user, to also introduce all the privilege check, all the permission check, all the security profile, essentially. So the idea is that this kind of user accounts are specifically made to be run only, to be used only for the services. So you have specific accounts that are only used not by the user of the system, but by the services that run on the system. So you have local service accounts, network service accounts, and system service accounts. Now the difference is that, like for example, system services have access to all the resources of the machine, so they are dangerous to expose as a service. Like you don't want your account to run, you don't want your service to run as a system service unless it's really needed. So that's the idea. Depending on the type of service, when we exploit them, we can get more or less privileges. And so with this viewpoint, it's clear to see that it's gonna be much better for us, the attacker, and much worse for the system that we exploit a service running with a system service account rather than a one running with a local service account. So they offer a really interesting attack surface area, because depending on how they are configured, depending on the file permission on the underlying binaries, depending on the libraries that are dynamically loaded when the service starts up, we can have different attack techniques, we can have different explanation techniques, and so they offer a rich attack surface area that is not too difficult to enumerate. So it's rich, it means that we can obtain a lot of stuff with that, especially in testing machines, like for example in the OSCP certification and other sort of CTF-like boxes, but in general they are not too hard to enumerate. So anytime you are testing the security of a Windows system, services is an extremely useful attack surface area to analyze, and this is why we are gonna of course analyze it. So having introduced the idea of services, we can actually see, okay, how do we manage them? Through the command line, of course. So here follows a list of useful commands that can be used to interact with services. So here the word is interact. So, and it means to enumerate services, to manage services, and so on and so forth. For example, one of the first command, show the current services, get service with PowerShell. Pretty simple. So this is the list of service. Let's open a PowerShell and let's write get, and then here I have to change the language to Italian, get service. And here I have a list of service, and here it says 3 columns, very simple information, the state, the name, and the display name. So really not that much, just some introductory like commands. Now, of course, we can extract more information on this. For example, we can extract information regarding, like we can have specific information. So let's copy that command. Let's copy that command. It's like, okay, get service again, but now we want to select the display name, the status, the service name, and what my specific user can do with the service. So this can wildcard. So we do this, and we have a more detailed information. Specifically, we can say, for example, can stop, true. It means that I can stop the service, and this is the display name, window, push notification, system service. It is running. This is the technical name for the service. So the display name is what is shown in the service box. For example, let's try to find this WPN service. So I go into this and I say W. Actually, this is called Windows push notification. So probably at the end, W. Window push to install, no? So let's see. Push notification, Windows update, push notification system service. So this one, essentially, push notification system service. And if I click here and I say properties, I have the service name, which is WPN service, so WPN service. So this is like another view of the same information, but through the command line. For example, here I can say stop, here I can change automatic, manual, and so on and so forth. And here I can check other stuff. And so with the first get service, we just show a list of current services, and then we were able to extract some information from the various services by selecting the various properties, essentially display name, status, service name. Now, one extremely important property of each service is the binary path. Now, why is this important, and what is the binary path? We can obtain this information with the get sim instance command, and specifically here we are obtaining the binary path for all the services that are currently running, because here we apply a filter at the end where object state like running. So this is very useful when you enter into a machine and you want to get a quick overview of the various services. You can just use this command. So let's use it. Notice what we get. For each service, here on the left, there is the service name and the state. I mean, it's running, so we can also remove that, but whatever. And then here we actually see the binary. For example, C, Windows, System32, svc host.exe with a specific parameter -k, network service -p. And we have this svc host many times with the different arguments essentially. For example, we have a spice agent, which I use to virtualize essentially Windows. I have C program files spice agent vdservice.exe. So I need this service to have the various screen resolution and stuff like that. So the graphical services that deals with that. We also have the lsas.exe, which is very important too. So as you can see, essentially the binary path is the executable, so the .exe that is linked to that service. When we start the service, we are just starting this binary, the associated binary. When we stop the service, we are stopping that particular binary. Because as I said earlier, services, they can seem abstract, but they are just processes. They are treated a little bit differently, but at the end of the day, they are processes. And of course, the idea is that each process, before becoming a process, it actually starts from a program. So the program, which is also the binary, which in Windows is the .exe, is just a static description of the process. This then gets loaded into the machine, into the CPU and into the RAM and into the various elements of the machine, and then we're able to have the process. So the process is the running the running program as it evolves dynamically over time. But at the end of the day, to each service there is associated a specific binary. And depending, for example, on the configuration of this binary, depending if we can overwrite this binary, we can have different exploitation techniques, which will be analyzed later on. But this is just to say that, for example, the binary is a really critical aspect of services. For example, balloon service, C program files, virtuwin balloon blnsver.exe. So this is the service name. And we can get the binary path with the following command. Of course, here I put the filter on where it's running, so let's remove this. And I would say let's also remove the state because it's okay. Now in this case, it could be useful to have the state because we want to remove the filter. So we want to select also the services that are not currently running. So I copy this, I go into Windows and I paste it. And here I have also the one that are, for example, stopped. So these are all the services that are installed onto the machine, stopped running and so on and so forth. So that's the idea. Very useful commands. Now all the commands so far were with PowerShell. Now we will see the sc.exe, which is a binary. You can also use it with CMD, so with the command prompt, and you can use it to do a lot of stuff with services. For example, another way to get a list of all services, like we did in PowerShell with the get service, is with this sc.exe query. So this thing we can execute it on PowerShell and we get this output. So as you can see, we have service name, we have display name, and then we have the type, the state, the exit code, service exit point, checking point, and stuff like that, like other information. But you can also open it with command prompt. So if you can only run CMD, you cannot of course do this get service because CMD does not understand this. However, you can use the sc.exe command to do the query. Now, while the sc.exe works even in the CMD prompt, in the command line prompt, of course, if you are in PowerShell, you can process the output with PowerShell commands. Like in this other command down, we query all the services information and then we select only the string service name. Essentially here, we just select all the lines, so not from the command prompt because select string is not supported by command prompt, but here it's sort of like a grep that we are obtaining just the lines with the service name. So this can also be useful. Now let's talk about some very, very useful commands like stop service, start service, and check the configuration of a service. So how do we stop a service? Let's obtain a service, like for example, this window push notification system properties. So this service is called WPN service. So how can we stop it? We can stop it as follows. We can do sc.exe stop and then the service name. So in this case it's WPN service. So I do this and it says, of course, access is denied. Because to actually stop this service, I need like the permission. I need permission. So let's open a shell. So let's do shell, and let's open actually let's open just command prompt. It's good enough. So as an administrator, and then do sc.exe stop WP in service. And notice this stop is pending. Here the service status changed to stopped, and now we cannot click on stop again, but we can click on start. And here we can even put the parameters for starting the service in a graphical interface. So this is how we stop a service, and this is how we start it again. Extremely simple. Now, sometimes during exploitation, we have to stop and start specific services. So for example, this one, let's see, it's not with a double S here. I wrote the service name wrong. So for example, I wrote WPN services in the plural, but it's just service in the singular. So I start it again, and it says start pending, and then service status running. So here it changed, and now I can stop it again. So once again, two different ways of dealing, either with the graphical or with the command line. But of course, the command line is much faster and much easier actually. And you can also automate it. You can just use a spreadsheet, a cheat sheet to have all these commands that you can then use during enumeration. So very, very useful. Now, another thing of the service, of course, is the configuration. So the configuration is a critical aspect of the service. How can we obtain the configuration of a given service? With the keyword QC. So we do this, then we say QC, so let's see, sc.exe QC WPN service. So here we have the type of the service, the start type, so auto start, the error control, the binary path name, load order group, the tag, display name, dependencies, service start name. So a lot of different stuff. So if we want to change, for example, the configuration of a service, we can do as follows. We can do sc.exe config the name of the service, so essentially the name of the service, and then we can do bin path equal the new path. So for example, we can do this, and actually here we can put, so let's put the name of this current service, which is this WPN service. So here we do WPN service, we copy all of this and we put it again. So it's of course here it's this, so let's see, okay. Change service config. So it changed, and now if we carry again the configuration, notice here we have changed the binary path associated with the service. So now when we start the service, we're not going to execute the original binary path, but we're going to execute the modified one, which is essentially this one, malicious.exe. Of course, to get back to the original here, what we can do is we can just copy it. It's like we can just say this, we can take this line, we can just copy it here, and then in the bin path, we're just gonna copy this thing with quotes. So we're gonna copy this thing with quotes, and we're gonna configure like this. And then if we query it again, we have what we had before. So this is another way we can attack the system, of course. Now the thing is that typically to configure a service, you need specific privileges. But assuming you have those privileges, you can change the binary, and then when someone starts or stops a service, you have code execution because you're able to execute your version of the binary. Maybe in the original service binary, you introduce some malicious code, some malicious shell code, PowerShell script or things of the sort. And so that when it starts again, it's going to start the normal service, but it's also going to execute malicious code. So this is another possible path of exploitation. So beyond changing the configuration of the service, another really important thing we can do is to check the permissions that are associated with a given service. And we can do that with the command sdshow. So sc.exe, sdshow, and the service name. So let's execute this. So here in the command prompt, so we can do this, and we can do service name, WPN service, for example. So after we execute the command, we obtain this output. And specifically, there is this string that is like hard to read. Now, what is this string? This defines a so-called DACL, which stands for Discretionary Access Control List. So essentially, in this list, we have the various types of permission that a given account can either be allowed to or denied to when they use this particular service. So this is like really hard to read, but essentially we have different information. Now, if we want to obtain a more readable version of the same output, essentially, what we can do is we can use a specific PowerShell command. And specifically, the command is this convert from as DDL string. This is because the language we saw is a domain language called Security Descriptor Definition Language, as DDL. So we can take this command here, we have to use it in PowerShell, so here in PowerShell, and then here we put the quotes, we take this long string, we put it in the quotes, so within the quotes, we press OK, and now we have, for example, we see that there are two types of ACL, discretionary ACL and system ACL. In this case, there are no defined system ACL, there's only discretionary ACL, and then for the discretionary ACL, we have the user or the security entity that it's talking about. We have that, okay, for example, an authority interactive is access allowed, so is allowed to do all these things. Create directories, generic execute, list directory, read attributes. So these are the specific permission on this object that this user has on the system. Then we have an authority service, an authority system, built-in administrator, and then here I'm not sure if there are any other accounts, I don't think so. So we have essentially 4 different accounts that can do different things. So for example, built-in administrator can do a lot of things, authority system too, and so on and so forth. Now, of course, the world of Windows is extremely complex. You have a lot of different permissions, but that's the idea. You can obtain this description with the command sdshow, and then you can read it better to understand, okay, how is this configured? And to finish off, we can list out the list of all the processes running on the system. So these are not just the services, they are literally all the processes with this. So with this first thing, we can select all the executable path. So like this. Actually, let's copy it better and paste it. So here we have all the executable paths, as you can see, even PowerShell, like this. And also there are, of course, the services, because ultimately services are processes. And then we can filter this down, for example, to not match a specific path. For example, system32 and syswow. So we have different output essentially, because maybe we want to exclude this specific folder so that all those in system32 are excluded. So that's essentially the basic idea. And so this is it as far as like the enumeration of services goes. We have these main commands, so how to extract information from services, how to stop and start a service, and now we can obtain the configuration, the permission of a service, and also eventually change that configuration. And also, just to be complete, it's also possible to change the permission of a given service with the command sdset. So here we put the service, and here we put the sddl string. And in the references that I used to make this video, I linked this article working with SDDL, that it shows a practical example of changing the SDDL of a service. So this is it for in terms of managing services. We can now talk about, okay, how can we add a new service? Now, why is this useful to know? Well, first of all, it allows us to apply what we discussed in the previous video regarding cross-compilation, because we can cross-compile our own service within Linux and then execute it on Windows. Also, because introducing, for example, a malicious service is a good path for exploitation of a machine, for obtaining maybe more privileges, for doing stuff on the computer essentially. So it's a cool thing to understand and to know. So how can we do this? Okay, so to create a new service, once again, you need a binary, a simple.exe. However, there are 2 specific ways. If you want to follow the standard way, this binary has to implement the specific Windows Service API. So this API hooks into the Windows Services system and allows to register the service with other systems in Windows, like for example, the service GUI and stuff like that. So how can we build like a binary that respects this specific API? So the idea is that it's pretty simple. You just say create the service name and the path to the binary. So bin path, the path to the executable that implements this API. Now here I will present a really simple example that I've taken from my GitHub repository. I will put the link into the description. I really thank the author. I changed it a little bit, but not too much. So this one, very basic Windows Service template in C of Monk, of the user. So here is link in the description, but it just gives us an idea on how the code looks like. So let's analyze this code. So this was heavily inspired from this link. So it's not really that much. It's about 100 lines of code, and it's mostly like to deal with Windows API. So we start with some include, so the windows.h, which contains the Windows API functions, and then the normal standard input-output, the stdio of the standard C library. So here we define the service name as a simple service with some structs that are specific to Windows, so service status and service status handle. Then here I have the temp file, so this contains the path to a temporary file because the objective of this simple service is just to execute many times this write to log function. So this write to log function simply takes a string, opens the temporary file in append mode so that we keep writing to the file, and then we just do an fprintf to the specific file descriptor. So in this case, it's the log file. So that's the idea. We just write the string and we write a new line. So the string is, so the string that we're gonna write is gonna be please subscribe. So it's just gonna write multiple times, please subscribe. And so that's the main idea of the service. Now, how does it work? So like here we have this utility function, here we have the definition of the temporary file buffer. So let's go down actually at the end, we have this win-main. So this is the entry point of the program in Windows using the Windows API. So given that this uses the Windows API, we have a bunch of like data structure that are given to us by the Windows operating system when it boots us, so when we go live. So we don't really care about those kind of stuff. We just want to initialize a service table entry, so this is like a struct, and we just put the service name here and the service main func. So like this is the pointer, this is the name of the function service main, and then we executed the start service control dispatcher start table, which is of course this is like standardized by the Windows. So this is like a Windows API with this specific data structure. So here there's not really much to say, it's all about Windows API. So what does the service main function do? So this is the main function that is called. So here we set up some variable of the service, for example, the current state, the controls accepted, so we can stop it, we can continue, you can shut down it, the exit code, the checkpoint, like a lot of specific Windows stuff. Then we register the control handler, so CTR handler, so we say service control handler, which is a function that is called when the service change like status. Maybe it goes, so like if the control pause, then the service is paused. If we obtain like a signal to continue, then the service is running, and so on and so forth. So I believe, I'm not sure, like I'm not 100% sure, but I believe this is called when the service receives an update. So for example, do we stop it? Okay, we have to stop it, and maybe we can do some extra work depending on our specific need. And indeed, here essentially we just, depending on the control that we obtain, here we just set it differently. So we can say set service status to the service status that we have modified here, where the service status of course is this global variable. So that's the idea. So here, if I read the API right, essentially what happens is that here we get an handle to the service status of the currently running service, and then we update it with what kind of data? With the data we have in our program. So essentially in our program we have a clone of the service status and we update it with the one we have. So essentially that's the idea. This is why we set it up first. So we set the service status up in our own memory and then we give it to Windows. So we update the status of the service that Windows sees and that Windows uses. Once again, if we have any problem, we just return early. Then we can initialize the service by essentially initializing this temp file, and this temp file is obtained with this method getTempPath. So it's going to return us a directory, like starting from the root directory, for example, from the C drive to like C Windows temp, something like that. And then to that we add the templogger.log. So this is going to be the final name of the actual file. And then we have the service main loop, which is just going to keep executing. So we say until the service has stopped. So what we do is we slip over, we check if the service is currently running again, and then we write it. So we only write if the service is running. If the service is not running, we do not write. And then if the server is stopped, we actually exit from this while loop. So this is going to be a while the service has to be kept running, essentially. So that's the idea, very simple code. How can we deal with this? How can we execute it and add it on the machine? We can cross-compile it as I showed in the previous video. So let's go into the cross-compilation. So here I go into the source. I can cross-compile it with my cross-compiler with a bunch of flags for dealing with Windows, essentially. So I believe that, okay, so this is it. So we can cross-compile. Here I have essentially the binary. So let's remove this and recompile it again, just to make sure. So I'm gonna cross-compile this. So of course, that could be also a malicious service. In this case, it's not malicious. So once we have cross-compiled, we can send it to our remote machine. So for example, with netcat, so .exe, I do a reverse shell here. Here I open a command prompt, I go into downloads. So let's do here, I have nothing, I have just my netcat. So I do netcat, and then I put it over the machine. So simple service.exe. So here I have a connection, so we transfer the file, and then we do the creation of the service. So sc.exe create, the name of the service, simple service, and then the binary path, so bin path. In this case, it goes to cuser quickemu downloads simple service, which is exactly this specific path. So I can just copy and paste this. So I copy and paste this. Of course, this is gonna say access is denied, because this is a low privilege shell. To actually create the services, you actually need to run a admin user. So we go into download, and then we create here, and now it says create service success, and we can query for the newly created service, and it's gonna, so like, let's take this, let's query it, and it's gonna give us the configuration of the service with our own specific binary path. And then we can actually start with the cs.exe start. So we are starting it now, and then, so to check if it's running, we can go into the cmp temp, so C, essentially it's like C Windows, then there is temp, so let's go into T, temp, and then we should have temp.logger, so this was created right now, essentially. And then look at this, it's writing, and after like that specific delay, so in the code the delay was, let me see how much it was. This code governs after how much the logger is updated. So right now we have, of course, more lines than before. And of course, now that it's running, we can actually see it in the service GUI. So in the previous GUI that I showed, here we check for S. So essentially for simple service. So we do simple service. This is it. We can do properties. We have that it runs in simple service.exe and things like that. So this is for in terms of installing it. And then we can stop it. We can stop it its current execution on the privilege shell. So I need this one. So let me copy this. So copy and paste. So now it's stopped, and then we can delete it. So we can delete the service itself so that it's we cannot see it from the GUI. So we got delete it. And now from these things, let's do maybe a refresh here. Don't know if there is a refresh. And it removed. Like there is no longer the entry for simple service because it's no longer registered within Windows. Now, in this case, I showed the example of a C binary that implements the Windows API. And I wanted to do that because then it gives you the power to modify it, to introduce your own code, and to slightly change the functioning. Essentially here, we have full control after we got the handle of the service. We have full control on how we want to deal with it, essentially. So if instead you want to convert an arbitrary .bat or .exe as a service, I've read, however, I did not personally test this myself, I've read that you can use the NSSM tool, which stands for Non-Sucking Service Manager. So here I give you some references. It should be easy to use, however, I did not test it out, so I cannot say for sure. It's like for completeness sake, if you want to introduce a service without using the Windows API, maybe you can use this tool as well. So just for your awareness, let's say. So this is it for this video. I hope it was enjoyable. I hope you got something out of it. In this video, we introduced the Windows services and how to manage them. In future videos, we will show specific exploitation techniques that can be done on the Windows service. So as always, if you like it, give some feedback, subscribe to the channel, share this with like-minded people, and to the next video. Hi everyone and welcome into this new video in which I continue my Windows privilege escalation series. Specifically in this video we start to see a practical example on the service attack area, and specifically we will talk about weak service permissions. So if the services are not properly configured, so if they have weak permissions, we can attack them in two different ways. We can attack the service configuration, or we can attack the service binary itself. So these are two different aspects that both have to do with the weak permission, with the configuration of weak permissions. At the end of the video, I will also show how to enumerate the service with winPEAS. So this can be useful if you want to have quick results, a quick overview over the service of Windows. You can use winPEAS with some flags that I show at the end. As always, I hope the video is useful. If it is, leave some feedback. Even if it isn't, leave some feedback. Subscribe to the channel to help me grow and share this video with like-minded people. Having said all of this, please enjoy the video. So let's start our discussion on the first type of weak permission, which is a service configuration. So when the service configuration itself is weakly configured. So we saw in the previous video where we discussed about services that we can enumerate, we can obtain the configuration of a given service with the command cs.exeqc. So we do cs.exeqc and then we put the name of the service, and in a practical example essentially what we get is we get this kind of output. So we have a bunch of different like configuration. And among these values, one of the most important one is the binary path name. It is the path that points to the binary associated with the service. Which means that, for example, take this example, simple service. We have this simple service exe found in C users quickemu downloads. What does it mean? It means that when we start the server, we are actually executing this binary. And in the previous video about services, I also show how to create a simple service using the Windows API. So the idea is, what if this configuration is not properly set up with the right permissions? What if it allows our user, the user over which we have access to the machine, what if we are allowed to change this configuration? Well, the basic idea is really simple. If we can change this configuration, if we can change specifically the binary path name, we can just point to a different exe, maybe a malicious exe that contains some malicious code, and then we will just be able to execute our code. So the idea is that if we can change the configuration, and then if we can stop and start again the service, the new executable will be executed, which is gonna be malicious, of course, because we have control over that. So how can we obtain this kind of information? Well, a quick and easy way is to use the access chk64 binary, which is a utility that Windows offers to download. So you can go into this site. So by going into this website, you can download the binary. It is around 1 megabyte, and it is a Windows utility which is very useful, so you should have it. So in my case, I have it here essentially. So in content bin, I have this access chk64. So the first thing is, let's bring it to the remote machine. So as always, I'm gonna put ncat to just transfer it. Very, very simple. So here I'm gonna open a shell, and the shell has to be actually CMD, because otherwise the ncat is not gonna work properly. I go into downloads, and I'm gonna change to the Italian keyboard here. Then I'm gonna do nc. I'm gonna put the IP address of my machine, and then I'm gonna put access csk64exe. So I'm getting a connection here, so it's been transferred, and so now I can just use it. Perfect. So we have essentially the reports effective permission for secureable objects. So this is like a very general utility which we can also use for services. How do we use it for services? We can just say, you can just use this command, which has a different flag, so we will explain it later, but let's just copy and paste this here. So I'm gonna do this here, and look, it says, look, simple service, it's the authority system has access to all the service in read and write, and also the administrators. So this service can be accessed by authority system and administrators. So essentially that's the basic idea. And here I report essentially the various flags and why we use them. And also we have to do this accept, also that we don't have to write all the time accept, essentially. So specifically, okay, let's say that we have this kind of configuration. Now, my user, if I say who am I, actually if I say who am I / groups, I actually belong to the administrators, group. So since my user belongs to the administrator groups, I should be able to change the configuration of this service given that the administrators can access, can do everything with the service. However, let's try, for example, to change the path, like with this command. So this actually does not change anything, but let's just try to access the service in this way. So I'm just gonna take this and I'm gonna copy it. It says actually access denied. And I believe, I'm not 100% sure, but I believe it has to do with the medium mandatory level, which is a Windows security feature, which I describe in the second video of the series when I talk about Windows permissions, and I have this integrity control. Essentially, the idea is that you can have different integrity levels, and depending on the level, you have only access to certain features. This means that even though my account technically is part of the administrator, this particular shell was executed with a medium level, and this does not allow me to access those privileges. Indeed, if I say where my priv in this shell, I don't have much here. However, if I go and do CMD, if I search CMD here and then I say run as administrator with the same account essentially, now I'm still quickemu. However, if I do UMI groups, I essentially am high mandatory level. So now the level has increased, which means I can now change the configuration of the service. So if I go back to the things to change the configuration of the service, I can just do this. Okay, not this because it did not copy it correctly from. So let's clear this. So I'm gonna copy this, I'm gonna paste this. And now it changes correctly. So at this point, we can assume we have a user that is able to change the configuration of a service in the system. And also we're able to stop and start the service. So we can do stop, simple service. It's gonna say the service has not been started, and we can also start it. So with this shell, we have full control over the service. We have these capabilities: starting, stopping, and changing the configuration. Perfect. What can we do with this? Well, a first payload is, let's say that we already have a malicious netcat binary in the Windows system. This is not really malicious per se, but we will use it in a malicious way. So what we can do is we can change the binary path to essentially trigger a reverse shell. So it's a very simple payload. Look at this. We just change config. Here we put the netcat. Here we put the IP address of our attacker machine, of our attacker endpoint. So 192.168.122.1.431, which is the TCP port. And then we do -e and we give the program to execute over that TCP connection. So this is like a simple reverse shell. So let's listen on this specific endpoint 431. And let's change the configuration like this. And I'm gonna put the shell here down so it's you can see it better. So let's execute this. So I'm gonna copy it again here. I'm gonna put it here. And now I've changed the configuration. However, I still do not get code execution because even though the configuration has changed, and if I check it with UC of simple service, I get, look, this is the new binary path name, I still need to start it to actually get code execution, because when I start the service, I'm gonna actually execute this specific command, which will trigger a reverse shell. So let's start it. Simple service. It's not QC, it's SC. It's SC, I always forget myself. And notice what I get down. I get a reverse shell as NT authority system. So now I have all the privileges of admin, essentially, of the root user in Windows. And so this is a very simple way to obtain code execution, given, however, that we can change the configuration of a service. And at the end of the video, I will show how to enumerate this thing with winPEAS. So that's a first approach. What would be maybe a second approach to exploit this, just for completeness? So let's say we don't have this malicious netcat already within the remote machine. So what we can do, we can use MS Venom to create a malicious payload like a shell reverse TCP with a given host and port. We can say, look, I want an executable and I want to call it malicious.exe. So let's exit from this reverse. So let's exit from here and let's remove this malicious. I'm gonna regenerate it with MS Venom, and here I put the payload Windows shell reverse TCP. So I'm just gonna do this. It's something about the future deprecation, but we don't care about that right now. So now I have the final payload. So essentially here I did not put the architecture, but the architecture chosen by the payload is good enough. It's x86. So that's a 32-bit architecture, which works for our case because Windows also supports that. And if we check the file on it, notice we see it's a P32 executable. So this is a 32-bit executable. It's still good enough. So what we can do about it is, okay, let's transfer it to the remote machine. So let's go into downloads here. I'm gonna do an endcut as always. Oh shit, I always... Okay, endcut with the right port. And then I put malicious.exe. So malicious.exe, perfect. I've transferred it over, that's good. So let's try to just use it to make sure that it works. So I'm gonna listen on port 777 and I'm gonna execute it with my user, malicious.exe. And notice I got a shell. So I got a shell and of course here I am quickemu. But of course this quickemu runs with the integrity level medium, so like I don't have access to all the privileges of administrators, but I still have a reverse shell. So now to make the actual attack on the service configuration itself, what I can do is, okay, I can change now the service configuration with this other shell, and I put, okay, the new configuration is going to use this malicious.exe. So I'm going to copy this, go here, take the shell with the higher integrity level. So I'm going to put this and put this. I have changed the configuration. Now I can stop the service. So I can do stop. Before doing start, I'm gonna have here, let's open here a reverse shell. So I don't know why this shell is stuck. Okay, I'm gonna open here a reverse shell. Actually, let's do 3. Perfect. It's port 777 this time. So always be careful about the ports. And so now I can do start. And when I do start, actually, let's first see the configuration itself. So if it's properly changed, c.c qc simple service. Notice now that it points to the malicious exe, so we can do cexe start simple service, and boom, we have our shell. So this runs as authority system. I have all the privileges and I can do whatever I want within the machine with this specific shell. Also, notice this one thing. We were able to obtain a shell as NT authority system because the way this service was configured was that it would log on as local system. So this is why it's important to like configure this stuff, not local system, not network service, but local service if it is a service that only runs on your specific machine. So essentially that's the idea. And so this first attack has to do with the essentially service configuration, with how the service was configured. Now, let's say that you are not allowed to change the configuration of the service itself. However, you are allowed to change the binary of the service. So this has to do with different kind of permissions, not on the level of the service, but on the level of the binary. For example, let's consider this. So let's start the service. So we can do, we can actually, okay, let's go back to the original service. So let's configure it back to the original value like this. I put it here. So let me copy it again because sometimes it just does not work. Okay, so now I have the previous service, the old service. I'm gonna start it, simple service. So perfect, it started. Now let's execute this command, get sim instance class name win3 services, select name state path name where object is like running. So this is a command in PowerShell that we can use to obtain all the running services and their binary path. So we do this and we have essentially a bunch of different services, and among these we can find essentially at some point where is the SS simple service with the binary path C user quickemu downloads. We can say, oh look, this service starts in a user's directory. Maybe we can change it. Maybe we can change the binary itself. So how would we test for it? Well, the idea is that let's use the ICLs utility to get the configuration of the specific binary. So can we modify this binary itself? Can we overwrite this with a new binary? Can we just change it whatsoever? So we copy this command. So we just copy this command here and we can say, look, let's go here. I'm gonna go into downloads because that's where the simple service exe is found. And then I just execute these icalcs. And I get, look, I am the user quickemu. So I am the user quickemu this, and I have full control over the binary. This means essentially I can overwrite it. So at this level, we are not really changing the service configuration. We are changing the binary itself. You can sort of think of like, okay, the service configuration points to the binary. So the way to attack this is either we change the service configuration and we point to a malicious binary. So this is what we showed previously. Or we just overwrite the original with a malicious and we don't change the server's configuration. So it's still gonna point to the same binary name with the same binary path. However, the actual executable associated with that particular path in the file system, the content of that executable will be different, and specifically it will be a malicious one that we overwrote because we have access to this binary, because this binary was not properly protected. So that's essentially the basic idea. It's pretty simple idea, so it's not too complex. So once again, what can we do? Well, we have already generated the malicious. So really, the only thing we need to do is just copy it over the simple service. So we can stop the simple service itself with the other shell. So we can do start and stop here. So we can do stop. And of course, in this case, I'm showing two different shells simply because in one, I've just the normal user. In the other, I have the more privileged user for starting and stopping the service. This requires having the privileges to start and stop the service. If you do not have those, you cannot really explore this attack vector. So here we are assuming we have compromised an account which can start and stop services. These are threat modeling. This is the point where we begin our exploitation. Here I'm just showing two different shells because the first one that I opened simply had the lower mandatory level for accessing all the privileges. So that's the idea. So we have stopped the service here. Now we can overwrite this service, even with this lower privilege shell, because we are the same user after all. So we can just do this copy, very simple command. It's going to take the malicious, which contains the executable for a reverse shell, and it's going to overwrite the simple service. Look at the sizes. This is 41, this is 73K, and now after this, we do adhere again. They are, of course, the same. We have overwritten the original service. Now, of course, here I did something that is kind of dangerous. I did not do a backup. So before you want to do this kind of thing, especially in a remote environment, you want to do a backup. So you want to say, look, I'm going to copy the original one into a backup version, and then I'm going to replace it. So actually this one, it would be like this simple service. First, you do a backup of the original executable and you save it somewhere so you don't lose it. And then you replace it. Because let's say that something goes wrong and essentially you fuck up the service, you want also to get back to the original version. If you overwrite it but you don't save a copy, that's very dangerous. So always do that in case. I didn't do it because I've saved the simple service in my Linux machine, so I'm not really in the previous directory, not in this one, so I'm not really worried about that. So having said that, it's as simple as that. So like we're already done, because now we just need to put our listener at 777, we're gonna stop the service, already stopped, we're gonna start it again, and look at this, we have a new binary. Even though if we check here, if we check the configuration of simple service, it has not changed. Now we did not change this configuration, but we changed the binary itself, and now we have a shell. Once again, the shell runs with an authority system because this is a system service. And so with this, we are essentially done. The last thing before closing the video is, other than a bunch of references that I've used for preparing the video, which I thank all the authors that made them. So essentially, we have enumeration with winPEAS. So we have this project winPEAS, which allows us to enumerate the service attack area of a Windows system. And how can we use this? We can just download it with wget. So look at this, it's a very simple command. So I'm gonna do exit. Here I have it already, winPEAS x64. So it's just wget with the GitHub page, the download page. This is the version, the 11 October version, whatever. Then we transfer it to the machine. So simple netcat to transfer it over. Our favorite command, and see 127.122.143 winPEAS.exe. Actually, let's do it like this, so it's better. Okay, so we have this. Now we have the binary itself, not access, but winPEAS. And okay, it's actually doing a lot of stuff. We don't want to execute everything. We are mostly interested in the Windows service enumeration. So how can we use this winPEAS to enumerate the Windows area? We just do winPEAS quiet services info. Very, very simple. We just do this. And look, we have a list of services that we can start or stop. We can start or stop these specific services. It says, look, these are the interesting services, like non-Microsoft ones. And look at this. It tells us that we have file permission over this simple service. And also the configuration, if it stopped running and if it's auto, like if it resets at boot time, so it starts again at boot time, or we have to manually start it essentially. So that's the idea. So it says file permission, quickemu access, all access on this particular file, and then possible DLL hijacking, which we will cover in a different video, so watch out for that. And then we can modify these services, and there is no registry we can modify. This once if we are able to write permissions, but we are not with this specific shell, we are with this other, however. Like with this other, let's try to execute the same script on this other. So user quickemu download, then we do we have to do cd, of course, user quickemu downloads, and then we do winPEAS, we do quiet services info. Of course, here we do not have the graphics essentially, but we are able to write data. We are able to modify all the registry entries, of course, because we have full access to the system. So the output is much more rich, clearly, because we have way more access essentially. But that's the general idea. So in this video, we show two simple ways to attack services, either if they have misconfiguration on the service itself at the service level. We can check that with the access chk. Remember though that sometimes, even though our users belong to certain groups, if our mandatory level, which I discussed in the Windows permission, this mandatory integrity control, this MIC, if the MIC is medium, then we cannot really access certain privilege features. So that's the idea. But other than that, let's say that we find a service, we know we can start and stop it, and we can change the configuration. Then the idea is just to change the binary path. It's a very simple idea. And another way is that, okay, let's say we cannot change the configuration of the service. However, we can overwrite the binary that the service points to. So the binary that is actually executed when the service starts and stops. If we can change this binary, once again, we have control over code execution on the system essentially. And then we can just create a shell. We can create a malicious exe with MS Venom. We can upload it to the remote machine. We can overwrite the original service with the essentially with the malicious one, and then we can start and stop. We can stop it and start again to obtain code execution. Of course, at this level, we're not really talking about obfuscation and about avoiding antivirus and like endpoint detection systems. That could be the topic for future series. Maybe at the end of this series, we'll talk a bit about that. I still have to decide. However, for basic stuff, we assume there's no antivirus, and then we build on top of this knowledge in the future. So essentially, that's the idea. And finally, I show how to enumerate the specific service area with winPEAS. So it's a very useful tool. It's a very useful enumeration tool. So this is it for this video. I hope it was enjoyable, I hope it was useful, and I hope you got something out of it. If you did, leave some feedback, subscribe to the channel, share this video with like-minded people, and see you to the next video. Hi everyone, and welcome into this new video in which we continue the Windows Privilege Escalation series. Now in this video specifically, we will see an attack on the Windows services called Unquoted Service Path. So as always, I hope this video is useful. If you have some feedback, positive or negative, leave it in the comments, subscribe to the channel to support me, and of course, spread this video with like-minded people to help me grow. Thank you very much and enjoy the video. So we can start to talk about unquoted service path. So what kind of attack is this? Now, when the Windows service binary contains white spaces, but no proper quotation marks are used, then our service binary can be vulnerable to unquoted service path. So this kind of vulnerability affects those binaries that the binary path, so if we check for example the configuration with the sc.exe binary that I showed in the previous episodes, so if we check the configuration for the binary path name, which represents the executable that is going to be executed when we start the service, now For example, in this case, there are no white spaces, so there's no problem. To actually be vulnerable, you need two specific conditions. You need to have white spaces in the path, so white spaces, and also the path must miss quotes, so missing quotes. If both of those conditions are true, then you are vulnerable to unquoted service path. To actually be exploitable, then you need further requirements, but that's the idea. So how does it work? Now, essentially consider, for example, our simple service, which is the service we are using to discuss this kind of vulnerabilities. Now, and here I have my Windows system, by the way. So here I have the prompt with elevated privileges. This is the normal prompt, so we're ready to do our exploitation, essentially. So in this system, what do we have? So let's query our simple service. So let's do here, we query for information. And notice, for now, the binary path name is the usual C users quickemu downloads simple service.exe. So there are no white space in this path, therefore this is not vulnerable. Now let's go into the downloads directory and create a couple of directories that contain white spaces. So for example, we can go into downloads here. We can do make dir example directory. Now notice this directory contains a white space and this is gonna be critical. So we do this, then we go inside this directory and then we create another directory called another directory. So very funny name here, another directory. So, and then essentially at this point what we have downloads, example directory, another directory. There are two white spaces, here between example and directory and here between another and directory. Now, let's change the binary path. So let's move the binary into this specific directory. So we're going to do a move dot to go backwards. Here I have to change the language to Italian. So here we go backwards and we do simple service and then we move it here. Perfect. So now our binary is situated in these directories which contain a white space. Now let's change the configuration of the service. So we're going to use this different shell because it has higher privileges. So let's change the configuration of this service. And now we're going to say, okay, the new service is going to be in downloads, example directory, another directory, simple service.exe. Simple as that. So we copy this and we have changed the configuration, which means that if we query now for the service here with the SCQC, now notice that the binary path change. And now in this change binary path, there are white spaces. For example, here, and for example, here, and there are no quotes here. Now this configuration actually is vulnerable to this specific attack. So what's the idea of this attack? Well, the idea is that in this situation, when there is white space but no quotation marks, then the Windows operating system will not go directly to the binary that we put at the end, so to this simple service.exe. To actually get there, Windows will first try to execute different binaries using a predefined series of rules, and then at the end you have the final binary. So it's kind of like a weird searching for the right service path, because Windows does not understand exactly where it is found. So for example, if we stop here the service, so now the service should be stopped anyways, let's just stop it again. So I'm gonna copy this, put it here. It says, look, the service has not been started, there's no problem, we can start it, and now it's starting, perfect. And now we can stop it again because nothing happened, that's good. Okay, now when we start the service, what actually happens is that Windows will search first for the example.exe binary in the downloads folder. If it doesn't find anything, then it moves to the another.exe binary in the example directory folder. And then if it doesn't find anything, then finally it arrives at the simple service.exe. So let's say that an attacker is able to write an arbitrary file in the downloads folder. Then an attacker can introduce a malicious file called example.exe. And notice that in this case, the name matters a lot because it has to be exactly example.exe. And if the attacker is able to do that, when Windows will start the simple service, it's actually going to search for this bin path, but then since the bin path contains white spaces, it's going to break it first here in example.exe. It's going to try to find this binary. The binary exists and therefore Windows will execute that binary. So this vulnerability has to do with the ambiguity that Windows searches different binaries instead of the final one. Now, to be honest, I don't know exactly internally why Windows does that, but essentially this is what happens. It probably does that because it cannot, with its algorithm, determine the final path, because probably these white spaces are interpreted in like the wrong way, sort of, so it goes into the example.exe. If it doesn't find this, it jumps into the next directory and it goes into the another.exe, and so on and so forth. As I said previously, this opens up the possibility for an attacker to introduce a malicious binary in one of the paths that Windows searches for. If the attacker is able to write in one of those directories, maybe not the first but the second, it doesn't matter, it just matters that one of those directories is writable by the attacker user. If this is true, if the attacker can write in any one of those paths, the attacker is able to hijack the execution flow and to execute a malicious binary. For example, let's say that we have a malicious binary. Now, I don't have it here yet, so let's generate it. I can generate it with MSF Venom. So pretty simple. So here I'm generating it, it's malicious.exe. So now that we generated the malicious.exe binary, we can just transfer it with netcat. So as always, we do netcat malicious, not nodes, but malicious. Here we do netcat. Okay, I have to change once again the language to Italian. Netcat 192.168.1.221, and then malicious.exe. Okay, now notice that we receive a connection, and now we have our payload. Now this malicious payload allows us to obtain a shell with the port 777. So specifically, let's say I put listener and then I execute the payload. Notice here I get a shell. So nothing new, I'm quickemu, and this is the idea. So how can we abuse the unquoted service path? Well, what's the idea? How does the attack work? First, we obtain the configuration, so with this simple command, and then we say, okay, look, this command is not quoted and it has spaces. This could be vulnerable. So we have to check if we can write in different directories. The first directory is literally the first things, the first time we get a space, we stop in that place, we go to the previous directory and we create the file name example.exe. So in this case, it is the downloads directory, which means that if we can write into the downloads, then we can exploit this attack. In this case, of course, we can. And it's actually pretty simple because you just have to create a copy of the malicious and we're going to call it example.exe. So notice now we have this example.exe. When Windows will try to start the simple service, the first executable that is actually going to get executed is going to be the example.exe in the downloads folder, which now is just become the malicious one. So let's put a listener once again. Let's start our service with the start simple service. So we can start with this order. And notice I get a shell. I get a shell because the first executable that Windows found was this example.exe. So this is like a pretty important vulnerability on the configuration of the service, of course. So I exit. Here it said, of course, that the service could not be started, clearly, because it was a malicious reverse shell. And of course, there is some security things which we do not care. Anyways, now let's say though that we could not write into this specific directory. Could we not exploit this? Well, actually, since in this case there are multiple directories with white spaces, we can try with this other white space. So the other executable is going to be another.exe in the directory of example directory. So the idea is pretty simple. So let's go, let's copy, let's move actually this example.exe. So we do a move example.exe. We're going to move into the example directory and I'm going to call it another.exe. So now if I go into the example directory, I have this binary called another.exe, no longer example.exe. Now in the downloads, there is no example.exe. So the same idea applies. I start the service and notice I get once again code execution because now what got actually executed is this another.exe. And to prove this point, let's rename it with another name. So with another2.exe, so a different name, right? So I remove from this shell, I put a listener again, I try to start the service again, and notice now no shell is started because now this executable was not actually executed because it's called in a different way with respect to the directory path. And so what actually got executed is a simple service exe which is the valid service. So we can stop this. This is just to showcase that in this attack, we need to write an arbitrary, not really an arbitrary file, but like a specific binary with a specific name in a specific directory. So that's the main idea of the attack. Now to make it more clear, I brought some more example. So for example, let's say there is this service path. So we have program files x86, company app, app.exe. So like, you know, an arbitrary service that a program might install in the system. So for example, in this case, how many binaries will the Windows operating system search before actually getting to the final exe? So first it's going to try to execute the program.exe, which means that if the attacker can write the program.exe in the C root, so in the file system root essentially, then we have code execution. The next thing it's going to do is going to actually execute program files.exe, also in the C root. If it doesn't find both of these, then it goes to the next directory. Now, in this case, notice that it skips completely the company, because the company portion of the path is just made of one word with no white space. So it's gonna go to the company app. To the company app, it's gonna break on the white space. So it's gonna find the program company.exe that has all the previous paths still valid, which means that if the user can write in the company directory in this one, in this path, so C, program file 686 and company, then once again, we have code execution. And after that, it arrives at the final binary. So this is one example. This is another example. So we have program, cool company, cool binary.exe. So here the white space is actually in the binary name. That is to be found on the name of the executable. Now, if this is the binary path of our service, then Windows first will search for cool.exe in program in C. Then it's going to go into cool.exe of this order, of the name of the binary. So cool is repeated, but remember, first cool.exe is for the first white space. Second is for the second white space. So essentially, the algorithm you must have in mind, sort of, you can think of is, okay, I go towards the first space, perfect. I remove everything that is after and I put an exe and I try this binary. There is nothing there, okay, I move to the next space. Okay, to the next space, I put an exe and that's it. Then to the next space, okay, the next space, here I put an exe and that's it. So that's the algorithm. By having this algorithm, you will be able to figure out all the different executables that Windows will try to search for, and then you have to ask yourself, okay, as an attacker, as the current user, can I write a file in the C drive? Can I write a file in the company folder? I mean, maybe it's really difficult to write in the C root, but maybe it's easier to write in the company folder. And then if you are able to write in the company folder, you just have to make sure you write the file with the right name. Otherwise, as I showed before, the attack doesn't work anymore. So that's essentially the idea. And by connecting this specific attack on services with the attacks that we saw in the previous videos, in the previous video we talked about weak services, so weak config. So weak config at the level of the binary permission or at the level of the service permission. In this case, we are saying it's sort of like another type of weak configuration in the binary path, but it does not have to do with the fact that we're able to change that binary path. We do not have to touch the binary path. It's just that if the binary path contains white spaces and there are no quotes around that binary path, then Windows will actually search for more than one executable. And then we can introduce maybe malicious executables. So the idea is that to be vulnerable, we need white spaces and no quotes. To actually weaponize this vulnerability, to actually make it an exploit, we need to find a path where we can write on. And this attack is all about getting from the binary path of the service, you enumerate all the different paths, and then you understand, okay, can I write in the company folder? Can I write in the cool company folder? And so on and so forth. This is the basic idea. Now, when it comes to automatic enumeration, you can also use the winPEAS tool that I showed in the previous video, because it's going to enumerate a bunch of common vulnerabilities, including the essentially no quotes and space detected, so including the unquoted service path vulnerability. Specifically, let's execute it on the machine. So here I believe that I had it downloaded. So let's go into downloads. Here it's winPEAS.exe. So I do winPEAS.exe quiet services info, exactly the same output as I showed in the last video. I execute it. And notice now that what do I get is, okay, you can start and stop some services, but the idea is that, well, I have file permission, I have DLL hijacking, which I will talk in a future video. File permission, I already discussed in a previous video. DLL hijacking, I will talk in a future video. And then we have no quotes and space detected. So essentially, it gives us the binary path of the service, and it says, look, there are white spaces here and here, and there is no quotes. It means that the operating system will do this funny search for all the different binaries before reaching the desired one, which can be problematic if our user can write in one of those binaries. So that's interesting. Now, to finish off the video, a quick note on fixing this vulnerability, because it's actually extremely simple. So when you configure a service in Windows, make sure that you have quotes around the path if the path contains white spaces. So how can you do that? Well, you can go into the regedit, so the regedit, the registry editor, essentially, of the system, and then you can search for, so let's put it on the side so that it's more clear. So we can search for the keys of the, essentially this thing, so I've already opened, but let's go into HKey local machine, then we go into system, then we go into current control set, so like current control set, this one, so like we do HKey local machine, system, current control set, services, then we find our service, which in this case is simple service, so simple service, and then here we have a bunch of lines in the registry, and what we want to change is the image path. So this one we do modify, and essentially we add a quotes at the beginning and we add a quotes at the end. So now we do this, and look now that there are quotes on this, so we can just close this, and what we can do is, okay, let's try now to exploit again. So let's try to exploit again as we did. So we have a shell running, perfect. So now let's first let's get the let's check the configuration again. So with the, essentially, let's go back to the commands, to this SCQC to check the configuration. Notice now that I see the quotes, so this is no longer vulnerable. So what do we have here? Let's go into example and let's move this another 2 into another.exe. Now previously this worked, previously with this we were able to obtain a shell. So let's try it now. So I'm going to do a start, I'm going to start it, and notice no shell. We obtain no shell because we fixed the vulnerability, because we quoted the path of the service. And this is enough to do this. Now, if you want to change this directly from the command line, you can actually do it in a simpler way with the scconfig command. So to change the configuration of a service, here, notice this, what do? We add the quotes, and here we have to escape the quotes. So essentially you just, let's first remove them. So I'm gonna show it. First we remove the quotes, so there are no quotes anymore. So like this we would just remove. So this is another directory, and then simple service. So with this, I just remove the quotes. I have to copy it better. So I do this, I put it here. So now if I check the service, there are no quotes, which means that now if I stop and start the service again, stop and start, I get a shell, right? So now how do we fix this? Here I can exit, whatever, perfect. So how do I fix it? Well, when I change the config, essentially, so when I change the config, I just have to change it by putting the quotes and by escaping the quotes, like this. So another directory, so let's remove everything here, and let's change the config, but this time with the quotes. So look at this now. Here I have the quotes. Notice the difference here. No quotes, vulnerable. Quotes, not vulnerable. I listen again down beneath. I start the service again, and I get no shell. I get no shell because the vulnerability has been fixed. If I try to enumerate with winPEAS, notice, well, it's not here, of course. It's in this previous directory. Now I get the previous vulnerabilities, of course, but I do not get anymore the unquoted service path. I get file permission and possible DLL hijacking, but I do not longer get, look, there are white spaces and no quotes, because we fixed that. And here below I put some references that describe the same attack I described in this video. As always, I hope the video was enjoyable. I hope you got something out of it. If you did, leave some feedback, share this video with like-minded people, and to the next video where we will keep seeing different ways of exploiting Windows services. Hi everyone and welcome in this video in which I continue my Windows privilege escalation series. In this episode we will discuss a technique known as DLL hijacking. This technique consists in understanding what are the dynamic link libraries of a given binary, for example also a service, and then trying to hijack those DLLs either by overwriting the DLL binary itself, so the file that represents the DLL that contains the DLL, or by hijacking the DLL search order. So in this video we will introduce what is a DLL, we will show a simple example of compile a binary with a DLL, and then we'll talk about how to enumerate the DLLs and how to attack vulnerable implementation with overwriting the DLL binary or hijacking the search order. As always, I hope the video is useful. I hope you got something out of it. If you do, subscribe to the channel, share this video with like-minded people, and that's it. Enjoy the video. So first things first, what is a DLL? Now DLL stands for Dynamic Link Libraries, and the idea is that modern operating systems offer the ability to reuse common code. So most application in a given operating system, they use a lot of shared code. So for example, the idea is that if I have three processes, process 1, process 2, and process 3, now they will share lots and lots of code among each others. So instead of having in the program associated to P1 the entire code which is then duplicated in P2 and P3, the idea is that, okay, let's take this shared code, for example, library code, let's put into a single file, call it lib.dll, and then this single file is used to spawn these various processes, so that the size of those programs does not go really high, because otherwise there will be a lot of waste. So the idea is that we have the ability to reuse common code, such as libraries, across the different binaries. Now, when an executable is started, a linker loads these dynamic libraries into the process memory. So the process of executing a binary, so transforming a portable executable into a process that executes on the system, is actually quite complex. And one of the steps in this process is to load the dynamic libraries. So to find in the file system the relative DLLs and to get the code from those DLLs and to patch it into the process memory. So very complex. Now, each operating system, of course, has its own support for doing this thing. In Linux, for example, we have the share objects .so. In Windows, instead, we have the dynamic link libraries. But essentially, the idea is the same. It's just that, as usual, Windows and Linux do things with different names, but the essence essentially is the same. Now, since this loading process happens dynamically, which means it happens when we start the executable, when we start the PA file, this introduces the possibility for an attacker to inject malicious code in the form of a malicious DLL. So here there's a syntactical mistake, as a malicious DLL that is loaded into the process memory. So specifically, there are two common techniques, two common pathways of attacking a binary using malicious DLLs. The first one is that the attacker can find a DLL that is used by the victim binary, by the program we want to attack, and we can overwrite such DLL with a malicious one. So essentially it means I have my program, let's call it program.exe. This program uses a DLL called lib.dll. It means that when this executable is transformed into a process thanks to the operating system, this process is gonna have a bunch of memory, of course, in the RAM of the machine, and specifically there's gonna be a text section which contains the code of the process. Part of this code is found in the static executable. Another part is loaded dynamically through the DLL. So another code is loaded dynamically through the DLL. What the attacker can do is he can replace this DLL with a malicious one. And by replacing this one with a malicious one, is able to introduce malicious code into the process memory. Another technique, which is a second way, is that instead of overwriting the original DLL, the attacker can trick the default search order used by Windows in order to load the malicious code. Because when Windows tries to load a DLL, if it's not fully specified, there is a specific search order that is used. It's sort of like, okay, first I look into this location, then I look into this other location, then I look into this other location. It's like file path. So these are all file paths in the file system. And if it doesn't find in the first, it tries in the second. If it doesn't find in the second, it tries in the third, and so on and so forth. Now, let's say that the original DLL is in the third location that the operating system tries to find, and the attacker is actually able to write on the second, the malicious one, the malicious DLL. Then the attacker can, once again, introduce malicious code not by overwriting the original one, but simply by tricking the search order. So the search order will first find the malicious DLL and only later will find the original one. So essentially this is the idea. Now, to get some intuition over these DLLs, I brought a simple example. So consider this code. This is library code that defines a very simple add numbers routine that takes two integers and returns its sum. So very, very simple. Let's compile an executable that will use this code as an external DLL library code. So what can we do? Well, first of all, I'm going to open a shell here, so on the right, and I go into source. So let's go into source, perfect. I go into simple, and here I have a bunch of files with executables because I've already compiled, but we will do it from scratch. So first things first is we analyze this lib.c. Not much to see, is exactly as the one reported on the left. So how can we compile it? Well, we can use the cross-compiler min-gw32 with the flag -shared. This flag tells the compiler, look, I don't want to compile a portable executable. I don't want to compile a full executable. I want to compile a library file, specifically a shared library file that for Windows is called DLL. So we do this, and now we have our lib.dll. And it says, look, it's a DLL. Perfect. Now, how can we use this library? I mean, this file, after all, just contains code, but this code is going to be used by another program. So how can we do that? Well, the answer is in this main.c. Let's analyze also this simple code. So what do we do in this file? As always, we include the standard headers for Windows and for standard input-output because we will need this to access the printf function. Then we do this interesting line which does a typedef. Essentially, we are introducing a type. Now, the name of this type is gonna be this label called addNumbersFunc. And the type that we are defining is a function pointer. So this is C syntax to define a function pointer. When we define a function pointer, we must describe how the function works and specifically the so-called signature of the function. Now, the concept of signature is a very common concept in computer science. It means essentially what does it take as input and what does it produce as output. And so in this case, this function takes two integers as input and it returns one integer as output. So that's how we do it. And this asterisk is because this is a pointer to a function. It's not a function, it's just a pointer to a function. This will contain the address of a function that takes two integers and produces as an output a single integer. So that's the idea. So we go into the main function. We define a bunch of variables that have to do with Windows. So h instance, and also we define this add numbers, which is of type addNumbersFunc. And notice this variable, how we will use it later on. I will mention it after. So the first thing we do, and then here we have a boolean and an integer, nothing amazing. So the first thing we do is that we load the DLL dynamically. Now, how do we load this? Well, we just say the name of the DLL, lib.dll. Notice, for example, that in this case, we are not specifying the full path. is just the name. It means that the full path will be obtained by the Windows operating system during runtime using the default search order. We are just asking it right now, can you please load the DLL called lib.dll, and Windows will do the rest. If, however, we got a null pointer, we could not load the DLL and we just return with a simple sort of like error state. Otherwise, let's say that we managed to load the DLL. Now, we want to obtain functions contained within the library, because a library is useful because we can access variables and functions, mostly functions. So in this case, we use the getProcAddress function. We pass it the references to the DLL, this H instance, and here we put the name of the function as a string, add numbers. Now remember the function that we compiled, this lib.c. We name it add numbers, and this label, the function name, is going to be represented as a string when we try to load it. So these have to match essentially. This type instead is a custom type that we created on the program that uses the DLL. We could also have given it another name, so that's really not that important. So essentially is that we get this pointer, getProcAddress, and then we cast the pointer to this type, which as I said is a function that takes 2 inputs and 1 output. Once again, if you could not find the pointer, we just return with a simple error and then we free the library. Otherwise, we call the function. And notice, when we call the function, we are just using the pointer with the typical parentheses for calling functions. And in C, this will be translated as I go to the address that is contained in this variable, in this function pointer, and essentially I call the function with these arguments. So this is the syntax. It can be confusing at first if you've never seen function pointers, but then you get used to them. It's pretty standard. So once we call the function, we just print out the result, and then we free the library. Pretty simple, I would say. So this is like a really simple library, nothing too amazing, it's just to show how we do it. So how can we compile it? Well, once again, we can just use the compiler, the standard compiler here. We can just compile with the cross compiler and we do not need to specify anything about the DLL. And now we have executed it. Perfect. Now to test it out, here I have my Windows virtual machine here, and essentially I can just transfer the file. First of all, let's just transfer the main.exe without the DLL. So we're gonna create a directory here called DLL example. I go inside this thing, perfect. Then I access the netcat in the previous directory, which is the typical one I use in this series. I connect with my host machine and then I just transfer the main.exe. Here we have a connection, perfect. Now let's try to execute this thing. Remember, when it's executing, Windows will try to search for the DLL. If it doesn't find it, it's gonna tell us. And for example, look at this. It told us, look, I could not load the DLL, so I cannot start the program. Of course, it makes sense. We just transfer the executable. We did not give it the DLL. When it tries to load the DLL, when it executes the code load library, it's not gonna find this. It's not gonna find this, so it's gonna complain. So to fix this, of course, we also have to send the DLL. So let's send also the DLL. So here I have a connection, just close this. I execute it again, and notice now I get the proper result. Result of add numbers is 5, 10, 15. When the program executed, it found the DLL dynamically, and then it was able to actually use the code contained in the DLL. It extracted from the DLL the add numbers routine, and then it executed it. Pretty cool. Now, in terms of vulnerability and in terms of offensive point of view of the situation, this means that now the final code that will run on our computer is not found all within the executable, but is found partially in the executable and partially in the DLL. So before talking about the DLL enumeration, let's view already a practical attack. So let's talk about overwriting the DLL binary. Now let's say that someone, like a malicious actor, sees this program, it's like, okay, look, I can execute main and it uses this libDLL, and maybe this malicious actor cannot overwrite the main.exe file. However, he can overwrite, he or she, whatever, he can overwrite the lib.dll file. So what can you do? Well, a first approach could be to compile a malicious library that exports the same function, so that when this function is called by the original program, we will have the malicious behavior. For example, in this case, consider this malicious lib.c. It's essentially the same as the previous one, but now we have added this system line which introduces this code, which just creates the file hacked into the downloads of quickemu user C, into this particular file path. So let's just compile this. So look, this is the malicious lib.c. It's what I showed previously. We can just compile it. We obtain the malicious lib.dll. I'm gonna share it now as previously. So now it's malicious lib.dll, and I'm gonna put it here. So it's gonna say malicious lib.dll. So here I have the connection. Actually, it should be malicious lib with the dash. Okay, so if I keep executing main, so let's also do this. Let's open another shell here, and let's go into user quickemu download. And then notice here, in downloads I have nothing. I do not have the hacked file yet. Now, if I just execute main like this, nothing is gonna happen, because like the original DLL will be used. Let's now make a copy. I'm gonna copy the original DLL in a file dll.backup like this. So I have this backup file. And now I'm gonna use the malicious lib to overwrite the original one. So I'm gonna do move malicious into lib.dll. I say, you want to overwrite? Yes, I do. Look at this. Now we have the malicious one, and look at that the size now are different, and the lib.dll has the same size of the previous malicious lib.dll. So here I'm gonna do a dir on the downloads. I'm gonna execute the main. On the outside, it seems like nothing has changed because we get the same output, but this is intended because the function essentially does the same thing. It's just that now it adds one more instruction. But now if I do dir, notice this, we have the file hacked, and this file contains the word hacks, which was created by this malicious line. So we have executed malicious code, we have injected malicious code into the dynamic library, and the user did not even realize it because the output is the same. However, in this case, there's kind of an issue. And the issue is that when the attacker has to compile this malicious library, he has to understand, he has to guess, he has to figure out what was the original function that was called by the binary. Now, it's true that this kind of information can be extracted from the executable. We will not look into that, but it can be done. However, in a very complex program, we also have to realize that even if you import like a bunch of functions like fun1 and fun2 from different DLLs, it doesn't mean that you will use them immediately. I mean, execution path can be very complex, and so maybe you will execute fun1 only in a specific set of conditions, which will be hard to recreate them. So what's the idea? How can we approach this problem? We want to introduce malicious code that will execute when the original program loads our malicious DLL. Now, in this case, the idea is to introduce a piece of code that will execute as soon as the library is loaded, regardless if we hit the correct function. And this can be done as follows. So we introduce this DLL main, which is the entry point when loading a DLL file. We put the malicious code here, and then we don't even care about this other add number. We can just comment it out. So that's the idea. With this, we will not be able to execute this add number, so we will crash the binary at the end, but we will still execute our malicious code. So this is not the most stealth approach, so to say, but it still works, because when the load library executes, we are going to execute this DLL main. Then, of course, when we try to find the number here, then it's gonna go into error and it's gonna print out could not find the function, because we do not export any add number. Now, there are ways in which you can extract this kind of information from the binary itself through reverse engineering and just analyzing the PA structure, the executable structure. However, in this case, this is like an easy win that leaves a lot of noise, so it's not really the most stealth approach, but it's still very good for this kind of, for example, for simple certification like the OSCP, you can get away with this stuff and it's gonna be fine, let's say. So let's go and compile this. So we just compiled it as previously. It's literally the same thing. So we just compile it and we just transfer it into the machine. So we just transfer it into the machine. So here, let's transfer it into the machine. We have endcat with malicious -lib. So here is -lib. We have the connection. That's cool. So now we have the malicious lib. So let's go into downloads to make sure that we have removed the hacked file. So I'm gonna rename malicious lib into lib.dll because of course the name has to match, otherwise it will not be found. And now I can just execute the executable, the main, and look, it says could not find the function in the DLL, but if I check here for code execution, I get hacked, which means that I have introduced malicious code. It's just that I cannot bring the execution to the original state. So from the outside, now something has changed. I lost that completely hidden ability, like that completely stealth approach, so to say, but still I introduced malicious code and this is what I want at this point. And so with this DLL main, essentially, you don't even have to care about finding the right function. And so to recap, in general, if you don't know which function are exported and you just want a quick win, so to say, you can use this DLL main. However, just remember that this approach is very noisy. It's not stealthy at all, and it can bring visible changes to the behavior of the program, which means that people who are going to execute the program will realize that something has gone off, that something weird is happening, and maybe they will understand that malicious code has been injected. So that's the first technique that I wanted to show, overwriting DLL binaries. Now, to discuss the other and also to discuss the enumeration, we can actually showcase a more complex example. So remember the simple service, the code for the simple service that I showed when I discussed about Windows services. Now this code is slightly changed just to introduce the loading of the DLL. It's sort of like I combined the simple example with with the service file. So now let's go and see what the changes. So now after the service has been initiated, we also load the DLL with this load DLL function. This function just takes care of downloading the reference from the library. Notice here I also use lib.dll and then I load the function pointer. So first I load the library, then I load the function pointer, and then in the actual service execution, which is the write to log function, the write to log here, I also execute this add numbers. It doesn't really make sense from like a semantic point of view in the program. However, let's just take it for granted. It's just to showcase our service now loads a DLL. Because even though this technique can be used for every sort of process and program that is executing, this affects specifically services. So a service typically can be vulnerable to DLL hijacking if it's not properly configured. And services are like good targets for this DLL hijacking. So it works for any binary, but services are kind of special binaries because they are always executing, they are always loading some DLLs. Sometimes you can even stop them and start them, so you can trigger the search for the DLLs at an arbitrary time if you are allowed to do so by the system configuration. So they are good targets. So how do we set it up with the DLLs? Well, as always, we can just go here. So let's go into the advanced, let's go into the simple, and let's just compile this thing. So we can compile it as follows. In the compilation, we do not have to change anything, because in the compilation, there's going to be written the code that calls to the linker to load the library. And that process is handled by the operating system, so we do not need to change anything. So we compile the simple service, and we compile also this library. Now, in this case, to start off, let's just compile the normal library, which means the library that is not malicious. So like this normal one. And so essentially here, I think I have the thing for compiling it here. I mean, it's really simple. I just have to say lib.dll because it's not malicious, lib.dll. Perfect, so I have this lib.dll and I can just transfer both of those files because also the executable is going to be changed. And so we can, first of all, let's just remove the hacked file so that we have cleaned it. And now we can overwrite the simple service.exe. Now, the original service did not use the DLL, we could just execute it without any DLL, but this one will use the DLL. So we can say in nc netcat, we can put the address and then we can overwrite the binary. Now at this point, we cannot start the service immediately because if we do, it's not gonna work because now the binary, the service will actually require the DLL to work. So we also need to transport the DLL. So we do lib.dll and we netcat it over the Windows box. So lib.dll. So we have connection, we go here, we do dir, we have this lib.dll. At this point, we can start the service. So we can start the service, for example, in this directory, downloads, and we can say sc.exe start simple service. So this is the service that we've been using for this video. We do start, and then essentially, it's gonna use this DLL. Now, to understand what DLLs our service is using, now that it's transformed into a process, we can use a utility called listdlls64.exe. And this is offered by Windows. In the reference here, I put a link to it, so you can find it here, this listdlls. And as always, just go into downloads and you can just download it and I just transfer into the Windows virtual machine. So how can we use it? We can just call it and we can say /accept EULA, the user agreement. So here I've already downloaded it. And then I put the name of the process that I want to list out the DLLs. So in this case, it's the simple service process. So I go here, simple service, and it says access is denied because I actually need a special shell with some permissions to do that. So I do it here essentially. So I copy this command and I do it into this other shell. And now look at this. So we have a bunch of different DLLs. It gives us the base address over which it was loaded. So this is the address in memory, in the memory space of the process. It gives us the size of the DLL. And finally, it gives us the path information. That is, within the file system of the box, where was this DLL saved? I mean, where it is saved right now. And notice that here we have a bunch of system DLLs. We have the binary itself. And finally, we have the custom DLL. We have this downloads lib.dll. This is the one we introduce, which right now is not malicious. Now, the same attack that we showed before works also in this case. So we have two ways of approaching it. Either we can overwrite by patching the custom function, or we can just introduce the DLL main. If we just patch the function, we will not crash the service, so the service will continue executed as usual. If instead we use the DLL main approach, which means that we do not export the add numbers, then in the code of the service, if we check the code of the service, there's going to be a problem. Because now here, when we load this thing, so when we do the load DLL, in this case, it's gonna, well, actually it's gonna return, it's gonna free the library. I think it's gonna crash because this one does not actually return in case of error. Here we do not check errors, but then we call the write to log. The write to log will try to use the add numbers pointer. And when we use the add numbers, at this point, it's not gonna be defined this pointer. It's gonna have a garbage value taken from the process memory, and then it's gonna crash. So I believe the service will not continue executing. Anyways, we can just try it out. So let's go with this other approach, with the DLL main approach. So we go into simple service. We go into essentially not this one, but this other, essentially advanced. We go into lib, and we put this here, and we comment everything else. And then we compile it with this one. Compile it with this, and we say malicious DLL. So we go lib.dll, malicious DLL, and then we transfer it over. So we do netcat listen for malicious lib, and then here we just do we connect with netcat, and we just do malicious lib.dll. We have a connection, that's perfect. And here I just created a backup copy of the original DLL because I don't want to lose the original one. When you do this kind of thing and you have to overwrite the DLL, make sure you have a backup copy to restore the system to its original state if it's needed. Now at this point we can stop the service, so we can do start stop, we can do stop simple service, perfect. We can overwrite the malicious lib into the lib.dll, yes, and look at this, now I do dir, there's no hacked here, I start the process, I do dir again, and notice here the file appeared because we have actually executed our malicious code, which in this case just creates the hacked file. Now, if we check the status of this process with the query command, so sc.exe query simple service, it's gonna say, look, the service has been stopped, so it's not working anymore because it was not able to find a function and so it crashed essentially. So that's the idea. If we restore back the original, so we do a copy of libdll backup into libdll, yes, and then we start it again, we do start again, it's gonna continue executing without any issue essentially. So it's gonna say running because with the original DLL, it finds the correct function and nothing essentially goes wrong. So that's the idea. So this is the same overwriting of DLL, but for a service binary. So in this case, the idea is first we figure out what are the DLLs used by a given service, and we can do this with this list DLLs, although it requires some privileges like this one. So wait, let me copy it again because it did not copy. And I've read it here. So first we figure out all the running DLLs. And then we say, oh, look, we can actually override this one. Okay, let's override it with the DLL main method that makes sure that we obtain our code execution even at the cost of breaking the service. So once again, not very stealthy. So to finish off the video, however, there is another way we can actually do this attack over DLLs, which has to do with hijacking the search order, which brings us to the name of this video after all, which is called DLL Hijacking. So if you do not specify a full path when loading a DLL, that is, when you do not specify fully where the DLL will be situated in your operating system, then Microsoft tries to find the DLL using a specific search order. And here we can talk about the difference very fast between absolute path and relative path. When we say absolute path, we are referring to a single point in the file system. Suppose the file system is this tree of files and directories. Then when we specify an absolute path, we are saying, look, this point, only this one. Instead, when we use a relative path, we are just saying the final name of the DLL, which means that Windows can actually find this name maybe in different parts of the file system, and depending on the order in which it discovers these different parts, maybe it does this first, second, third, and fourth, then an attacker can introduce a malicious one before the original one, so that the malicious one is found. Now there are lots of rules on the specific file path, but essentially the idea is that, first of all, it tries to find it in the folder of the process, which is specified by this LP file name. You can actually consider this the working directory of the process. So each process has a working directory, and the first path that Windows tries to search it over is the working directory. Then we find the system folder, which can be obtained by using the get system directory, so the get system directory function defined in the Windows API. Then we have the 16-bit system folder. Then we have the Windows directory, which can also be get by another function, the get Windows directory function. Then we have the current directory where the command has been called, has been executed. And finally, we find the directory listed in the path environmental variable. So to showcase a scenario that is vulnerable to this kind of hijacking, let's assume that the regular DLL, the original one, is found within the Windows directory. Now the Windows directory is actually in C/Windows. while we will put the malicious DLL into the system directory. And the system directory actually is found in the C Windows System32. So this is for the 32-bit system directory. So that's the idea. Let's set up the thing in this way. So first of all, DLL in C Windows. So the original one, which is the libdll backup, so this one, we're gonna copy it. So we have to do it with a privileged shell, of course. So this, we're gonna copy libdll.backup. We're gonna copy in C Windows lib.dll. So we have copied this file, and now if I do C Windows lib.dll, we have our file. Perfect. So here I'm gonna remove this lib.dll so that it's not gonna find it. Actually, I cannot do it. I have to do it from this other shell. Actually, it's because it's being used. So first I have to stop the simple service, of course. I say del lib.dll. Perfect. So now here it's not gonna find it on this directory. So, but we can still activate the server with no problem. We just say sc start. So the service is starting, and now if we check for the DLLs used by the service, notice that the libdll, which is our custom DLL, is found in the C Windows. So it's not gonna find it in the current directory, but in the C Windows. Perfect. Now at this point, let's move the malicious one. So let's move the malicious one. Let's not overwrite the original one, but let's move it into Windows System32. So into the system directory. So now I go Windows System32, and of course, actually, it shouldn't be called malicious lib. It should be called lib.dll. So let's just move it. Let's just rename it. So I move this from malicious-lib.dll into C Windows System32 lib.dll. So I do this move. Perfect. So now essentially I have in the C Windows system the malicious file with the same name as the original one, and in the Windows one the original one. Perfect. So let's stop the service. c.exe stop simple service, and let's start it again. So look at this. Here I have act. Let's remove act. So let's remove act. So I'm gonna start it again now. I'm gonna start the service again, and now I do dir, and notice I get hacked again. And if I check essentially the executable, if I check this, of course it's not gonna find them because the process crashes. But to finish off this example, let's real quickly just introduce the other kind of malicious manipulation in which we just add the code execution, but we keep the code so that the service does not break essentially. So that's the idea. So I want to give this malicious lib. I want to take it here so that I want to show that it found the different DLL. So malicious lib, perfect. And then here I'm just gonna do copy malicious lib. I'm gonna do C Windows System32 lib.dll. Yes, I'm gonna replace it, and then I'm gonna just start the simple service. So let's make sure we still have code execution. So I'm gonna delete the hacked file to show that it's gonna recreate it again. I'm gonna start it. Here we have, actually here we do not have it. Let's try to understand why. Let's do this. It found the lib, it's System32. However, what happened here is that, okay, here we have this also. But let's see this advance. So here I'm doing this thing correctly. So what happened here? Why did not create this? Okay, no, it was just a matter of time. It actually created it. It's just that this code in the simple service does not execute immediately, actually. It's every once in a while that it writes to the log because there's a timeout here. There's a sleep. So after every 5 seconds or something, it does this. And notice that even though in the Windows directory we find the lib.dll, it actually finds this one other first, which is the malicious one. So in this case, we did not overwrite the original DLL, we just place our malicious one in a path that has priority over the original one. And indeed, if we stop the service now, and we delete this hacked file, and we delete the malicious one, so Windows System32 lib.dll, and we start the service again, so with sc.exe start, and we check the DLLs used by the system, now it's gonna go back to the original one, which means we won't find this act file anymore because the original code is gonna execute. So this is the idea. We were able to introduce malicious code because we got into a priority directory and we put our malicious DLL into that directory with a priority level with respect to the original one. And so this concludes the video. Here I have 3 links to the list_DLL utility, to how we can compile a DLL using MinGW, and to the dynamic link library search order, to the Microsoft document that describes the search order for finding the DLLs. So as always, I hope the video was interesting, I hope you got something out of it, and if you did, please leave some feedback, subscribe to the channel, share this video with like-minded people to help me grow here on YouTube, and to the next video. Hi everyone and welcome into this video in which I continue my Windows Privilege Escalation series. In this video we will discuss different ways of bypassing the user account control mechanism, also known as UAC. So we will see different ways of doing UAC bypasses. As always, I will use some theory, I will introduce the main theoretical and conceptual idea behind the bypasses and behind the feature itself, and then I will show it in practice within a Windows virtual machine. So, I hope you get something out of this video. If you do, leave some feedback, positive or negative, share it with like-minded people to help me grow here on YouTube, and that's it. Please enjoy the video. So, let's begin. What is user account control? Now, I had mentioned this feature in one of my first videos of the series. Specifically, it was the second one, in which I discuss the most important Windows permission systems and Windows security features. In particular, in that video, I discussed about UAC and MIC, which is Mandatory Integrity Control. So let's review this concept and let's understand what is the relationship between UAC and MIC. So specifically, UAC is a feature that helps manage when and how applications run with elevated privileges. It requires user to explicitly authorize or authenticate before a process can gain elevated permissions. So what's the idea here? Well, the idea is that when a process has to increase its privileges because it wants to do a more privileged action, it will require the user for permission, and this is the UAC mechanism. So applications are started with the least privileges needed. So we can say if this is the lifetime of the process, we start here, so the process starts here, which is a non-privilege, like a low privilege, so like low privilege, and then maybe sometimes we want to increase our level of privileges to go into high privileges. Now, when we do this increase of privileges, in this there is a security boundary that we must be careful on how we deal with it. Because when a process increases its level of privileges, if then it gets attacked right here, the attacker will have compromised a high privilege process, which can be dangerous. So we want to be careful and we want to make sure that we only do this if we really want to do some like high privilege action in a way. And in this picture, UACT is the feature, is the security feature which deals with how this boundary is handled. Like how does it happen that a process from low privileges goes into high privileges? When an application requests higher privileges, a prompt is used to ask for confirmation, and this prompt is the UAC security feature mechanism. Now, UAC is a security feature that can have different configuration levels. So we can go from less secure to more secure. We have different sort of like this kind of prompt, this consent is asked in different ways, and it requires different kind of information to be properly authenticated. So for example, the level 0 means no prompt. It means that when a process goes from low privileges to high privileges, nothing is asked of the user. In this case, the bypass is pretty trivial because there's nothing to bypass. UAC is simply not configured. Then we have different levels, so we can have a prompt for credential on secure desktop or prompt for consent on secure desktop. Now, in both of these prompts, we are talking about this concept of secure desktop, which is sort of like a level of isolation from all the other running applications. And this is made so that malicious software that runs on a machine cannot interfere with the UAC prompt. So this prompt does not happen in any process of the system, but in isolated processes, so there's more protection. Now the first level asks for credentials. It means it's going to ask for the password of the user, while the second asks for consent. Clearly, the one is stronger in terms of authentication because you're not only saying, okay, you can gain higher privileges, you also have to authenticate as a user to the machine. You have to put the right credential for the user. So it is stronger. It requires more information. But both of these are on the secure desktop. Then we have also credential and consent, but for the normal desktop. And in the normal desktop, it allows other programs and windows to remain active and interact with the user while the UAC prompt is on screen. So it provides less isolations. And finally, we have the fifth level, which is prompt for consent for non-Windows binaries. So when we are executing a binary that is not native Windows, which means a third-party library that is not signed by Microsoft, then for those, we will prompt for the user consent. So we have different levels of configuration, and in this video, we will see exactly how they work and why they are different and things of the sort. And so this is the idea of UAC. It is a prompt, it is a security boundary that happens when a process goes from low privileges to higher privileges. So it's low, it wants to increase its set of privileges, and here UAC, depending on how it's configured, it can ask for more or less confirmation in a more or less isolated environment. Now, another thing that relates to UAC is mandatory integrity control. And here the idea is that we have different integrity level from low, medium, high to system, where low is the lowest privileges, so like not many privileges, medium is a little bit higher, higher is also higher, and system is like the highest of them all. And essentially MIC enforces restrictions by preventing lower integrity processes from writing or modifying higher integrity objects. So the idea here is that even though I am an admin user, if I start a process with a medium integrity level, then I cannot do certain actions. I cannot modify certain objects which require a higher integrity level. Even though my user can technically spawn processes with high or system integrity level, I actually don't want to do that, because to respect the least privilege design, the least privilege, what's the idea? Well, the idea is that I only want the privileges that I strictly need to perform the action that I want to perform. If I am an admin, this means essentially that if I am an admin, but I just want to create a simple file in a directory which does not really require me to have higher integrity level, then I can just spawn a shell with a medium integrity level and just be fine with that because I don't need higher integrity levels. Then, when I actually need the higher integrity levels, I can ask for more, I can increase my integrity level, and at this point, UAC comes in. So the concept, the abstract concept that we were talking about increasing the level of privileges, comes back to MIC, to the integrity level defined in MIC, which can be either low, medium, high, or system. For example, if I am a shell running at medium and suddenly I want to increase it to high, this is a security boundary which can be protected with UAC. So that's essentially the idea. And indeed, what's the relationship between UAC and MIC? MIC and UAC work together to restrict unauthorized access and manage privilege escalation problems. MIC provides the underlying enforcement mechanism for integrity levels. So essentially it is the access control mechanism that Windows uses to handle privileges and authorizations essentially, while UAC provides the user interfaces and the mechanism for increasing those privileges if it is required. So when a standard application attempts to perform an action that requires elevated privileges, UAC triggers a prompt. Then, if the user consents or if the user authenticates depending on the UAC configuration, the process integrity level is elevated from medium to high, for example, or from high to system. So to recap, MIC enforces a policy-based boundary based on integrity level, while UAC controls how and when processes can cross those boundaries. So that's the idea. Now let's go into practice, because this was a lot of theory. It can be boring, but the important part is, okay, let's see how this concept play out in real Windows system. So let's say that you have a real Windows system, you have a shell on it, and you want to understand how UAC is configured and how maybe you can bypass it. So let's first enumerate the UAC configuration. How do we do that? Well, we can actually read some registry entries. For example, this one, this HKLM software Microsoft Windows current version policies and system, and from this we're gonna select the object enable LUA. So this is gonna tell us if UAC is enabled. Specifically, if it is enabled, we will get a 1. And to read this value from the registry, as always, you can use either PowerShell with the get item property, or you can use the cmd.exe with the reg query command. For example, let's do this first, get item property. We will need PowerShell. Here we have it. We're just gonna do this, and look at this, we have enable Lua 1. So we have it enabled. If we open a shell, a command prompt, then we can just do reg query, essentially this one, and here we get reg dword 0x1, which means it is enabled. So all good. So this is the first step. Is it enabled or not? The second step is, of course, okay, what kind of configuration level do we have? Because remember, it's not like UAC is just a binary setting. Either it's enabled or it's not. It actually goes into 6 different levels, from 0 to 5, where 0 is no prompt and 5 is prompt for consent for non-Windows binaries. So how do we enumerate the specific level? A different registry item. And so to read the specific configuration level, we can read another registry entry. Specifically, we have to read the consent prompt behavior admin, which we can read with this simple PowerShell command. So get item property, this is the registry key, and this is the value that we want to extract from that registry entry. So we do this, not in the cmd.exe, of course, but in the PowerShell. And notice that we get this level 4. Now level 4, we go back to this, means prompt for consent on the normal desktop. So we will see essentially what this means. So we have this value. Let's say though that we want to set a new UAC level. How can we do it? Well, for example, we can use the cmd.exe syntax to change the registry entry. Essentially, we can do reg add. We put the policy system entry here. Then we put the value that we want to change, and we put the new D. In this /D, we put true. For example, in this case, it's gonna change it to true. Of course, to do this action, we need to have certain privileges. If we just do it on this shell, look at this, it's gonna say access is denied. Now, why does it say that access is denied? Because the interesting thing here is that if I check my groups, the groups I belong to, which is the user quickemu, if I say, for example, who am I, okay, this one is who am I, but if I say who am I /groups, it says, look, technically I am in the administrator group here, built-in administrators. But in this specific process, I'm actually running with a medium mandatory level. So in the MIC integrity levels, this is just a medium shell. It means that it is limited. I cannot simply get access to the entire system, not because my user does not have access to those, but because the process that the user spawned, which in this case is the PowerShell, has medium integrity level. So here, there's just a big thing to understand is that one thing is the privileges of the user, which in my case, for example, this quickemu has the built-in administrator group. So it is a privileged user because it belongs to a privileged groups, but this thing is not necessarily the user privileges are not the same as the process privileges. And when I interact with a system, for example, let's say that I have a reverse shell that I obtain in a system, I'm dealing with a process, and the process integrity level might be different, might be lower than what it can actually be. So the point now is, okay, how do I increase it? How do I go from medium to high? Well, going from medium to high requires elevating privileges, therefore requires bypassing an UAC prompt. I mean, in a way, I have to pass a UAC prompt, and if I'm a malicious actor, I have to bypass it. I have to find ways of bypassing the prompt. So this is the basic idea. And we will see in this video ways in which I can go from medium to high, which is a typical vector for privilege escalation. So at this point, we can start to talk about UAC bypasses, which is clearly the most interesting part of the video, which is the point of this video. However, before talking about that actually, let's see in practice the various levels at play, because it is really important to have a clear understanding of the feature we want to bypass before we actually bypass it. So how can we get this clear picture? Well, the idea is that we're gonna start from the no prompt level, and we're gonna go up to the 5th level, to the prompt for consent for non-Windows binaries, step by step. And to do this, here we actually get this command, the start process. And actually, we're just gonna modify it a little bit, because this start process is gonna be used to increase the level of integrity. And specifically, here we have the file path that we want to execute. In the future, I'm gonna execute an endcat, but for now, I'm just gonna execute a PowerShell instance, so very simple. PowerShell.exe. I'm gonna remove the argument list because I don't need it. I'm gonna remove this Windows style hidden because I don't need it. And then I'm gonna keep this -verb run as. Now this run as is gonna try to increase the integrity level. It means increase the integrity level, and depending on the UAC configuration, we will see different behaviors. So we take note of this command, and then we take note of the command to change the UAC levels like this. So let's start from UAC level 0. So here I go with I need an administrator prompt. So I need an administrator prompt here. It's gonna execute this as administrator. And notice that it tried to ask me for the UAC prompt. What we saw was a UAC prompt, but we will see them better and more slowly, so don't worry. So let's start with level 0. So this is level 0. I just modified the UAC prompt to be level 0. Let's see what happens when I do this. So notice here, I am a mandatory medium integrity level. And if I check my privileges, there are not that many here. But I can do start process file path PowerShell verb run as. I get a new PowerShell, and notice this. I say UMI groups, and I'm high mandatory level. And if I do UMI priv, I have way more privileges, because now the integrity level of this process is no longer medium, it is high. So it's much stronger, clearly. And notice that in the increase of privileges of integrity level here, I go from medium to high, no UAC prompt has appeared because it is not configured to appear. So this is the level 0 essentially. If we have level 1 instead, notice what happens. I do this, and now I get this UAC prompt. I get it on the secure desktop, because nothing that I cannot interact with other application. So there is a level of isolation between this process, the process responsible for this window and for this password, essentially for getting this password, and all the other processes of the system. Here I have to put the password of my user, and then when I'm gonna put it, I press yes, and the process is gonna spawn. So for example, here I have the password, I press yes, and now it spawns the process. So this is UAC with level 1 essentially. I say UMI groups. Once again, I have a high mandatory level. I have a high integrity level. So let's go number 2. Let's do this. Notice now that it does not longer ask for credentials, it asks for consent, but it asks for consent in the secure desktop once again, because it's isolated from all the other application. I say yes, and it spawns a shell. And here I have essentially once again the high integrity levels. I'm just showing it for transparency, we can say. Then we increase it to 3. 3 is gonna change, because 3 now, look at this. It asks me once again for the password, but I am no longer in the secure desktop, because look, I can interact with other processes, so there's no longer isolation. So this is the difference, the practical difference between here secure desktop and normal desktop. You can see it clearly here, right? And so once again, here I have to put my password, and then it's gonna spawn a shell with higher privileges. Not gonna put a password because we already understand this. Then we put 4, and notice here, it's gonna ask me for consent. Consent on the normal desktop. I say yes, and I have a shell with higher integrity levels. So that's essentially the idea. Here is coming down stack a bit. It's loading, perfect. Then I put level 5. I start PowerShell, and it asks me, essentially, do you want to allow this app to make changes to your device? So it still asks me for consent, essentially. Show more details, verify, publish, and Microsoft Windows. So even in this level 5, it actually asks me for stuff. I don't know why, maybe PowerShell is considered a non-Windows binaries. I'm not sure exactly on this level 5, but that's the idea, essentially. So as you go up, you get more wide with respect to how many things you ask the prompt, essentially. So this was just a quick enumeration, a quick viewing of the different UAC levels. And finally, now we can actually discuss proper bypasses. So in this video specifically, I'm gonna show 3 different bypasses. The first one is super easy because it's at level 0, so there's technically no bypass. The second is on level 5, and it uses the fodhelper.exe, which is a Windows binary, which is like internal, a Windows binary. And then we have level 1, 2, 3, and 4, which can be bypassed using a different technique, which has to do with always install elevated configuration, which I'm actually gonna talk more thoroughly in a future video. In this video, we will just use this, we will just see this technique in action to bypass the UAC prompt, essentially. That's the idea. It is also worth to mention that like a lot of UAC bypasses have to do with DLL hijacking. And I've made a full video about that technique, which involves introducing malicious code as a DLL and then either overwriting original DLLs with malicious one or tricking the Windows search order to find the malicious DLL before the original ones. So it's a common technique used to, you take a program that immediately starts out with higher integrity levels, and then you do DLL hijacking on that specific process, and you get higher integrity levels without going through the UAC prompt. That's the key idea. So let's start with level 0. Level 0 is super easy because once again we just use this start process, we just say run as, and this is going to increase the integrity level. Since there's no UAC prompt, we can just bypass it because essentially there's nothing to bypass. I mean, it's very, very simple. So here we put integrity level 0. Here I'm going to put a listener to the port of 4321, and then I'm going to execute this command. So consider this scenario. I obtain a reverse shell. I am inside the system, but I do not have full access to the privileges of the user because I am running with a medium integrity level. And I can check that with /groups. This is medium mandatory level. It's not good. I want high, I want higher. So what do? Well, I check the UAC. I go like, okay, wait a second. Let me enumerate the UAC level. So let me do this get item property, whatever, here. Okay, look, it's 0. It means I can easily bypass it. Perfect, I just do this. I just do start process with a netcat with a reverse shell command, essentially. And let's just do it from the middle integrity level. And look at this, I have a shell. And not only I have a shell, but I have a high mandatory level shell. And in this shell, I have all the privilege that I can access. I can get full access to the fact that I belong to the administrator group. So that's essentially the idea. So this is the first bypass. As I said, pretty simple because there's actually no bypass. And so the level 0, as I said, was pretty easy. Now let's go into a more interesting level, which is level 5. Let's say that I have a level 5 UAC configured. Now in this case, if I try to start the previous command here, it's gonna ask me for this prompt on the graphical interface. And so it's not easy to bypass it from the PowerShell command line. So how do we overcome this? How do we bypass this consent? So that's the idea. Well, the idea is to use this fodhelper.exe. Why do we want to use this utility? Because this is actually a Microsoft utility. It is a program found in the system and is signed by Microsoft. And how can we check that it is signed by Microsoft? We can use this sigcheck.exe, which is a sysinternal utility that you can download here, sigcheck in learn.microsoft sysinternals, so you can just download it essentially. So how do we use it? Well, you just do sigcheck.exe, then you put some flags, you point to the fodhelper.exe, and look what you get. Essentially, you get a bunch of data, and you get a bunch of XML, and in this XML, it says auto-elevate true. So essentially, that's the idea. It's going to auto-elevate the integrity level without requiring a UAC prompt. So specifically, how does this bypass work? Well, we can use this Windows utility with this FOD, which stands for Features on Demand, to bypass the UAC prompt. Now, specifically, Windows treats the fodhelper.exe as a trusted system application, which means that it runs it with high integrity without triggering a UAC prompt. Now, this specific attack works in two steps. In the first step, the attacker modifies a registry value in order to configure the malicious command that will be run with higher integrity level. And then in the second step, the fodhelper binary is executed. So the setup of the attack involves modifying the registry, but in a way that we have access to it. So the normal user has access to it. So what do we do? In practice, first we create the registry item with the command new item at the path hkcu software classes ms settings shell open command with the -force flag. So we just do it here in the medium integrity level, and it says, look, I open this thing. And then we can configure it with the malicious values to execute a cmd.exe. So specifically, here we have name default, and value here is the command. So the command is in the value of the key default, and then the delegate execute has to be empty. So we add the two item properties. One is the default in parentheses, which contains the malicious command. The other is the delegate execute, which has to be empty. So for example, if we want to execute a reverse shell, we can just put in the value here the typical command for a reverse shell here, set a property. Then we put the second value empty. And finally, we just execute the fodhelper binary. So we do fodhelper.exe. Notice what happened here. We got a shell, and this shell runs with higher privileges because this shell runs with higher mandatory level. So we did not see any UAC prompt because fodhelper starts as a higher integrity level process. It does not pass a boundary. And when it passes a boundary, it's signed by Microsoft, so it does not trigger the UAC prompt regardless. So there's no UAC prompt, and we still got a high mandatory level shell. So this is a typical way in which this can be done. And so to recap this bypass level 5 of UAC, we use fodhelper.exe. Now, does this bypass also work for other levels? Well, let's try it out. Let's put, for example, level 4. Which should ask for consent on the normal desktop. And let's just do this thing once again. So let's just call here from the low here, we call fodhelper. Notice that it asks for UAC prompt. So it does not work for level 4, it does not for level 3, 2, or 1. So it works for level 5, because if we put here 5, it's not gonna ask us a prompt. Look at this 5 here, but we execute this. No prompt, we get execution, very good, but it doesn't work for level 4, 3, 2, or 1, clearly. So how do we do that? Well, if we have, for example, let's say we have level 1. Level 1 is the hardest, right? Because level 1 we have password in the secure desktop. Wow, how do we even bypass that, right? Well, in this case, there are other ways. So the idea is that you find a process that runs with higher integrity levels, and you try to hook into that. You try to sort of introduce malicious code into that. For example, one way is to use the always install elevated configuration, which is a configuration that if enabled, it runs like MSI packages, so installation packages with higher integrity levels, also with the integrity level of system, so that's the highest. And this also will allow to bypass any UAC levels, essentially. So here I have a small demo. I will not discuss fully this thing because I have prepared a full video on this, but how does it work? Well, let's say that in our machine, we have a malicious package, this sample2.msi. So essentially the idea is that let's put a listener to port 777, and let's install it with this command msi exec /quiet/qn. I have to go a bit better. So I'm gonna do this, Notice what happens. I get a shell, and notice even more. If I do groups here, this shell has a system mandatory level, which is the highest integrity level. Now, why was I able to do that? Because this is a malicious package, and the system is poorly configured with this always install elevated configuration in the registry, which allows me to obtain this kind of integrity level when installing new packages. So that's the idea. If you want to know more about this, you just have to wait for the next video, because I've already prepared it. I'm gonna record in a bit, where I discuss about always install with elevated privileges escalation. So like the escalation using this always install with elevated privileges configuration. So that's the idea, and in this video, in the future video, we will see how to create a custom MSI and how to exploit and how to do configuration check, you know, the usual thing essentially. So this is it for this video. Here are some references, but I hope it was interesting. I hope it was a fun experience. I hope it made you understand what is the point of UAC, how we can bypass it. Of course, I did not show all the different ways in which you can bypass it, because it's not like there is an exhaustive list of such ways. As I said, most of the times it happens with DLL hijacking on specific binaries that run with higher integrity levels. However, the general idea, the intuition that I want you to build on this topic is UAC happens when a user goes from lower integrity levels to higher integrity levels. So the idea to bypass it is to start from a higher integrity level, or to use specific systems that start with higher integrity levels, such as the FODHelper.exe. We can bypass it with FODHelper because at level 5, FODHelper, since it's a Windows like trusted binary, it does not ask for UAC prompt, because in level 5, UAC prompt is asked only for non-Windows binaries. So for a subset of all the binaries in the system, and in level 5, FODHelper is not one of those, so it bypasses the UAC prompt by its own nature in a way. So that's the idea for the UAC bypass. So this is it for this video. I hope it was fun. Share this video with like-minded people, subscribe to the channel to help me grow and to motivate to make even more videos like this, and to the next video. Hi everyone, and welcome to this new video in which I continue my Windows privilege escalation series. So in the previous video of the series, we discussed about the user account control bypass, so the UAC bypass, and at the end of that video, I showcase a specific UAC bypass that involved the usage of the configuration always install with elevated privileges. Now in this video, we're going to talk about this configuration, the always install with elevated privilege configuration, and we're going to discuss why it represents a security issue and how it can be exploited to obtain code execution with higher privileges. Therefore, it can be used to do privilege escalation. Since this attack has to do with the creation of malicious MSI packages, at the end I will show a little extra on how to create a custom MSI. And as always, I will introduce the main ideas and concept, and then I will showcase everything in a practical way using a Windows virtual machine. So I hope the video is enjoyable, I hope you get something out of it. If you do, subscribe to the channel, share this video with like-minded people to help me grow here on YouTube, and that's it. Please enjoy the video. So let's start by discussing about this feature, which is called always install with elevated privileges. Now, it's a really simple feature, so it's not gonna take that much. Essentially, the idea is that if you have this configuration in your system, then this is a policy setting that allows users to install software with elevated permissions, even if they are not administrator, even if they do not have the higher integrity level. So the MIC level, even if it's not high, you can still install software. Now, what's the problem here? The problem is that during software installation, potentially arbitrary code can be executed. This means that software installation is a very critical moment within an operating system, because typically processes that deal with software installation, they need to have higher privileges, they need to have a high level of rights in the system in order to write into specific directories in order to overwrite eventually environmental variables and things of the sort. So for a whole bunch of different reasons, when software is installed, the process handling that installation typically runs with higher privileges. Now this becomes a problem when we allow anyone to install new software even if they are not administrator. Because if anyone can install new software even if not administrator, essentially it means that everyone can execute arbitrary code as a high privilege process. So in this case, the idea is pretty simple. We have a user which typically runs with a low privilege, so a user with low privilege. But then this user wants to install a software, and to install the software, you need higher privileges. And if any user is able to install any software without restriction, then users have a way essentially to escalate their privileges. How? By creating custom and malicious MSI packages, which is a Microsoft installer essentially. So that's the idea. So how do we check how we are configured with respect to this option? There are two ways. One is with the GUI and one is with the command line. I prefer the one with the command line, but I'm gonna show you both for completeness. So since we're talking about a policy, to actually see it, we have to open the program gpedit.msc. So we go into the virtual machine, we type this gpedit, essentially gpedit.msc, which is the program. So here I have to actually put my password, and this has to do with the UAC level actually that I showcased in the previous video, whatever. So in here essentially, now I'm just gonna put it down because it's gonna be easier, just do notes like this. So there are actually two different configurations, both of which have to be enabled in order for this configuration to work. The first one we will see in the computer configuration section. So we go computer configuration, then administrative templates, then Windows components, then Windows installer at the end here, and finally always install with elevated privileges, and notice that it is enabled. In this case, let's actually disable it. So I'm gonna do edit, and actually I'm gonna go disable. So edit disable, and then I'm gonna say okay. Perfect. So now I have disabled it. So this is the first one. So computer configuration, templates. So here there's some typo, templates, Windows components, Windows installer. A similar configuration has been done also for the user configuration. So user configuration, administrative templates, Windows components, Windows installer, so here, and then always install with elevated privileges. Once again, let's just disable it to understand what it means to have it disabled. So this is the idea essentially. So we can just lower this and press OK, apply and OK. So now it's disabled on both. So this was the graphical way essentially with the local group policy editor with this tool. However, this is boring, so we want command line tools. That's much better. So here I have two CMD shells. This one runs with a medium mandatory level, so medium integrity level, while this other runs with a higher integrity level. So it means that in this one, in this white one here, we are privileged, we have access to more privileges. In this one, we are limited to a medium integrity level. So that's the idea. Now we can read the configuration with the function getItemProperty. We go into this specific registry key, HKLM, software policies Microsoft Windows installer, and we obtain, we read the item property with the name always install elevated. So we do this, we copy it here, and we get of course a 0 because we just disable it. We get a 0 for both the computer configuration and also for the user configuration, which has the same registry path, so software policies Microsoft Windows installer, but it starts with HKCU instead of HKLM. So we do the same thing and we should see another 0 essentially. So this is a safe configuration, meaning that it is disabled. For the configuration to work, both of these values have to be 1. Now what does it happen if they are 0 instead? Now to check what happens when we have this configuration at 0, so when it's not really activated, when this property is not activated, here I have a simple MSI file called sample. I can just click on it And notice it says it asks me for the user account control permission. So to install the software, I need to pass a prompt, which is gonna increase my integrity level. But if I don't pass this prompt, then I cannot install the software. So that's the basic idea. Of course, it's not gonna be able to install this package because it is malicious. But what's the idea here? The idea is that to actually install this software, I need to do a UAC bypass. So I need to do UAC bypass. What happens instead if we have this as level 1? So let's go to our commands here. I'm just gonna go to the nodes. So to actually put it to 1, we can just use this set item property. Of course, we do need to have a privilege shell for doing this. We do not need like this one with the medium integrity level is not gonna work because we do not have enough privileges here. Clearly, access denied, permission denied. However, this one, it has enough privileges. So we're just gonna copy the instruction. So I suppose I need to copy better because it doesn't get it. Okay, I'm gonna set it for the local machine and also I'm gonna set it for the user account. So now they are both valued once and we can quickly check it by doing a get item of LM and a get item of CU. And look at this, they are both 1. Now notice what happens when I install this thing. Notice that now it does not ask me for UAC anymore. It simply bypasses that point and it starts to install it. Now, why is this malicious? Why is this bad? How can this be exploited? So, let's say you have this configuration in your system, which means that both of these results, they get you 1. So, both values are 1. How can we exploit it? Well, pretty simple. Look at this. 2 lines and we get higher privileges. The idea is that we're gonna generate a malicious MSI package, a software install package, a Microsoft software installer, which is the abbreviation of MSI. So MSI means Microsoft software installer. And then so we can generate it with MSF Venom. So pretty simple. Here we put the payload we want. So we want a reverse shell in TCP. This is our endpoint. So 192.168.122.1 port 777, 7, so 4 sevens. And then here in the format we say MSI, Microsoft Software Installer, and we call it sample2 or sample whatever. Let's just call it sample for simplicity. This is we do in our Kali box. Then we transfer this file over the Windows machine, and within the Windows machine we execute it with a simple MSI exec. We put a bunch of flags to make this process quiet so that it does not pop up any other shell or whatever, like /quiet, /qn, /i, and then we put the name of the MSI package. And then we will have code execution, we will have a reverse shell on our target machine. So let's do it, it's really simple. Here I have another generated, but I can remove it because I don't need it. So let's do it, MSF Venom. So we're gonna generate this. And then essentially we go to our Windows box here. I'm gonna delete this 2 because we don't need it. And then, so let's go here in the CMD. So I'm in downloads. I'm gonna do netcat. So here I'm gonna put a listener to transfer the file. I'm gonna transfer the sample.msi which was generated with MSF Venom. And then here, essentially I'm gonna transfer it over to the machine. Notice I get a connection from the Windows virtual machine. So I can just stop it here. Look at this, now we have this installer. At this point, I just need to set up a listener to receive for the reverse shell connection. So the first one is for file transfer. The second one is gonna connect back to the reverse shell, which will allow me to execute arbitrary code as the admin account. So look at this. So in this shell, here I am UMI groups. Notice I am medium mandatory level. It means that I do not have full access to the machine. However, if I do this MSI exec like this, I can just copy it and I paste it here. Look at this. Look back, look down here. I have a shell. And if I do UMI groups on this shell, I get system mandatory level. So my level increase and now I have access to the entire machine. I have access to all of these privileges and in general I can do essentially what I want because this is the highest level I can get within this local machine. Why did this happen? Because the machine was poorly configured, it allows for this always install elevated property and it also allowed for a user to load an arbitrary MSI package. So combining these two things, I can just get simple access to a privilege integrity level, which in this case is system integrity level. And here another way to do it is much simpler. I put another listener, and here I just do ./sample. It's gonna execute this, and it's gonna give me the shell. However, in this case, it's gonna spawn these windows, which could be problematic if there is like someone viewing the desktop for this user. So in general, it's much quieter to just use the MSI exec. So this one, which does not spawn anything, but I still get remote code execution, I still get the reverse shell, which I then can use for whatever purposes I have in mind. So essentially, that's the idea. That's the core of the video. As I said, pretty simple because it's just a simple misconfiguration that you can have. If you are configured that in this case, the always install with elevated privileges is 1, then be careful on what kind of files you allow the users on your machine to install. If they can install MSI packages, then it's super simple. It's super simple because it's really simple to obtain then higher level privileges. Now to end this video, I actually want to show a little bit of an extra chapter, we could say, which is not strictly needed for exploitation. I mean, we already done here because this is it. This is all you need. It's a simple MSF Venom line. Of course, this payload does not evade antiviruses, EDR system, and things of the sort. This is not the objective of this course for now. Maybe at the end I will briefly mention about those kind of things, but in general, that's the basic idea. Once you have this payload, then you can add on top obfuscation techniques, you can add on top loader techniques so that they are able to evade antivirus, EDR, and system like that. So that's the idea. But now the idea is that, okay, how do we create a custom MSI that will execute a custom command? So not only a reverse shell, but any sort of custom command that we want. And to bring this example, I'm actually going to use Wix toolset, and specifically the version 3.14.1, which allows exactly to create a custom MSI in what I would say is a pretty simple way. So not too complex, and we're going to be able to specify exactly how the build of this package has to be done, so that at the end of this process, we will have full control over what's going to happen when a user clicks on the MSI package. And so for this POC, for this proof of concept, I'm going to use Wix version 3.14.1. Now, this is important to mention. Use this version because for more recent version, which goes up to version 5, I actually not found documentation that was easy to follow. I mean, I did not want to spend too much time reading the documentation for the system. I just wanted something fast that I could use, that I could modify, and this was the earlier version that allowed me to do this essentially. So that's the idea. 3.14.1. You can just download it in the GitHub project in the releases with this particular version. So in this case, in this machine, I've already installed the program, and essentially here, I'm not sure where I think it's in simple app. Yes, in this simple app, here I have an example. And so specifically in this case, you just copy this GitHub, you go into the Windows machine because this is where you're gonna have to install it. Let's open Safari, let's go into paste, and here, so I can just close this because we don't need it. And in this, you can just download the executable here, Wix 314exe. Then you click on it, you do the installation, it's pretty simple, nothing too crazy, and then you have it installed. Now, how can you use it? Well, the program that's going to install is going to install a program in this path. So in C program files x86 / Wix toolset version 3.14, we can go into this specific path, for example, with a different shell here. So I can just go into that path. And notice that here, okay, maybe I need to put quotes here because there are white spaces. And here I have a bunch of different programs, like a bunch of different executables. And out of all these executables, we're just going to be interested in 2, which will allow for the build of a simple MSI package. And these are the candle and light. So candle.exe and light.exe. To actually make it easy for you, here I also put the command to update your path, which is the environment you are working with essentially. So this is the path. So you can just open a shell. For example, let's say I open it here. I go and I say set path. Actually, okay, set path. And now I can do candle.exe I think it's not actually like this, but it has to be on a command prompt. So it has to be on a command prompt. And then I can do candle.exe and I get access to the candle utility, or light.exe and I get access to the light utility. I can also do just candle and light, it's the same, it doesn't really change. So once we have access to both of these programs, we can use this sample XML to essentially introduce our malicious code. Because notice what happens in this sample. So it's a really simple file here, just a bunch of tags. And among these tags, we find here the CMD line tag, like this attribute CMD line on the property tag, that says CMDexe UMI groups, and it just cuts it out in the desktop of quickemu into a file named test.txt. So what does it mean? What does this file essentially represent? Well, this file is used by the Wix toolset to understand what to do when installing the package. In this case, it's going to be a very, very simple installation process, because we just want to introduce our malicious code, which is this line, and that's it. And then we want to stop. So that's the idea. We have this custom action, and in this install execute sequence, we say, okay, custom action stage 1, custom action stage 2. In this one, essentially, here it fails on this fail here. In this stage 1 instead, we are executing the command CMD line, which is this one. So essentially what we're going to do is just execute the command and then stop the execution. So that's really a simple idea. This is a simple script. What we can do here, for example, that I have it in this simple app directory. I have it here. I have a bunch of other files, which for now I don't need. So I can remove these files. I can remove the sample MSI. So the only thing that I have in this directory is this sample.wxs. I open it with like Notepad or something. Like Notepad is good. And notice this is exactly the XML file. It's just that right now I have a reverse shell in here, but it's the same thing, you know, I just whatever. Like for example, here I have a typical reverse shell that will start a reverse shell on this endpoint. Very, very simple, but the structure is the same as the one before. So let's say we have something like that. How can we use it? Well, just two simple commands. Candle, which will transform this file into a Wix object. So this is the first thing we do. We do candle of the file. So let's go into the simple app folder here. Simple app folder. Here I have this sample.wxs. Then I do candle here. It's going to generate essentially a new file, which is this Wix obj, so Wix object. And then I do light. I can also remove the exe here, it doesn't really matter, whatever. Here the name is important, I have to say sample.wixobj. It's gonna give us some warnings, but we don't care, some errors, but we don't care, because at the end of the process, we still managed to obtain our sample.msi. And since our sample.msi was built with this malicious file that contains the reverse shell, now we can just set up a listener once again. So we're gonna set up a listener here. 7777, and then I'm gonna do the typical installation, so MSI exec quiet sample, so this one, and look down here. I have essentially a shell as, so I'm like UMI group. Actually, it's UMI, I would say groups. Okay, no, not group, but groups. And here I have system mandatory level, so system integrity, which is the highest. Notice that in this case, we actually spawn this window, because this window is actually the process for netcat. So I obtained this reverse shell through netcat, so this window is kinda like not that good to have, but we can just modify the command to avoid having this window spawn. It doesn't really matter. I mean, in this file, where it is the, so let's open this sample, this one, open with Notepad. In this file, we can essentially put anything in this specific line. And when we install the program, so the full chain essentially is we obtain the MSI from this sample, and then when we do this MSI exec, here we have code execution. So when we're gonna install this package, the payload we put on this file is gonna get executed, which in this case is gonna give us the shell with system mandatory level. Why? Because in this system has been poorly configured with the always install with elevated privileges. So that's the chain. So this was a little bit of extra just to show how you can construct a custom MSI. I think it's a pretty cool thing. Let me know what you think. And essentially this is it for this video. Here I have a bunch of references on the Wix toolset and how to modify the Wix installer to run as admin. It's like an old forum, I just had some problems using it and then I made it work by changing a flag essentially, and specifically it was it was impersonate. So before it was impersonate yes and it wouldn't work. Now I said impersonate no and it does work. So essentially that's the idea, couple of references. So that's it for this video. I hope it was fun, I hope it was interesting, I hope you got something out of it. If you did, let me know, leave some feedback, subscribe to the channel, share this video with like-minded people to help me grow, and to the next video. Hi everyone and welcome to this new video in which I continue my Windows Privilege Escalation series. In this video we will discuss some of the most important files with sensitive data in the Windows operating system. Specifically, we will talk about history logs of PowerShell, about the SEM and system file, and especially the SEM, which is the Security Accounts Manager, and we will talk about how we can dump the contents of this file using Mimikatz and the SeBackup privilege, and then at the end we will talk about the registry hives. And as a little extra, I will mention something about configuration file, paging file, and hibernation files, which can also potentially contain sensitive data. However, these things are application dependent, while these other things are always there most of the time, so are more critical, I would say. So, as always, I hope the video is useful, I hope you get something out of it. If you do, leave some feedback, share this video with like-minded people, and subscribe to the channel to help me grow. That's it, enjoy the video. So let's discuss history logs. Now, any command we write using PowerShell could be saved in the history, which is a txt file. It's a simple file that contains the command history. So the history of all the commands that we wrote. Now, to get the history in the current PowerShell session, we can use the command getHistory. For example, consider this is a Windows 10 machine. We can open a PowerShell session here, and we can write a bunch of commands. UMI, ls, dir, cd, cuser, quickemu, desktop, a bunch of commands, perfect. Then we can do the get history, and we will see the current history, the history of the current shell. So the first command we executed was UMI, then we find ls, then we find dir, and then we find cd. So in this list, we just see the commands in the current session. Essentially, notice that we do not get the outputs, but only the command. Now, there is a particular file in which these commands are written, which is the history file. Now, to understand where this file is located, we can use the following command. So get ps read line option history save path. So we do this. So no, actually I copied wrong. So let's clear it. Let's copy it again. And notice here I get cuser quickemu updata roaming Microsoft Windows PowerShell ps readline console history.txt. Now this is a very critical file because sometimes certain commands can take credentials, for example. So I write, for example, a CMD where I put my user ID and I put a password, and this thing will be saved in the command line. So this is the value of the password. This thing will be saved in this file, which means that if I get access to another user PowerShell session, I should check both the history in the current session and also where the history file is located. So let's read the history file on the current machine. So let's clear the screen and let's read this file. So I'm gonna copy the path, and to read it I can do more and then the path. And notice here what do I get? I get a bunch of different things that I've done like the other day to test this out. We will talk about these commands, but essentially here I create a service for the QEMU setup of Windows. I mean, the idea is that in this file you can get a lot of information, even critical ones. So it is considered a file with sensitive data. If a user writes the password into this file and you can read it, then you can maybe obtain a privilege escalation, because maybe you can pivot to a new user, to a service, you can enter into a database. This of course depends on the application. And here are the default location for the Windows and Linux. So notice that in Windows we have the app data folder. This is on the user profile, which is the default path for the user. So in my case, it is C users quickemu. And notice that this path is the default one, so nothing special here. There is also in Linux, because you can use PowerShell also in Linux, it's on the local folder in the home directory of the user. And so this covers the history. Very simple, but also very, very important to check anytime you get access to a new system. Always check the history. It could contain sensitive data. Oh, and also, other than checking the history, which is an important file, make sure to check out also the environmental variables. You can do this with the command dir env:, because once again, environmental variable could contain sensitive data. This is not a file, strictly speaking. However, it is still very useful because it could contain sensitive data. So that's the idea. Here we have the name of the variable on the left, and on the right we have the value of the variable. So always make sure to check history and environmental variables. Now, another potentially dangerous feature of PowerShell is the transcript feature, which is used to keep track of all the commands we execute. Now, this thing is less obvious to attack, is less common, because you actually need to explicitly start a transcript with the following syntax. So you start the command and you give it a path where the log file has to be saved. So in this file, we will log all the commands we write in the session. And then at the end, we just stop the transcript. So for example, if I were to start it in this machine, so here, so if I were to start it here, and then I do a bunch of commands, wmi, dir, whatever. At some point, so like let's go back one directory, I do once again dir, and then I do the stop transcript. So stop transcript. Then the file is this log.txt, and we can see it here in the desktop. And notice that in this case, we see a bunch of general information about the machine and also the commands with the output. So a transcript is actually more rich than the history, because the history only contains the command we execute. It does not contain the output, while with a transcript we also obtain the output. This thing, however, is harder to abuse because there is no default path for transcript. The user has to specify such path, and many times users do not transcript stuff. While the history is an implicit mechanism, it is used even if you don't want to, and so it's much more dangerous, the history. Also, with the history, a reason why we typically don't want to execute programs where we put sensitive data into the command itself, like for example, I connect to a VPN and within the command line I also put the password. We don't want that, exactly because such commands get logged into the history, and the history is a sensitive file that typically can be read, so we don't want to do that. So a general like best practice when it comes to coding and designing codes is to develop interfaces that do not take sensitive credential within command line parameters, but in case they can ask user input during the execution, so that the data is transferred through inter-process communication mechanism to the process itself without being logged in the history. So that's a general idea that we want to implement. And so this is it when it comes to history logs. Now, at this point, we can talk about the more juicy part of the video, which is the SEM file. Now, SEM stands for Security Accounts Manager, and it is a file, it is a critical component of the Windows operating system. Why is it critical? Because it stores user account credentials for local accounts. So, when we have any system that has to do with, that includes an authentication procedure, so where a client interacts with a server to establish a session, generally what do we have? We have that the client has to send authentication credentials, and the server has to check those credentials to make sure that the client is really who or she says to be. Now, how do this process happen? This also happens in a web application. So the idea is that the client sends the username and the password, so username and password to the server. The server has a database that stores information about authenticated user, so a data store. Within this data store, the server does not store the password directly, as that would introduce a security risk, but rather it stores the hash of the password. And we will talk more in detail about hashes in the next video, about hashes in Windows. Now, for this specific video, what we need to know is that the database in question is actually the SEM file. So this file is used to store user account credential for local accounts. If we have an Active Directory environment, this is different. If we are just focusing on a single Windows machine, then the file of interest is the SEM file. So this file includes usernames, password hashes, account information, security identifiers, group memberships, and things of the sort. Now, it is located in the directory C Windows system32/config. For example, here I have my shell here. I can just go into this directory. I can do dir. And notice here I have a bunch of files, and I also have the SEM file right here. So that's the idea. Now, by default, it cannot be directly accessed since it is locked up by the operating system. Now, specifically, there is a process in Windows which is called LSASS, that reads this file, so it locks this file, and this process is used to dealing with authentication. So that's the idea. So typically it cannot be read. However, there are certain situations in which it is possible to obtain a copy of this file. Now here I will mention two different strategies to extract the hashes from this file. One targets the file itself, so we create a copy of the file itself with the SeBackup privilege. Another uses Mimikatz to dump the information on the process. And actually we're gonna see the second first because it requires an authenticated credential. It requires an administrator user of the machine. So let's say that we have compromised a machine and we are administrator on that machine, then we can use Mimikatz. Now, what is Mimikatz? Mimikatz is a tool used for penetration testing and red teaming in the context of Windows operating system. This is the GitHub page. So here I put a link to the GitHub page, could be useful. So this is the GitHub page. Here you can see in the releases, you go into the releases, you can get the executable, which essentially it's these files, and you can get, for example, the x64 mimikatz.exe or win32 mimikatz.exe. So how do we use it? It's actually very simple. We can use it with these following commands: privilege debug, token elevate, LSA dump sum. Now I will not explain in depth these commands because we will actually use and explain Mimikatz more in the Active Directory series. However, how do we use it? What's the idea of Mimikatz? The idea of Mimikatz is that it's gonna dump the hashes saved within the local security authority subsystem service, which is the LSASS. So we take this command, we execute it here. So here I have saved a copy of Mimikatz essentially in, I believe, in downloads. So here I have the Mimikatz copy. So that's the idea. And how can we use it? I'm just gonna copy this command and I do this. Okay, here it doesn't get the command. I have to do dot dash. And notice here, what do I obtain? I obtain this output. Now, the most interesting part of this output is that for each user of the machine, look at this. I have for the quickemu user, I have the NTLM hash. And for the Leonardo user, I also have the NTLM hash. Now, we will talk about these hashes in the future video, when we talk more in general about Windows hashes. But essentially, we have extracted the sensitive information from the SEM file, this time by targeting the process itself. We're not talking directly to the file, we are targeting the process itself. So that's the idea. And of course, notice that in this machine, I have disabled the antivirus because of course Mimikatz is very noisy by default if you don't add anything to protect its execution, and so it gets easily picked up by antivirus, Microsoft Defender, and so on and so forth. So that's the first way in which we can extract the content of the SEM file by going through the LSASS process. Another way instead is by directly copying the SEM file itself. Now, as I said, this cannot always be done, right? However, there is a special privilege called the SeBackup privilege that allows user to bypass the typical restriction that happens in file systems in Windows. So if a user even if it is not an administrator. However, if any user has this privilege, it becomes possible to create copies of the SAM and system files. Now, specifically, this privilege allows user or services to backup files. And since some files are locked for various reasons, the privilege by design allows user or services to bypass normal file security restrictions. Typically, it is granted to backup operators, system administrator, and trusted backup software. Now, this is important to know. Since by design it allows to bypass security restrictions, it introduces a significant security risk to consider. And so the privilege should only be granted to those who strictly need it in order to implement a least privilege approach to protect our system and software. Now, to assign such privilege, you can assign the user you want to the backup operators. So for example, in this case, I can assign the Leonardo user to the backup operators. Now, once we have that privilege, it is possible to copy the SAM and system file with the following two commands. Reg save, I put the name of the key to save, and I put an output path. So for example, in this command, I'm gonna save the SAM file into this specific file, and the system file into these other specific files. Once I have both of these files, there are techniques to extract the NTLM hash contained within them. So let's try it in practice. So right now I'm logged in as quickemu, but I want to change the user. I want to go to Leonardo essentially. So now I am logged in as Leonardo, and if you notice the privilege that I have, if I say who am I priv, I have the SeBackup privilege and also the SeRestore privilege. Even though I'm not really an administrator user, but I have those privileges because I belong to the backup operators group. So I'm not administrator, but I belong to the backup operators, which is a critical group in terms of security. Now, how do I get a copy of the SAM and system file? Well, I'm just going to do these two commands. So first, let me copy it again. First, notice that this file has been created, sam.hive. And then the second, I have essentially here I just copy it, and I have the system.hive. Now I have both of these files. I can transfer to a Linux box, to a Windows attacker control box, whatever. And from this file, I can extract the NTLM hash. So that's the idea. So these are the two techniques to extract these kind of files from the SAM and system files. Now, the other important topic that we talk about is the registry hives. Now, when it comes to Windows, we have an important data structure, which is the Windows registry. Now, the Windows registry is a hierarchical database structure following a tree-like data structure into registry hives. So, tree-like data structures in computer science have the following form. So we have a root node, which is a starting point, and then these root nodes opens up in different nodes underneath, and so on and so forth. Then each node can open up in different nodes. So this is sort of like an upside tree, because tree typically like they have this trunk, and then they have all the leaves here. Instead we have like the root at the top and then the leaves in the bottom. So that's the idea. Now, in this case, for each tree, we have a specific registry hive. So each hive is made up of multiple keys and values, and these hives are stored as normal files in the operating system. So once again, these files can also contain sensitive data because of their nature. They contain critical configuration, they can contain sensitive data, and so on and so forth. Now, these data sources are also very useful in another context, and specifically for threat intelligence, since the data stored within these hives can be used as indicator of compromise for specific malware. So the idea is that when a malicious software executes on a system, it leaves some traces, and these traces are called IOCs, and you can collect IOCs, you can even sell them to integrate them in various solutions for protecting endpoints. And so the idea is that when I see those kind of indicators in my system, maybe malware is running on my specific system. So the registry is a really important data source that must be considered in general. It typically does not happen, especially for OSCP, like for the exam and things of the sort. Typically, it is not used. However, it is very important to understand how it is structured, and how we can view the contents of this data. So here we have a bunch of different registry hives. So we have the classes root, the local machine, the users, the current user, the current config, and these are the respective files on the machine. So this file contains this registry hive, which is abbreviated as HKCR, HKLM, HKU, HKCU, HKCC. So that's the idea. Now, to explore the content of a hive, there is a package, a Python package called regipy. So that's the idea. Consider, for example, so let's go back to essentially, so here I have a Python environment. I can just activate it with .vm bin activate. So here I'm just activating a Python package, but essentially the idea, I can even deactivate it. So what's the idea is, we're gonna create a virtual Python environment in which to install the regipy module. So I'm gonna activate the environment, I'm gonna install the regipy module with pip, and then, for example, I can use something like this. So I can use something like this, like dump.py, this code, which simply lists out all the keys within the registry. And then I can, for example, explore the system registry. So in this case, it's system. Now, of course, I need to get the system registry. So here, maybe I can start an NCAT listener. And I can use, essentially, let's see if here I've saved something. I don't have it here. But if I go to the other user, to quickemu, I should have, so here I'm going to quickly authenticate with a very simple password. And here in downloads, I should have netcat. So I'm going to copy, essentially, so I'm going to do Leonardo desktop. Let's go into system hive. I'm going to copy it here. So now I have it here. I'm going to netcat. I'm going to netcat into the my host, and I'm going to give it the system thing, but I need to do it within a different shell. So I'm going to use this shell. I'm going to use C users quickemu desktop, actually not desktop, but downloads. And then I'm going to do ncat, then 122.1.431 system. And so with this, we are extracting the system from the Windows virtual machine to our Linux host. Look at this, we have a connection and we have 12 megabytes of data. So this file is actually really big. Now at this point, if we execute our dump Python, we get all the data out. Now, of course, this is like an insane amount of data. It's really not that easy to extract useful stuff. I mean, this is the whole concept of threat intelligence. It is not easy to do, threat intelligence. But essentially, that's the idea. We can potentially extract stuff from this file, and so this is another source of sensitive data. And so far we saw the history, the PowerShell history, the SEM file, and also the LSAS process, which we will discuss more in depth in the Active Directory series, and then the registry hives. Now, to finish off the video, 3 quick things. Now, with respect to configuration files, certain locations are most often used by application to store configuration file, and these are, for example, the app data and local app data, which for example, in this case, if I do app data, this is the app data roaming. So in this case, it's this directory. So C user quickemu app data roaming. Now you want to check out this directory because it might contain sensitive data regarding the specific application that are installed on your target system. So this cannot be generalized. So it's like I can either bring some example or talk in general. If I want to talk in general, there are no specific paths of exploiting this, like for example, the registry, the SEM, and the history. However, this highly depends on your application. Just make sure to check out this area and also check out if you have folders with names that remind you of application, vulnerable application, and things of the sort. So this is for configuration file, and then we have paging and hibernation. Now these are 2 different files that sometimes are used by Windows to handle memory. For example, the paging file is used to handle the paging mechanism. Now what is paging? The basic idea is that the computer has a finite amount of RAM, for example 8 GB or 16 GB. An application uses a certain amount of this RAM during the various workloads. Now what happens when the RAM is saturated? What happens when the RAM is completely filled up? If the operating system did not do anything extra, the system will simply freeze up because it could not handle all the different workloads. So what's the idea here? The idea here is to use a different mechanism for storing data, specifically the disk, for storing a portion of this RAM. So a portion of this RAM goes into the disk. And the file that contains this portion in the disk, this portion of the RAM, is the page file.sys. So if paging is enabled, the system will create a page file.sys file, and so you want to make sure that if you see something like that, and if you're able to read such content, it could contain sensitive data, because after all, it contains the data of the RAM. And the same thing happens when you turn on the hibernation feature, which allows for a faster startup time. So the idea is that a part of the RAM system is saved into the file, into the disk. So once again, when you have things saved into the disk, they could contain sensitive data. So just watch out for that. And so this is it for this video. In the next video, we will analyze more how hashes are used in Windows. So we will go back to talking about the SEM and to the hashes and to how the hashes are formed, the NTLM hashes and other hashes formats. So as always, I hope the video is interesting. I hope you get something out of it. If you do, leave some feedback, subscribe to the channel, share this video with like-minded people, and to the next video. Hi, and welcome to this video in which I continue my Windows privilege escalation. In this video, we will talk about hashes and specifically how hashes are used in Windows. So we will introduce some basic theory and application of hash functions, and specifically when they are used for authentication purposes. We will discuss the various hashes formats that exist in Windows, how to obtain them, and how to crack them. So as always, I hope the video is going to be useful and interesting. If you have some feedback, leave it in the comments, subscribe to the channel, share this video with like-minded people, and everyone who wants to learn about Windows privilege escalation. And that's it, enjoy the video. So let's get straight into the discussion. Hash functions, why are they used? Theory and applications. Now, of course, this is going to be a very brief overview of hash functions because they are an extremely important and technical topic of cryptography, and I should do an entire course on cryptography, but right now the focus is on Windows. So let's just go and zoom in, understand essentially what is the reason why Windows uses hashes, and let's see in practice how they're used. So from a mathematical perspective, hash functions can be described as one-way functions. And this one way essentially is going from the password to the hash of the password. And here I show a practical example using the hash function SHA-256. So here I'm doing an echo of Leonardo, and the -n is just to remove the new line at the end, so that we're not gonna hash that. And we pipe everything into SHA-256 sum, and here we have our hash value. So notice this, the string Leonardo is transformed into this long string. And a really cool thing about hash function is that if I take this command and I change the input of the hash function slightly, so let's say for example I put another row and I compute the hash function again, I'm gonna get a completely different hash function. And this fact, the fact that by slightly changing the input, the output completely changes, and also other properties that can be described mathematically, essentially make hash functions a very sort of like useful tool in the context of authentication. Now, as I said, I'm not going to describe in detail the mathematical properties of hash functions. I can do a specific video in the future about that. So, how are they used in the context of authentication and specifically in the context of Windows? Now, in the context of authentication, hash functions are used for protecting user credentials since they are easy to compute, but they are hard to reverse. And here the idea is that these functions are called one-way, because to go from the password to the hash, computationally speaking, which is going to be done by the server of the authentication procedure, it's easy to do. If I give you the password, everyone can compute the hash in a very small amount of time. However, going backwards, so from the hash to the password, is very hard and it requires a lot of computational power. So in practice, this mechanism essentially is used to protect user credentials. Web applications, for example, they do not store the password in clear text. Rather, they store the hash of the user password within a database. This means that the application can still verify the credential during login, because during login, the user is going to give the original password, and once the server has the original password, it can quickly compute the hash of the password. So this can still be done, and then you can check the hash of the password with the hash of the password saved in the database. So this is going to come from the DB, this comes from the user, and depending on the check of this equal, you can either have a good login or a not good login, essentially, like a failed authentication. However, if an attacker gets a hold of the database, if there is a ransomware or if there is like a malware, whatever, that leaks data, they are still not easy to retrieve the passwords because the passwords are protected by the hash. So this allows the application to verify the authenticity of the client during login and to protect the user credential. Now, of course, also the authentication procedure is used in many different contexts, not only the web context. Like web application are an example of authentication procedure, but the Windows operating system itself requires authentication. When I log in into a system, I have to give a password to the system. And so essentially that's an authentication procedure. Anytime we have to exchange some piece of data, such as user credential, in order to obtain a session, a user session, then we have an authentication. And since we have an authentication, it means that we have to store user credential in some way, in some data store, like a database. And so in general, we can abstract away any authentication procedure as first, the user gives a password to a process, the process that handles authentication. The process computes the hash of the password, and of course, this is dependent on the specific implementation. There are many different hash functions, and each implementation can choose a different hash function. There are secure hash functions and unsecure hash functions. For example, if you use MD5, MD5 is deprecated in the context of protecting user password, so you should not use that, and it's a bad thing to do. Once the process has computed the hash of the password, it's going to check if such hash is present within a trusted data store, like an internal database. If it is, authentication succeeds, otherwise authentication fails. So that's a general idea, and it goes much more in general than Windows specifically. But this of course also happens in Windows. So at this point we can ask ourselves, okay, what are the different hashes that are used in Windows? Now, Windows uses different hashes, most of them for authentication purposes, some other also for protecting data, for protecting keys and stuff like that. So let's go in the order. But in this video, we're gonna focus on these four: DLM, NTLM, Net-NTLM, V1 and V2. Kerberos and DP API for later videos, not of this series. Kerberos for sure in the Active Directory. DP API, Data Protection API, maybe in the future, like it's not specific to this series. So let's start with the first, LM, which stands for LAN Manager Hash. Now this is the oldest password storage hash used by Windows, and it is actually deprecated and it is turned off by default since Windows Vista and Server 2008. And here in this article, which I'm gonna link in the description because it's very well made, so essentially this article, LM, NTLM, Net-NTLMv OMI, so very well detailed, very well written. It describes essentially all the different algorithms, so it's a very good source. So the algorithm for computing it essentially is this one. We don't really care about the specifics, just for completion I wanted to bring. Essentially, it's gonna do some processing on the password. It's gonna create two DES keys, where DES is a specific block cipher. It's gonna encrypt a specific strings, and then it's gonna concatenate the two encrypted strings. So this is like very Microsoft specific algorithm. I don't even understand why they do this. Whatever, it's old, it's deprecated. And to check the LM hash configuration of your machine, you can use this code which queries the Windows registry. Specifically here the path is HKLM system current control set control LSA, and you want to query the item no LM hash. If it returns 1, it means that LM hashes are not generated, and this should be the default behavior. So nowadays these hashes are not really found. So for example, here I am in my Windows machine. I'm gonna run as administrator. This is so like I'm full administrator of the system. I'm gonna wait a bit for it to start up, and then I'm gonna execute this get item property, and I get 1. It means that no LM hashes are used, and this is what I expect also. So that's the idea. Then we find the NTLM hash. Now this is the way that passwords are actually stored on modern Windows system, and especially this is what we obtain when we dump the SEM database. And I showed how to do this in the previous video where I discussed sensitive files in the Windows context. So this is the algorithm for computing the NTLM hash. So we have the hash function MD4 and we have the encoding UTF-16LE, where LE stands for little endian, because this is one important thing to understand. When we're talking about hash functions, we're talking about functions that are defined on bytes. So the input of an hash function is not a string, it is a byte. And this is a really important difference. This means, for example, that if I say the string hello, if I do like something with a string hello, whatever, like this thing is not well defined. To actually define what I'm giving as input to the hash function, I need to understand how I am encoding the string. So the specific encoding scheme, and in this case we have a UTF-16 and also little endian. So it specifies essentially the way that the single bytes of the string are written to the hash function. So that's just a little specific about hash functions. For example, this is the NTLM hash of the password. So this is the string. When we encode it like this, we obtain the following NTLM hash, and of course do not use this. So at this point, we introduce two kinds of hashes, the LM and NTLM. These are the hashes that are stored in the SEM file. So how can we obtain those hashes from a penetration testing point of view, from a red teaming point of view? So in this section, obtaining hashes, I describe two different ways. So the first way has to do with LM and NTLM. So essentially there are two ways to do this. Either we can dump the SEM file if we have the SeBackup privilege, or we can just use Mimikatz if we also have the right privileges. Typically Mimikatz requires more privileges, so we can use it, for example, in an Active Directory context. Active Directory setup are made of multiple machines, right? So sometimes we can get local administrator into a machine, but we are still not domain admin. We are still not administrator in the context of the admin. So the idea is that sometimes we use Mimikatz on the local machines to obtain the hashes of the user who have authenticated to that machine, and this allows us to pivot to other machines. So in this context, privilege escalation is also to be taken with the pivoting point of view. Like I'm moving from one user to another, maybe it's an horizontal escalation, it's not a vertical one. So that's also a privilege escalation. So that's the idea. And if you want to use Mimikatz, assuming we have the right privileges, which is the hard part, using Mimikatz by itself is actually easy. We just do this command and it's gonna dump the LSA. So the LSA is the process that deals with the SEM, essentially. We do this, and wait, not with CMD, sorry, not with CMD, but with command prompt. So let's run with command prompt. Let's go into C users quickemu downloads, and then we run the command. So Mimikatz, and notice what we get here. We get the current hashes. So we get the NTLM for quickemu, and we have the NTLM for the user Leonardo, which is down. So NTLM for the user Leonardo. So that's the idea. And of course, here I'm showing these NTLM hashes because they're not really sensitive data. They are just joke passwords. Do not show the NTLM hashes of your user passwords because it is sensitive data. And we will see later why, because they can be cracked essentially. So maybe let's take these NTLM hashes actually and let's put them into a file. So let's create hashes.txt, not hashes.txt. We're gonna put quickemu colon this, and then we're gonna do Leonardo column that. Leonardo column that other. And notice also that the value produced by an hash function has the same size. Fixed, the hash function, they always have the same size, regardless of the input. The input could have like 100,000 millions of bytes. The output is always the same. So very fascinating mathematical object. So these are the first two. LM and NTLM. Now we get into the second block, which is the Net-NTLM. So what's the idea here? The idea is that there is this protocol that is used by Windows to authenticate the client. So when a client wants to authenticate, to say, look, I am a legitimate client, I am logged in as this user, and this is the NTLM protocol. Within the protocol, the NT-hash is used in a challenge response way between server and client. So what's the idea here? The idea is that in this protocol we have client and server, and here the client has to be authenticated. So the clients want to authenticate itself. So the way it works is that the server sends to the client a challenge, and this challenge is just a bunch of bytes. Like for example, in this case, is an 8-byte challenge, which are just random bytes. So the idea is that the client will use their own NTLM hash, LM or NT hash essentially, their own hash, to compute a response to this challenge. And the server will be able to check if the response has been computed correctly, to check if this client had that particular hash. And so this is the way that the response is computed. Essentially, you split the hash into various blocks, and then you compute this thing on the challenge. And here the difference between version 1 and version 2 is that in version 2 the protocol is different, so the algorithm that is used is different. However, the idea remains the same. We have, for example, server challenge and client challenge, but essentially we still have challenges, and these challenges, to resolve them, they use the hash, essentially, so that's the idea. And for example, to check whether you are running the first version or the second version, you can use, once again, this command. So we're gonna query the registry, current control set, control LSA, LM compatibility level. So if this thing does not exist, like in this case, it means that the default is used, which is the second version. And this default depends on the version of your Windows operating system. Now, I'm not going to go into the detail on how this Net and NTLMv2 works, because that would be going too in depth. For what we care about is, okay, what's the big idea here? What is the thing we actually need to perform a red teaming or penetration test on Windows? For example, in the context of OSCP certification. Now, the big idea here is that in both of these cases, assuming we have an authenticated session on a Windows system, so like we obtain a reverse shell on a Windows, but we do not know the credential of that user, meaning there is a current session, we just cannot authenticate as that user, but we do have execution within that session. So the idea is that we can extract such hashes, so the Net-NTLMv1 or the Net-NTLMv2, depending on the version we are using, the version that is configured on the system. And how can we extract such hashes? Well, we can use tools such as Responder. So the idea is that we are forcing a connection from the Windows victim to a controlled Linux host. So in the context of a challenge response protocol, now the client is going to be the victim, and we have some sort of code execution on the victim, or we can perform a phishing attack on the victim. So we can force the victim to establish a connection to a server, and this server is controlled by us. So we have control over this server. So we're going to fake to be, for example, an SMB server. We're going to connect to that server. During that connection, we're going to pretend to be real servers, right? So we're going to say, hey, can you authenticate me with this challenge response? So the client is going to compute the response to our challenge, and in that response, there will be a piece of information on the hash, on the NTLM hash, which is going to be formed in different formats depending on the context, and then we can crack that later on. So that's the idea. Now, how do we do it in practice? So for example, let's say that I managed to get this execution right here. So I have this shell at this point. I do not know the credential of this user, but I can execute code in this context. So what do I do? So in our attacker machine, so in the server that we control, we're going to install in packet. So let's do it right now. So we're going to do pip3, we're going to create a Python environment, and we're going to activate it, and we're going to install in packet. and a bunch of other packages. So we're gonna do pip3 install in packet and net ifaces. I'm gonna install both of them. Then I'm gonna clone this project, which is the responder, the tool that we will use. And the objective of this tool essentially is essentially we have it here. And so this is what we're gonna do. We're gonna call it with sudo because it requires root privileges, and we're gonna specify the network interface on which this server should listen to. So this is gonna activate a server that the Windows client can interact to. And we can see the code with this responder.py. So of course here is parsing all the options and things of the sort. And then it's activating all the different servers depending on the configuration. So let's do it. So we're gonna do sudo python3 responder.py. Then we specify the -i, and for example in my case this is verb 0. So it activated a bunch of servers. It says I cannot activate server at port 53 because it is already used by my DNS server. I don't care about that, however. So we do this on our control Linux attacker box essentially. And then we go back to our client here. So we go back to our client on the right. And then what do we do? How do we trigger the connection? So I'm gonna go back to my notes here. And then from the client, look at this, from the victim, I'm gonna do this dir, just a simple command, but I'm gonna execute this command over a connection, which it should be an SMB connection. So I'm forcing the machine to connect to this server. This server will request the authentication using the Windows protocol, and during this authentication attempt, I'm gonna extract the net and NTLM hash of the client. So let's do this. Notice here, I'm gonna execute this on the right, and look at this. On the left, I received the hash of the client. Specifically in this context, we are talking about the Net-NTLMv2 hash. So this is my username and this is the hash. So this is a very powerful technique, for example, in this case. So to recap what we covered so far, essentially, we have two main hashes. These are used for authentication of users when you log in. So the LM hash and the NTLM hash. These hashes are stored on the same file, So this is the first most important thing when it comes to hashes in Windows. A second most important thing, however, is when your user tries to authenticate in the network after a session has been established and after an NTLM hash has been given to the process, to the session essentially, it can use that NTLM hash as an authentication mechanism using different protocols. In both of these protocols, however, it is possible to obtain the hash that was processed in various ways, and you can do that, for example, with a tool such as Responder. And we show two ways. We show with Mimikatz, with the SeBackup privilege that I showed in the previous video, and in this video we introduce a new technique called Responder. This is gonna be used also in the Active Directory series, so this is a little bit of spoiler for future videos. So to talk about Kerberos, I'm not gonna talk about Kerberos because that is an authentication mechanism used in Active Directory. So Kerberos is a complex authentication mechanism. It is used in Active Directory because in Active Directory you have way more going on than a single machine. Especially you have a sort of like architecture, you have a system where you have a certain centralized server that deals with authentication. You can call them identity provider. In a way, they are called like that nowadays. IDP is like the Kerberos central server. And then you have other machines like desktop or services and stuff like that. And they all communicate to the central Kerberos service to obtain a different form of tickets. And tickets are means to deal with authentication using Kerberos, but I will not go into the detail on that because it will be treated in the Active Directory series, which is a whole other topic as well. It's sort of like basic Windows, but on steroids because you have much more going on. And then we have the DP API, Data Protection API, which are hashed used for data encryption we will not cover about them in this video because in this video I mainly wanted to focus on authentication. So with the LM, NTLM for basic user authentication and Net-NTLM v1, v2 for the authentication during network access and things of the sort. So at this point we showed what are the hashes, how we can obtain them, but what's the danger in obtaining such a hash? I mean, how can a malicious actor weaponize this? Okay, let's say that I've obtained this hash. What can I do now with this hash? Well, it becomes a problem obtaining these hashes because even though the theory tells us that it is easy to go from the password to the hash, but it is hard to go from the hash to the password, so in theory it should be hard to go from the hash to the password. In practice, this highly depends on the security of your password. If your password is not that secure, there is actually a way to go back, because you can just crack the hash. And cracking is not really a sophisticated process in terms of ideas. It's a really basic process, but if you have enough computational power, if you parallelize your work enough, you can get a lot done, and you can crack a lot of passwords. So the idea essentially is that cracking is a very simple process in which you have a word list, that is a list of words of most commonly used passwords, and you try to compute the hash of each one of them. You check if the hash you computed is equal to the one you obtained, and if you have a match, you just discover the password of the user. So the idea is that, let's say I have a hash here saved, so like h of p, you go with 1, 2, 3, 4, 5, 6. You do the hash of this, and then you ask, is it equal to this one? No. I go to the next, and I do the same. I compute the hash, I check if it's equal. If it's not, I go the same. I go this, I compute the hash, I check that it's equal. Perfect. This is the password that I can use to authenticate as that specific user. So this process is boring. It's not a genius process, but it's very effective sometimes, depending on the security of this. And people, of course, especially security researchers, have made life easier to do this sort of activities because they have organized word list of most commonly used words. For example, most commonly used passwords. And the ROQ is a just famous word list that contains different passwords. So let's curl it out. So let's curl ROQ, but not in this directory. In the previous one, I can deactivate responder like this. So let's curl this out. Let's wait a bit to download the word list and to untar it essentially. So it's a bit heavy, not too much, but considering it's a single file, it's 134 megabytes. And so here I have the 4 different commands we are interested in. Crack LM hash, crack NTLM hash, crack Net-NTLM v1, and crack Net-NTLM v2. Both of these can be cracked either with John or with hashcat, depending on your favorite, and the syntax essentially is the same. You put the format, LM, NT, Net-NTLM, Net-NTLMv2, you put the file that contains the hashes to crack, and with hashcat, instead of the format, you have to put the code, and this code depends on the type of things that you want to crack essentially. And of course, you also have to specify the word list if you are using a word list and you are not completely brute forcing. Brute forcing means that you try all the possible characters. This can get quickly impossible to do essentially. For example, one thing is you have password of 4 characters, but another thing is you have password of 16 characters. Like brute forcing a 16 character is essentially very, very hard, extremely impossible. For most people anyways, especially if you do not have the resources of a government, let's say. Now, when it comes to John, so let's try, for example, to crack the NTLM. So here we are with the syntax. So we go into our folder here and we say, okay, this is the situation. These are our NTLM hashes. This is the command. We run this. And of course, it's not this because it's hashes. We run this and look at this. We found the password for quickemu. My secret password was capital P, password 123, exclamation mark. So very simple password. We did not crack the one for Leonardo, but it's also easy. And so that's the idea essentially. So this when it comes to NTLM, and if we really want to try to crack the same thing, but essentially the one we took with responder. So let's take this. Let's save it into the hash.txt, so single file. and let's call the same format, but this time with the syntax net, so this one, so Net-NTLMv2, and with hash.txt. So this is another thing, and notice we obtain, of course, the same password because the NTLM hash underneath is the same. It's just the way that we use it is different because directly NTLM is sort of easier. If we have it in the Net-NTLMv protocol, it's a bit harder to crack. It just takes more time. In this case, it was easy for both of those. And so this also goes to show that, for example, if you cannot access the SAM file, if you cannot execute Mimikatz, however, you have a currently running session, then you can use a responder, you can like authenticate with the client to the malicious server, and you can still obtain the hash. So this is another way of obtaining the hash. And essentially, this is it for this video. I talk about hashes, Windows hashes, how to obtain them and how to crack them. Here are some references. So essentially, these are the articles that I use for preparing this research. And that's it for this video. I hope it was enjoyable. We will see more techniques with responder essentially when we talk about Active Directory, also with Mimikatz. But for now, for the Windows privilege escalation, this is it for this topic. See you to the next video. Hi everyone and welcome into this new video. In this video we continue my Windows privilege escalation series, and the objective, the main topic of this video will be discussing the role of credential manager, of store credentials and the Windows Vault. As always, I hope this video is useful. If you have some feedback, leave it in the comment, share this video with like-minded people, subscribe to the channel and enjoy the video. So let's get started and discuss about the credential manager feature. Now, the Credential Manager is a Windows feature that allows the centralized storage of user credentials. And here, when we're talking about user credential, we are referring to usernames, passwords, certificates, anything that can be used to authenticate to a service. So this is our client, we have different services, and these different services requires authentication. Perfect. For all of this, we have the Credential Manager. And the objective of the Credential Manager is to store credentials in a secure way so that later on, when we need them, we can just simply retrieve them in a fast way. So it provides a simple way to store and retrieve credentials for system and applications without requiring users to repeatedly enter their authentication details. And in terms of storage and protection, when we are storing data, we also have to protect it with cryptography, and credentials are securely stored using the Windows Data Protection API, also known as DP API. And essentially, this is it for this feature. It's pretty simple, and it's also easy to understand why this feature is useful. Instead of typing your password every time, you can just store it on the Credential Manager and retrieve it automatically. So very useful, and this also brings us to the point, why is it dangerous? Well, even though the data it's stored is encrypted using the DP API, so the Data Protection API, if a malicious actor gets hold of a session with stored credentials, so a session where certain credentials were stored using the Credential Manager, while it is not possible to extract the plaintext passwords without extra privileges, it is still possible to actively use those credentials for malicious purposes. So the idea is that if your session is compromised, all the credentials saved in the Credential Manager can be used. So there's an important distinction here between reading the password and using the password. So when we store something in the Credential Manager, we are not allowing an attacker to read it. To read it, the attacker will need to compromise the private key of the DP API component. Technically, it can still be done, it just requires more privileges. Assuming the attacker has a low privilege access to our session, what he can do instead is use the credentials stored in the Credential Manager. He cannot read the plaintext password, but he can use it. So be careful on the credentials that you store on your session and protect access to your session, because if your session is compromised, all the credentials can be used. Now, practically speaking, if you get access in the context of a penetration test or a red teaming activity, if you get access to a user session one thing that you should enumerate is the credential manager. So how do we use it from the command line? So there is also a way to use it from the UI. So we will need to go into control panel, user accounts, credential manager, and then we pick which credential we are interested in. So essentially in this case, this is like a Windows system. So I go control panel, then I go user accounts, user account credential manager, and then for example, I have Windows credentials. So I have this, and here I can see that, like for example, here I have no passwords, but here I have something. So here I have password, I can edit it, I can, I cannot copy it, I cannot read it, but I can change it essentially. So that's the idea with the UI. But of course, we're not interested in the UI. Why? Because we're interested in the command line. This is the way, for example, we get access to a system through a reverse shell. So we need commands. So what are useful commands? Well, there is the CMD key, this utility, which allows us to interact with the credential manager. And the idea is that when you get access to a user session, when you get a reverse shell, when you get anything of the sort, always enumerate this with a simple command, CMD key /list. So it's a very, very simple command. We do this, and notice what happens. It says, okay, look at this. I have a bunch of generic credential here, and then I have this password for the user quickemu. Okay, this is interesting. Right now I'm logged in as the user Leonardo. And then I notice that, okay, but this Leonardo actually is able as login credential for the user quickemu. And so if we see something like that, that's already suspicious. It means essentially that we can use these credentials. So the next question is, okay, perfect. How do we use it? How do we use these credentials? In this case, we can use the command run as, we can say /saved_cred, we can specify the user, in this case we specify quickemu, and then we put the command. If we executed this, if we execute this, like for example here, so let's do it like this, we do run as quickemu cmd. Notice that now we have a shell as the user quickemu. So this is a different user with a different privilege potentially. I mean, in this case, I don't have much privileges. This is because I don't have, like if I do UMI groups, my integrity level is medium. So I have medium integrity level. However, if I notice that quickemu belongs to the administrator groups, I've essentially already done a privilege escalation because the user Leonardo, net user Leonardo, does not belong to the administrator groups. So by using the logon session saved in the credential manager, by using the credentials saved within the credential manager, I was able to essentially change user. And this is essentially why you want to always enumerate this thing, because it's, first of all, it's really simple. It's just a single command. And then you're like, okay, this is what I can do currently. It says, okay, I have the credential for quickemu. It is a domain password. And then I can use it essentially. For example, let's say that I want to delete that. I can delete that with this /delete. Of course, deleting it would be very, very stupid, clearly, because I'm deleting something that allows me to maybe escalate my privileges. So I don't want to do that clearly, but let's say that someone, maybe I am the legit user of this machine. So I have used the credential. Now I want to remove them for security reasons. So I just do the delete /delete with the target. So in this case is what I obtain from the list command as the target value. So domain interactive, blah, blah, blah. So that stuff. So right now I don't have it anymore. And now if I execute the previous command, so the one that allowed me to spawn the CMD shell, in this case, like this essentially. So if I do this once again, since it does not find the credential for this user saved in the manager, it actually asks me for the password. So in this case, I actually need to put the password, and if I don't put it, it's gonna say, look, you don't have the correct password. However, if I put the correct password, so in this case, I'm gonna put the correct password just one time, and it spawns the shell, right? So I do UMI, whatever. Then I close everything. The next time, it's just gonna directly spawn the shell. Why? because now it is saved into the credential manager. So be careful on what you save in the credential manager. This from a defensive point of view. From an offensive point of view, always make sure to understand what is saved in this manager, in this database. And as a little extra, to connect this discussion with the UAC bypass video that I've made previously, let's say that, okay, we notice that we have these quickemu credentials, and so we spawn a CMD prompt with, actually, let's spawn a PowerShell. So here I spawn a PowerShell.exe with the quickemu user. So we do this. So actually, I did not save it, I did not copy it correctly. So let's do this. So now I have this PowerShell as quickemu, but I notice that if I say whoamipriv, I do not get access to all the privileges quickemu, even though quickemu actually is a member of administrator, and this is of course because right now I'm running with a medium integrity level. So if I do groups, here I have medium integrity level. And then to actually obtain all the privileges of my user, I can just, for example, do a start process. I do a start process. Of course, now there is an UAC prompt, so I will need to find a way to bypass this prompt. In this case, I have access to the graphical interface, so I can easily do it. If I just have the command line, this is not as easy. There are other ways. In the UAC bypass, I showed different ways, but at this point now I have all the privileges. So here it was a two-step process. First, through the saved credential to the credential manager, I get access to a shell for a different user, and then through a UAC bypass, I get access to a privilege shell of that user. So sometimes you have to combine different steps, and here I just wanted to say that, okay, even though you find credentials for other users, to actually gain access to higher integrity context, you might need also to do other sort of bypasses. So this is like a simple way. So that's how you delete it. How you add it, you can just use the keyword add, or you can do a command run as, and then you put the save credential. So in this case, it would save the credential for this user essentially. So the first time it saves the credential, the second time it uses the credential saved, or you can explicitly add it. So you can say add, this is the target, this is the user, and this is the password. So for example, if I do this, I do add, so not this because whatever, let me clear it. So I do CMD key add, and then I do CMD key list, and notice this, I have target, my server, domain password, my user. So that's the idea. So the important thing to understand is that you cannot read these values, you can just use them, you can just edit them to modify them, but you cannot read them once you insert it into them, because the way they are stored is they are stored through encryption. And remember that everything you put into the credential manager cannot be directly read, but it can be used. So essentially that's the idea. Now to finish off the video, let's talk a little bit about the Windows Vault. Why? Because the idea is that the credential manager actually uses as the underlying storage mechanism the Windows Vault. So you can think of the credential manager as a simpler way to use the Windows Vault, because it has a simpler interface. If you want to access the raw feature, that is the Windows Vault, which is a data store capable of managing encrypted data. So data protected through the Windows Data Protection API, so DP API. So that's the idea. Now, while Credential Manager is accessed using CMD key, the Windows Vault instead can be accessed using the Vault CMD command. For example, if we want to enumerate all the vaults in our machine, we do vault cmd/list. And notice, for example, we have the Web Credential Vault and the Windows Credential Vault. Here we have a GUID, like an identifier within the context of Windows, a different one for the Windows credential. And then we have the location in the disk where this file is stored. So for example, in this one. So we go here, we do dir, and notice this policy.vpol. If we try to read this file, we're not going to read anything because it is encrypted data. So we're not going to be able to read this. We need to find the encrypted keys, the encrypted material, the cryptographic material that was used to encrypt this vault, and we also need to understand the binary format to actually extract the data. So for example, if we want to list out all the credentials saved in the web credential vault, we can just do list creds, the name of the vault /all. So we do this, and it says no credential. Now remember that we had two vaults in this case. So we had the web credential and the Windows credential. So another thing that we can do is, okay, let's enumerate all the credentials saved in the Windows credential vault. And notice here we have this quickemu. So it says essentially identity, resource, hidden, roaming, property, schema ID value. So as I said, this is a more powerful way of storing encrypted data. The Vault CMD is a more general API, it's more powerful, but also more complex. And to finish off, for example, we can dump the vault with Mimikatz, for example, with the following command. So we do this Mimikatz vault. Actually, it's not like this because we have to deal with this. We have to remove the scan. So let's allow on device, whatever. Then we do into Magic settings. I'm gonna remove the real-time protection and I'm gonna execute it again. So in this case, once again, it finds the two vaults, which is a web credential and Windows credential. So of course, also with Mimikatz, you can dump, for example, the key for the DP API. I'm not gonna cover into that because it's too much advanced with respect to like a certification like the OSCP. Typically, you don't need to go that far. But in this video, I just wanted to mention that the existence of these features, the credential manager and the Windows Vault. So the credential manager is used to store credential and it actually uses the Windows Vault. So typically you will just like be enough by using the CMD key. So that's gonna be good enough. Just list out all the keys you have and then use them with the save cred option in this case. And the Windows Vault is a more powerful way of accessing this data store. And so this is it for this video. In this video, I introduced the role of the credential manager to store authentication credentials, and I discuss a little bit the Windows Vault, which is the underlying storage mechanism used by the credential manager. Of course, this is not it. It's not like I finish all the topics regarding this area. You can go a lot deeper into this. However, from a point of view of, for example, an OSCP certification, what you need to know is always be careful of enumerating the credentials saved in the credential manager with CMD key list. And if you find any, use them with run as/savecred. It's gonna be useful maybe to pivot into different accounts and to perform a privilege escalation. And here are some references for the credential manager store and the CMD key documentation. As always, I hope the video was enjoyable. I hope you got something out of it. If you did, leave it in the comments, subscribe to the channel, and to the next video. Hi everyone, and welcome to this new video in which I continue my Windows privilege escalation series. The topic of this video will be scheduled tasks. We will introduce by discussing what are scheduled tasks, then we will see some commands that allows us to enumerate the scheduled task, how we can create and delete a scheduled task, and a simple example of exploitation of a scheduled task. As always, I hope the video is enjoyable, I hope you get something out of it. If you do, subscribe to the channel, share this video and this channel with like-minded people to help me grow. And that's it, enjoy the video. So let's start with a simple question. What are scheduled tasks? And here the name helps us a lot. Why? Because scheduled tasks are Windows computer programs or scripts that are executed automatically based on a specific schedule or trigger condition. Think cron job in the context of Linux. So in Linux we have cron jobs. Now in Windows, we have services, which we discussed in previous video, and we also have scheduled tasks. While services are like daemons in the Linux context, scheduled tasks are like cron job in the Linux context. However, in Windows, they're a little bit more complex because they can be executed based on a specific time schedule or also based on specific trigger conditions. So they are managed by the task scheduler service and they can be used for various types of tasks such as backup operations, system maintenance, custom scripts that need to be executed, maybe to set up a development pipeline or environment. So anytime we have something that needs to be executed either on a fixed schedule base or on specific conditions, we can use schedule task for that purpose. And as always, when we have a system that is designed to execute arbitrary code, because by design the schedule task can be any sort of executable, so Windows executable, or any sort of script, so BET or PowerShell script. Anytime we have a system that executes arbitrary code, we must be really careful into how we use such system. So in this case, we must be careful in who has access to it, so who has access to the various schedule task, how are they configured, what they execute, and things of the sort, because this is like a very significant surface attack if it's poorly configured. And of course, this note really applies to every system that executes arbitrary code. It could be Windows services, it can be Windows schedule task. Anytime we have arbitrary code, this could be a problem. Now, I'm not going into full detail on the schedule task data because it's very complex, but essentially, schedule tasks contain different kinds of data, and these are way more complex than simple services. So here I've categorized data into these different sections: general information, triggers, actions, conditions, settings, security settings, and last run execution information. So in the general information section, we start out with some basic information about the task, such as the name, the path, the description, if the task is enabled or not, and the author of the task. Notice that the path with respect to the scheduled task does not refer to the file system directly, but it refers to this task schedule library. So it is a different library. You can think of it as a different file system on the system. And essentially, when you want to specify a task, you must combine the path with the name. So for task, the identifier path plus name has to be unique. This means that task with the same name can exist in different folders, so with a different value for path, and in the same folder, task with the same name cannot exist. Now, what does it mean? It means, for example, that we might have path, we will see some practical example, with a simple slash. So this defines a specific namespace where tasks can be defined. And then I can have within this path, I can have different name. I can have task 1, I can have task 2, and things of the sort. And then the full name of the path, the full path for the task is gonna be /task1 or /task2. Now the idea is that since I have this concept of path, this does not refer directly to the file system, it refers to another file system, to the task scheduler library. And this is a useful abstraction to have, because for example, we can define for a different path, let's say I can put /custom, I can define a task with the name task1. So I can repeat the same name for the task as long as I am in different folders. And so we have this /task1 and we have /custom /task1. And these are going to define different tasks. So depending on the path, you're going to have different tasks. Within the same folder though, we must have unique task names. So within the same folder, I cannot define the 2x task1. It has to be unique. And when I want to interact with the task scheduler to say, for example, start this task or stop this task or delete this task and whatever, to fully specify the task, I'm going to use path plus name. So I'm going to use the full description. Another thing of interest is the triggers. Now the triggers specify the condition under which the task will run. And there are different types of triggers. We can have time-based triggers, which are the most common, and these are like actually mapped to the cron job in Linux. And we will see an example of a time-based trigger later on. We can also have different type of triggers, so not only time-based, we can have event-based triggers, which are triggered by system events, like the user logs on, or the system starts up, or an event in the event log. So like any sort of event that can be captured, I can define a trigger on it so that when that event is captured by the task scheduler, it's gonna activate this specific task. So each trigger contains the following information: the start and end date, So start time and end time, which means when does the task start and when does the task end, and then the recurrence interval. And of course, this is mostly for time-based. For event-based, you can say, okay, trigger this task every 30 minutes, so that when 30 minutes have passed, it's gonna trigger again. If the same event happens 2 times in a single window of 30 minutes, it's just gonna execute it once. That's the idea. Then we have the actions. So this is gonna specify the action that has to be done when the trigger is satisfied. So when the trigger starts, when the task is triggered, what's gonna happen? So here we have typically an executable with some arguments and maybe a working directory, so that we're gonna execute, for example, a PowerShell script within a given working directory with some specific arguments. Then the conditions, so like network, power, idle time, we will not really care about that because that is too much detail for our purposes. And then, of course, we can specify more general settings, like allow a task to be run on demand, restart on failure, things of the sort. Once again, too much detail, we will not really care about that. And then there is some security settings, which of course are interesting to us, which for example defines, okay, run with this particular user, run with this principal, run under these privileges. So those are really important. And then for each task, we have information on the last runtime, the next runtime, and the last run result or the status for error details. So essentially when we run a task, it's gonna say, look, last time I ran on the 10 a.m., I'm gonna run next time on the 11 a.m. if the task was scheduled with a time-based schedule for every hour. Now, tasks can be a really complex surface attack because they're not really easy to enumerate. So let's see some commands to deal with tasks. This is a PowerShell command that allows us to list out all the scheduled tasks that our user has access to. So we can do with the get-scheduled task. So we open a shell, as always here. I do get scheduled task, and here I have the list of tasks. Notice that in this list we have 3 main information essentially, which is the task path, the task name, and the state. So notice this, in the /task path we have a bunch of tasks regarding to OneDrive. Then we have the task path.NET framework with all the tasks related to the .NET framework, and so on and so forth. This is the idea, this is the concept that we talked about previously. And while the get scheduled task works in PowerShell, we can have like an equivalent in CMD, which is SCH tasks. So essentially we can just open a command prompt, we can just do SCH query, and we get all the different information depending on the folders. So in this case, they are already organized by folders. In this case, we have a more like the folder is repeated in case. Now let's say that we want to list out all the tasks, but only those in a specific folder. So here we can use typical PowerShell syntax to filter out. So here we're getting all the tasks, but here we're filtering on the objects where the task path property is equal, for example, to Microsoft Windows shell. So we execute this, and we're gonna get only the tasks that live in that specific path. So let's copy it again. I'm gonna copy it here, execute it, and here I get these different tasks. Create object task, family safety monitor, family safety refresh task, update user picture task, all of these things that run on this specific path. Now, if I want to list out some more information with respect to a specific task, I can do this. I can do get scheduled task, task name. And so, for example, here we can execute this get scheduled task with the task name create object task. And here we get the information. It's like we wait a bit. So we execute this. And we get information regarding 2 different tasks. One that lives in the task path Microsoft Windows Shell, and the other that lives in the task path Microsoft Windows Cloud Experience Host. If we want to be more specific, of course, we have to introduce a new filter here, task path, essentially. And in this task path, we have to put the path like this. So like this, and then we go here, and then here we put this. And we're gonna get the details on this specific task and not the other. As you can see here, some information are last runtime, last task result, next runtime, number of missed runs, the name, the path, and the computer name, which is not set in this case, so more detailed information. Another way to obtain information is by just formatting all the properties. with this format list. So here we have a task name, and here we have all the properties, and notice that the actions, the triggers, and the instance properties are complex objects themselves, which can also be expanded essentially. So here we also have the principal, and this is gonna define the user, the principal is gonna be used to execute this task. So for defining the security context to run. So that's the idea. Now, for example, let's say that we want to extract the binary path of a given task. So here we can just zoom in to the actions component of the task. So we do get scheduled task, we put the name, and then we put .actions. So let's copy it. I'm gonna get this. And so here we get execute windir system32 and then the name of the task, which in this case is a simple executable with the arguments standby. So this is how we move from the task name to the actual binary that is executed. And if we want to do this for every task in the system, we can just do a simple loop for each object, and we can simply extract the actions object, the action property in a way. So we do this, and we extract all the executable. Once again, depending on the permissions of this executable, you could maybe be able to overwrite it with a malicious executable, and if the task is periodic, is scheduled to run every minute or something, there you go, you have code execution with your arbitrary code. So that could be a path, and to get to the actual executable, you can use these commands. Of course, you can customize it depending on your need. Finally, let's say that you want to export the configuration as an XML file because it is easier to read, maybe, also for automatic enumeration processes. So you can do export schedule task, you can put it here, you put the task name, and here you have essentially all the details of the task. And in this XML, you will find information on the actions to execute, on the context of execution, which in this case is local system, the command to be executed, the arguments, the triggers, which specify the condition, the principal, which is once again local system, and all other details. So it could be an interesting thing to extract. Now, to get more familiar with scheduled task, the idea is let's create and delete a simple scheduled task and see it in action. So let's create a simple task that runs when the user logins into the system. So we're going to have a trigger, and the trigger is going to be @logon. So to define this new task, we do it with essentially 3 different commands. In the first one, we are defining the action. And in this case, the action is just to execute the notepad.exe executable. So it is just a simple notepad instance. So we define this. We need, of course, a privilege shell to create a new schedule task. So we're gonna execute a privilege shell here. So first we create the action object, and this is done. The second thing is that we're gonna define the trigger condition. In this case, we're gonna say new schedule task trigger @logon. So this specifies, okay, when the system logs on, you're gonna execute this code. So a simple trigger, and we define a trigger. And finally, we can register the new task. Here we put the task name, here we put the action using the object that we created previously, same thing for the trigger, and finally the user that we're gonna use to execute this task, which is gonna be our quickemu user essentially. So in this case, it's quickemu, actually let's see if it's correct, who am I? It's quickemu h5ds, so quickemu h5ds, perfect. So we're gonna register this task as the name my task. Notice here we did not put the task path, so it's gonna start from the root. So we're gonna execute this, of course not this, but this other. And here we have registered our task, and the state is ready, so it is ready to be executed. Let's go and enumerate, for example, the details of this task. So in this case, the details is my task here, and I'm gonna get these details. So I'm gonna say, look, the last runtime was never essentially. And so to actually trigger it, what do we have to do? Well, we just have to log out and log in again. So we're gonna force a logout. I'm gonna do a sign out. We're gonna wait, then I'm going to log in. So here, essentially, I put the password. And now the task is gonna be executed because the trigger condition is gonna be met. So I'm logging into the system, and then I'm gonna execute the task itself. And notice now that I have a notepad ready to be used. So this could also be useful for automation and things of the sort. So this is how we register a simple task. And then of course, let's say that now we want to delete it. Also, let's try to see if it now change the last run. So this is last run at 18:11, which is like right now. And so that's the idea. So to delete it, what do? We simply do unregister schedule task with the name. So like this. And here we have it removed, not property simple task, because it is not simple task, but it is rather my task. So it is no longer there, essentially. In this case, the task path was here. So if we check information on this again, get schedule task info, it's not gonna find it because we have just unregistered, and so we have removed it from the data structure used by the task scheduler. And finally, let's see a simple example of exploitation. So for this exploitation, we're gonna define another simple task. This time, however, we're gonna execute the task every minute, starting from the moment we define the task until 1 year. So here the action is gonna be execute a PowerShell.exe with a specific argument, and the argument is gonna be a script on the file system. So the script is gonna be in C users quickemu task test1.ps1. So essentially, we are saying to the system, okay, every minute execute this script. So this is gonna be our action. So we do this action, new schedule task. Then we're gonna do the trigger. So the trigger is essentially once at get date, so we're gonna get the current date, and then the repetition interval is every minute. So new time span -1, repetition duration for 1 year, so 365 days. So we're gonna define the trigger. So this is gonna be a time-based schedule task, so the schedule is gonna depend on the time. Then we're gonna define the principal, which is gonna be the user profile for security that's gonna execute the task, and this one is the system user, and it's gonna run with the highest level of privileges, so it is a very dangerous task to define in the first place, of course. And then we're gonna register the task. We put the simple task as the task name with the action, the trigger, and the principal. So we register the task, and now we have registered the task. So this is it. Now, what does the task do? In this case, the task is pretty simple, because if we go into the path, into this task, so C user quickemu task, this thing is just gonna, if I edit this PowerShell, it's just gonna execute a whoami, and it's gonna write this output into this file, test_whoami.txt. So in this case, this whoami is gonna say NT authority system, because that's the user that is executing the task. For example, if I remove this, and I just wait for the next execution, which anyways, I can get this information by asking for the get schedule task info with the name simple task, and it's gonna say essentially, look, the next one is gonna be 1717, so we are gonna wait 1717, and it's gonna execute it again. At that point, a new file will be created. Now, let's talk a little bit why this can be dangerous. Well, of course, what's the problem here? The problem is on the configuration of this schedule task. So the issue we need to understand is, wait, who can access this file? Because if other users can edit this file and they can introduce malicious PowerShell, then they're gonna be able to execute malicious code with higher privileges every minute, which is not a good thing. So notice now the file has been created, and it says on NT authority system, and essentially, if I do get schedule task, it's gonna say, look, the last run was in 18/17/17, this one is 18/18/18. So that's the idea. And in these cases, a simple exploitation technique is just, okay, we understood that this file is executed by a scheduled task every, for example, minute with higher privileges. Okay, let's insert some malicious code. Pretty simple. And here, for example, I change this, I put the shell, and I wait for the next execution. So here, for example, it's gonna say 4040. I've noticed that typically it executes a little bit earlier than that, but that's the idea. So here we wait a bit, and then we get our execution. Of course, in real system, this is not this simple. Why? Because in this case, we were the one who created the task. In real system, what the hard part is the enumeration part of schedule task. If we had all the information, it would be easy to understand if the system was vulnerable, but the point is that we do not have all the information. And notice here we get the shell execution, and it is around like 10 seconds before the task itself. I think it takes some seconds to execute, so it does it earlier. But that's the idea. We have our shell, and of course this shell is run as like the user system authority system, so higher privileges. And so we can do whatever with our shell. So as I was saying though, the problem is that it is not easy to enumerate the scheduled task. This is why scheduled task is an interesting attack surface, but it is not always doable to deal with it and to exploit it because it is not easy to enumerate. Specifically, if we if we try to search for this task on a normal shell here, we get no information. Why? Because this task is only available in higher privileges shell, for example in this one. So in this one I get the information, I get when it runs, I can get the executable, like for example if I say format list, if I say action, sorry, if I say action like this, so I'm gonna copy this, so not like this, but if I say this and here I say let's do simple task, I copy this and I execute it here, I get of course that this is a PowerShell file, but only in this privilege context. In a normal shell, I do not have access to this information. And if I try to search for this task in a non-privileged environment, I get an error, doesn't find the task. So ultimately, the exploitation of scheduled task is not that easy to do because it is not easy to enumerate the scheduled task. This is why I suggest to keep in mind that they exist, but not focus on this path for simple certifications such as the OSCP certification. Try to maybe check if certain files are created, or maybe if you have other information like a history, PowerShell and things of the sort. So if you happen to see commands like the following, like new schedule task principal, register schedule task, and things of the sort, do try to understand if there is a scheduled task going on. Otherwise, focus on simpler things to enumerate first before going into the scheduled task enumeration. And these are some simple references taken from the Microsoft documentation. This is it for this video. We analyze the concept of scheduled task, we discuss what they are, how can we enumerate them, how can we create and delete them, and how we can exploit the main idea. And we also said that the hardest part of this is to enumerate, is to actually understand what is going on at the level of the system with respect to the scheduled task, because we do not have all the information with a low privilege shell. So I hope the video was enjoyable and you got something out of it. If you did, subscribe to the channel, share this video with like-minded people, and to the next video. Hi everyone and welcome into this new video in which I continue my Windows privilege escalation series. The topic of this video will be to analyze some of the most critical registry paths. So we will talk about the registry, which I've already introduced in the sensitive data video on Windows. But this time we will talk about specific registry keys, which are the following one, which I picked, and they represent some of the most critical registry paths. This means that if you are able to overwrite values into this registry path, then you might be able to introduce malicious code to obtain privilege escalation and in general to perform malicious activities on the system. Now, these are not all the sensitive registry paths. These are some of the most important and also simple to explain, but essentially the idea is that you're gonna have all the registry paths, which I will not cover in this video. This video is just to give you an introduction to some of the most critical registry paths. So let's get straight into the topic and talk about registry. Now, I've already discussed what is the Windows registry. Essentially, it is an hierarchical database that is structured with tree-like data structures, and each tree represents a specific registry hive. So we have different registry hives. Specifically, there are 5 main hives, and these are the HK classes root, the HK local machine, the HK users, HK current user, and HK current config. And they have the abbreviation HKCR, LM, UCU, CC. So the idea is that we have this sort of like big database, so you can sort of think, okay, here we have a bunch of different trees, which is a very common data structure that you will often find when you study computer science. And in each node of this data structure, there could be different values. So here we have attributes that have names and that have values. So in each path, you can have different names with different values. So that's the idea. Now, of course, for each hive, we have a respective file. So for example, you have the config software, config system, config default, and user data system profile. I've already discussed about this in the sensitive data in Windows video, where I show how to extract the data using a Python script. Now, there are many uses for this registry. For example, in the context of malware analysis, the data that is found in this registry is often used for doing threat intelligence. That is, for understanding the activities of malicious software and how the software modifies the system and the environment in which it is running. And this kind of modification can be picked up by analyzing how the registry is accessed. So the idea is that you gain threat intelligence by analyzing data access to the registry, and then you can figure out the indicator of compromise IUC, which you can then later sell or distribute or share and stuff like that. Now, given that the registry contains a lot of important configuration for the Windows system, there are certain paths that, if misconfigured, could be dangerous. And here, the threat model we have to consider, we have to understand is that, let's say that a malicious attacker is able to modify any of these 4 different registry paths. So they have full control over the attributes and the values found within this path. And the question is, what can an attacker do with this sort of privileges? So in the video, I'm gonna use an administrator account because I did not set the correct privileges, but essentially imagine that you can give to the attacker this kind of permission, and then you can see the result in terms of code execution, privilege escalation, and things of the sort. So assume you have control over this path. Now, the first registry path that I want to talk about is the HKLM system current control set services. So essentially, this belongs to the HKLM, so the local machine configuration, the local machine registry. And why is having access to this path critical in terms of security? Well, because services are a common target for privilege escalation, and this was already discussed in the previous videos of the series, and specifically these 3 videos were mainly targeted on services, Windows services, weak service permissions, and unquoted service path. We also did a video on DLL hijacking. I also did a video on that, so that is also linked to attacks on services, but these are mostly focused on services. Now, but what's the idea? How is, for example, the service configuration linked to this registry key? Well, the idea is that when we configure a new service, the system writes a new key into this registry path with a bunch of information with respect to the service. And among this information, we find the image path attribute. Now, this attribute is used to specify the executable file that is linked to that specific service. This is very similar to the video that I discussed on weak service permission, in which we have the configuration of the service in which there is another property called the bin path. So, essentially, the idea is that by modifying the bin path, actually what we were doing was modifying the underlying image path present in the registry at this specific path, and then here you have to add the name of the service, so like for example name here, and for different services you have different names. So the idea is that when we modify the bin path of a service, we are actually modifying the underlying image path. This means that, for example, if an attacker is able to directly modify the image path to directly access the Windows registry, for example, with the following PowerShell command, the one that I'm highlighting. So notice here, we do set item property, we specify the path, which is the HKLM system current control set services, and here we find the name of the service, which is simple service. Then we say, okay, I want to modify the attribute called image path with this value, with a different executable. Now, if an attacker does that, essentially the next time we activate the service, for example, by doing a restart service with the name of the service, we're going to execute the new binary and not the original one. So by having access to this registry path, an attacker will be able to hijack the execution of each service he has access to. So essentially that's the idea. For example, consider we have a binary called simpleservice.exe and we want to add a new service that executes this binary. So in the path, see users quickemu downloads simpleservice.exe. So here I have the notes for the previous video, from the Windows service video here on the right, this one essentially. So I can simply copy this. Of course, it did not really copy it, so I have to copy it again. So I'm gonna copy this and I'm gonna create the simple service. So now I've created the simple service. Now let's try to get the item property at this path. So this current control set services simple service. So let's get this path. So of course here I have to do it again. Okay, get item property. Now here we have a bunch of information on this specific service called simple service. Specifically, we have this attribute called the image path with this specific value. It means that when we're gonna start the service, we're gonna execute this binary. Perfect. Now, to actually understand what happens when a malicious actor is able to modify this image path attribute in the registry, let's take a very simple executable, which here I've called here hello.exe, and the source code for this executable is this one. So in this source code, I'm simply gonna create a file in the path see users quickemu downloads test.txt, and I'm gonna write a simple hello world string within the file that I open in write mode. Perfect. It's a very simple thing. I've cross-compiled it with the cross-compiler toolchain and I've put it into the Windows system. So if we execute this, notice what do we get. And I do dir. Notice that we get the test.txt file, and if we check its contents, we see the string hello world with the new line. Perfect. So now we're gonna replace the executable, the simple service, with the hello.exe. So how do we do that? Well, we just open the set item property, and essentially here we set the image path attribute of the path simple service, services, and so on and so forth. With the value, here we just have to put hello.exe. So we do this. So let's just do this. Also here, let's delete the test.txt because we want to delete it. At this point, if we get the property again, notice that now the image path has changed and it is no longer simple service.exe. And now we can start the service with a simple start service name simple service. It's gonna print out an error. But then if we check on the disk here, notice that the test.txt has been created with the content that we expected. So essentially, it means that we are able to execute arbitrary code by triggering the service. This happens because now in the image path attribute, we find this specific executable and no longer the original one. So if we wanted to restore to the original one, here we would have to write simple service.exe. So let's copy it again, simple service.exe. Then I put get item, look at this. And now if I start it, start service name simple service, it's not gonna bother me anymore. Now it's actually gonna properly start it because it is the proper binary, and so it is able to just run. And in this case, I will not have code execution. So if I remove the test.txt and I restart the service, here I'm just gonna put simple service as the name. I'm gonna restart it, and here it's no longer it's not gonna create the test.txt file because I do not have longer code execution. And so this was the first registry path that I wanted to cover. And also I want to mention the fact that this attack is similar to the one that we saw before in the weak service permission episode. However, this one is different because we are not directly attacking the configuration of the service, but we are attacking an underneath layer, which is the registry. This is because Windows actually uses the service config is just an upper layer. Underneath, there is the registry. So here, if we have a registry, of course, typically the registry requires more permissions. However, let's say that your system is misconfigured and you're able to write into this path, then you can totally ignore the service config, you can totally ignore the executable on top, and you can directly go towards the registry. You can directly change that. Specifically, you can change the image path, which is different from the bin path, because the bin path lives at the service configuration level, the image path lives at the registry level. And so this is the first idea. Now the second path is actually very similar, because in the second path we are talking about a DLL hijacking. Now, there is a specific registry key which contains a bunch of different DLLs, it contains a list of DLLs, and when this value is set, Windows will load into every user mode application that uses the GUI, and specifically those that use the subsystem for application, the Win32 API, it will load the DLL specified in this registry path. Now, this of course imposes a significant risk for security. This represents a significant risk for security, and this is why, as a result, because simply malware may attempt to use this key in order to inject malicious DLLs into system or processes. I mean, the idea is that if you're able to write here and this thing is enabled, it is used by the system, Windows will load the malicious DLL for you. So you don't even have to worry about how to load it into a single process, because Windows will do it for you by default, by design. And this is why this registry is often disabled. And actually, there is a specific attribute within the path that tells us if this thing is enabled or not. So here, let's make it clear. So here it's HK local machine. So we can abbreviate it with HKLM, as I did previously. Here, technically, the registry path ends in Windows, so we don't have these app init DLLs. Why? Because this app init DLLs actually represents the name of the attribute that contains the list of DLLs. So to make it a little bit better, so this is the actual path. And then here we have two attributes of interest. The first one is load app init _DLLs, and the second one is app init DLLs. So the first one tells us if the second one is enabled. The second one contains the actual list of DLLs, so it is the one that represents the security risk. However, it is disabled by default because modern versions of Windows have additional protection to restrict or limit the usage of this particular registry attribute. So what's the idea here? Let's try to understand, for example, if in our system this thing is enabled or not. We can do so with the getItem property. We put the key and the name has to be load app init _DLLs. So we copy this and it says 0, it means that it is not enabled. So pretty simple. So that's the idea. We can enable it by writing it 1, we can disable it by writing it 0. By default, most often you will find it disabled because it represents a significant security risk, which unless you really need it, just don't use it. It's much better. Now though, let's say that you want to use it. How do you do that? Well, you can once again use the getItem property and the setItem property command. So if you want to read the value of the app init DLLs, we can simply do getItem property with the path of the registry. And so let's copy it better. And so here we have, essentially it is an empty list, so there's no content here. However, let's say that we want to set it to something. So the value, how do we specify the value? So notice here what we do. Essentially, I'm going to copy here for better clarity. But the idea is that we have a string. So just let's put text mode. So we have a string, and then we have each path to each DLL, and the different DLLs are separated by semicolon. So we have an entire string. We have the path to the first DLL, a semicolon, the path to the second DLL, a semicolon, and so on and so forth. This is similar to how we specify path in the Linux system, so that's essentially the idea. Of course, we have different separators, but the idea is that we have a bunch of different paths separated by a specific symbol, which in this case is the semicolon. So not much to say here apart from the fact that this of course allows you to do DLL hijacking, which I've talked about this kind of attack in a previous video. So go and watch that video of DLL hijacking. I will put a link into the description. So essentially the idea is that through registry, sort of like we can do attacks that we previously discussed, And this as far as the first two paths are concerned. The first one with services, the second one with DLLs. Now let's go to the third one instead. This one is in Windows current version run. So these keys determine which applications start automatically. So specifically we have the current version run of the HKLM or of the HKCU. Now the difference is that if you are configured with the run in the HKLM, this will affect all users of the system because this hive is for the local machine. So modification to this hive will reflect on all users, while the CU hive is for the current user, so only the user that you are actually logged on as. So the first one affects all users on the system. Programs that are listed there will run at startup for every user who logs in. It requires, of course, administrator privileges to modify, because once again it represents a security risk. Now this sort of keys can also be used for red teaming operation. Let's say that you compromise a machine, but you want to extract credentials, you want to extract tokens, you want to extract information from the people who actually use that software. Then you can think of using this kind of keys to achieve persistent over time in your system. So every time the system boots up, you can execute malicious code by modifying this registry key. And of course, you want to modify the HKLM because you want to affect all users of the system. And so these were the run entries for the HKLM and HKCU. We also have the run once path here. Instead of run, it's just run once. And the idea is that they are executed exactly once and then they are removed from the registry. So it means that they actually will not be executed again because their configuration will be removed from the registry. So that's the idea. Now let's test it out. So we have here our file, our hello.exe that creates the test.txt file. So let's try to execute this upon a login. So how do we do that? Well, first of all, let's get the item property hkrun like this. So let's get this item property. Let's get this item property. And what do we have here? We have, for example, this test program that I added this key to do some testing myself. And then we have a bunch of different others. So for example, we have this security health, which executes the security health systray executable. Now let's modify the path of this test program to essentially point to our hello.exe and not test.exe. So we can do this essentially test program, and then at the end, I'm just gonna put hello.exe. So I'm gonna do this set property. So I'm gonna do this, and then I'm gonna copy this into the system. Now I get item property, and notice, now the test program is set to hello.exe. So now I have no txt file. Let's do a logout and a login. So I'm gonna sign out, and then I'm gonna sign in again. And the idea is that when I will sign in back, so here, I'm gonna put my simple password. When I log in back, I will actually execute that program, which will create the test.txt file within the downloads folder, as we will see. Here it takes some time to start up. I mean, this is Windows, we have to understand it somehow. So let's wait, let's go into the downloads folder of quickemu, and essentially let's wait a bit. So let's wait a bit, and notice what happened. While we were waiting, actually, we saw the program execute, and we saw that this file was created. Now, of course, a malicious actor would not simply just pop a file like that, just spawn a file randomly like that. They would execute malicious code that the user cannot see. But that's the idea. So that's the entry point. That's like the persistent method for executing code. Maybe it is not as much useful for privilege escalation because it assumes you already have administrator privileges. However, I still wanted to mention it because it's a very critical registry path, which is useful to know regardless of privilege escalation or not. And so this is for the current version run. If you set the run once, you're going to execute it once, and then at the next boot, you will not execute it again because it was removed from the registry. Now, for the last registry key that I want to talk about is going to be the current conversion win logon. So the winLogon registry key is used to configure how Windows interacts with the logon process. Specifically, it's gonna define the program to execute upon a login. For example, if we just put the name cmd.exe, if we just write to this registry the name in the attribute shell, so in the attribute shell we write cmd.exe, like first of all, let's try to read the item property of winLogon in general, regardless of the item shell. So we have winLogon, of course we have a lot of different stuff here. For example, we have a default domain, default username and stuff like that, auto restart shell, background and stuff like that. And then we have a shell, which in this case is explorer.exe, and also we have userinit, which is userinit.exe. Now, and also we have this sci-host.exe. I would say that if you find executable path within the registry, they could be critical, because maybe if you modify them, then you can get code execution. Now, in this case, if we modify this shell, the value of this shell attribute within this path, within the winLogon path, we're gonna change the first program that is executed by the system. So how do we do that? Well, for example, we can do a set item with the value cmd.exe. So let's do cmd.exe. And then at this point, we just need to log out once again. So we just to sign out. And the first thing, once again, is to sign in again. So we sign in. And now, and notice at this point, when we log in, we do not get the same explorer.exe that we usually get with the graphical interface. We just spawn a cmd.exe. Now, why is this the case? Because we changed the winLogon registry key. Now, how do we get it back? Well, we can start a PowerShell like this. Then we can increase the privileges with this, with this run as. We're gonna say yes. So this is gonna spawn a PowerShell as a privileged user, essentially. Then let's get the getItem property path. Here, notice that it says cmd.exe. We want to change this shell, and we want to change it to explorer.exe. And then we're gonna do logout. And to actually log out, the command is log off. So we do log off. We're gonna log back in with the user quickemu. And now we're gonna have our explorer back, essentially. Now, what's the idea here? Once again, a malicious actor will definitely not change the way the system looks. So it's not like it's gonna remove the explorer.exe to just give a shell, because that would be obvious to detect. What a malicious actor is gonna do is gonna introduce malicious code in the code chain, in the program chain. So maybe you still get your explorer back. However, he used that registry key to change the program that is executed in order to introduce a step that is malicious. So essentially, this is the idea. Once again, is this linked to privilege escalation? I would say not necessarily, because to change these keys, you already require pretty high privileges. So either the system is misconfigured and somehow you are able to access these keys, or if it's not misconfigured, what this registry key are actually used for is more for persistent than for privilege escalation. I mean, I'm putting in the privilege escalation series because we are reaching the end, but consider this more for persistent methods to like keep executing code on a victim machine that you previously infected. Now, here are some references with respect to registry hives. This is a vlog from Google Project Zero. It goes very in depth, and this is also another interesting blog post that goes in depth into the mysteries of the registry. So of course the registry here, I said it is a pretty simple data structure and stuff like that. But actually, of course, in reality, there are a lot of nuisance. There's a lot of complexity that we are not showing here. In here, I just discussed 4 critical registry paths. Of course, there are many more. How do you search for this? You can just document into the documentation. You can just read how it works. And the idea is that once you understand that a potential thing can be used also for malicious reasons, then you know also how to defend better. So once again, not always for privilege escalation, also for persistent. So this is it for this video. I hope it was interesting, and see you to the next video. Hi everyone, and welcome to this new video in which I continue my Windows privilege escalation series. In this video, we will talk about tools. Specifically, I will list out all the tools that I think are useful in the context of Windows. This is not a 100% complete list, but it's like a 70%, 80% complete list with all the things that you will most often use within Windows. Of course, here the context is a privilege escalation. So during our red teaming, penetration testing, during a certification, these tools can be very useful to obtain more privileges, to enumerate the system, and so on and so forth. Now, most of these tools we already use in the series throughout the various episodes. Some of them I will use them in the Active Directory series, such as CrackMapExec, which we not cover in this series, but we will cover in the Active Directory one. So as always, I hope the video is interesting, I hope you find it useful. If you do, subscribe to the channel, share this video with like-minded people, and enjoy the video. Before starting the list of tools, however, I want to take some time to describe why do we use tools. Now, in my point of view, tools are an integral part of computer science and therefore of cybersecurity. Now, why do we use tools? We use tools because we want to automate tasks that would otherwise take time and effort. And these are precious resources which we should use very carefully. Now, in my opinion, a tool is useful if and only if the following requirements are respected. First of all, it precisely defines the context in which it works properly. That is, the tool should come with its own documentation that describes, look, I work in Windows, I work in Linux, I work in macOS, I can work under these kind of constraints, environmental constraints. So that's the idea. That's the first requirement. If you find a tool that does not really describe the context in which it operates, then it's not a really good tool and maybe you should not use it in critical situations. The second thing is that it is simple to use, but this simplicity has to be taken into context with respect to what the tool offers. So it is simple to use relative to the functions it offers. For example, Emacs is a complex tool because it offers complex functions, so it cannot really be super simple. However, in my viewpoint, it's well designed, so it's simple enough. Third point, it can be easily integrated into automation workflows. Now, the cool thing about a tool is that you can add the tool to your automation workflows. For example, it can allow you to save data in different formats like XML, JSON, TXT, and things of the sort. The fourth, it is clear and concise. This with respect to the output. The problem with most tools, and this also happens in the tools that perform enumeration of a system, is that they print out a lot of information. However, of that information, the really useful one is really not that much. This is a typical situation with respect to tooling in cybersecurity. They tend to spit out a lot of output, but how much of that is actually useful? It depends. In my opinion, a good tool must be clear and concise. Then it must be as minimal as possible. So this with respect to the design interface, so to the amount of functions it offers and to how they are accessed. So we want integration with different workflows, but we don't want to bloat the tool with so many functionalities. Most of them are not really that well supported. The idea is that understand exactly what the tool should do and develop it as such, essentially. And finally, it can be easily understood and modified. Now, this last point with respect to easily, it's really debatable. Once again, I can think of Emacs as an example. Is Emacs easy to understand and modify? At the start, not really. However, it gives you the documentation, it gives you the path essentially to understand it so that you can properly modify it. So I would say that it has to be well documented with respect to how it is used. Now, regardless, however, of how many tools you use, always try to understand what it is that the tool is doing underneath, what is the action that the tool is implementing, and understand how you yourself would implement such action in code. Now, when you're starting out in cybersecurity, this might seem really hard. Maybe you find a tool that exploits a CVE, you read it and you don't really understand it, and that's totally normal. However, as a direction to have in your career, it's really useful to understand that tools are useful, but never be satisfied with just using the tool that you don't know what it's doing. So if you use a tool and you don't really know what it is doing, ask yourself, what is it doing underneath? can I implement it? And if the answer is no, because maybe right now you do not have the right knowledge, which is totally fine, then if you're really interested in how it works, you might go and research how you would implement such tool. Maybe just a basic version. Like for example, in this channel, I've already made a bunch of videos, for example, for the implementation of the xdump utility, or for the implementation of a base 64 encoder and decoder. And in this context, the idea is to understand that when you implement such things, like when I implemented the xdump, when I implemented base64, I do not really need to fully implement as it is used in the Linux distributions. I do not need to implement all the different features. But the idea is that to get a working like prototype that implements the core functionality. And then the rest, you can just use the code that other people wrote. Because at the end of the day, tools are useful, but the best tool remains the mind, and you want to train your mind. You can use tools. Computer science is built up by using tools, essentially. We have to use tools. However, we have also to create new tools and to understand the tools that we are using. So this is a general introduction. It has nothing to do with Windows per se, but I really care about this topic because I like teaching computer science. I like to teach people how to solve problems on their own. And that's the whole idea of this channel, after all, to give you the tools so that you can solve your own problems. So let's get straight into the topics, however. So we're dealing with Windows. So here I prepare a bunch of tools that we use throughout the series and a bunch more that we will use with Active Directory. This list, however, is not 100% comprehensive because of time constraints, but it contains a lot of stuff. For privilege escalation, this is mostly enough. For Active Directory, we have other tools that we will see later on. So let's start with the tools that allows us to perform HTTP request, because the idea is that each tool can be sort of like categorized depending on what it allows us to do. So for example, these first two tools, the certutil and the invoke web request, they are used to implement the HTTP protocol. Now, why is it useful to implement the HTTP protocol? Because we can use such tools directly in the target system to transfer files, to transfer binaries. And for example, we can transfer the other tools as well. So that's the idea. So one works with cmd.exe and the other works with the PowerShell. So the first one is a really simple utility that was originally made to deal with TLS certificates, but as a side effect, it allows to download files. So we can use it with certutil, URL cache, split f, and then here we put the URL, and here we put the name of the file that we want to save. So here I have a Windows system. We can open a CMD shell, essentially, and we can go into the directory tools. So let's go downloads tools. Perfect. Here we have a bunch of other stuff that we will see later on in the video. So let's copy the command and let's execute it. So we copied, we executed, and we have our file. So here I do more nodes.txt and I get the please subscribe message because this is what was offered in my website /node.txt. The same thing can be done with PowerShell. It's just a different command. It's called invoke web request, which is much better the short version, IWR, with the URI option to specify the URL and the out file to specify the file that must be saved in the local file system. So once again, we copy this command. Now we are with PowerShell, so let's delete the node.txt to make sure it's executed. Let's execute the command, and we have once again the node.txt that contains the please subscribe message. So once again, we have downloaded it. Perfect. So first two tools is to download file. The third one instead, and the fourth one as well, and the fifth one as well, are tools used to invoke reverse shells. So as we discussed in the reverse shell episode, reverse shells are one of the most fundamental tools that penetration tester and malicious actors can use to interact maliciously with a remote system. So the idea is that these tools allows us to execute shells and create TCP channels on which to send the information that is obtained through the shell. So for example, Netcat is a really standard utility. Here we can directly download it on the target victim with the IWR targeting the GitHub user content, which offers a static version of Netcat for 64-bit applications architectures. So let's just download it. So here I have my netcat. At this point, I can just execute it. How? Well, first of all, in my system, so in my system here, I'm gonna create a listener with netcat for 321, and then here I'm gonna do netcat, I'm gonna execute. I put my IP address, so the IP address of the host. I put this, and here I have a connection. Of course, this connection by itself is just a TCP connection, so not that useful. However, the cool thing is that we can transform this thing into a reverse shell by putting -e and the name of a program, for example, cmd.exe. So notice in this case, I'm getting a connection back, but it is no longer just a TCP channel. Rather, it is a full-fledged shell where I can execute various commands. They will be essentially here what happens is that I give my input from the host, which is the attacker machine. This input travels to the target machine, it executes using the CMD process, and then the output is written back to my attacker machine. So the output and input travel through the TCP channel in order to travel the network, essentially. So this is a typical tool used in penetration testing activities for spawning reverse shells. And of course, in the context of reverse shells, we have different options. Netcat in general is a utility to manage TCP connection. Then we have a specific PowerShell script, which is the invoke PowerShell TCP. So we can download it as follows. And all these commands you will find in the content in the GitHub repository. So I'm gonna listen again, and then I'm gonna do the syntax to include the module. So look at this. This dot space dot slash, it is used to import all the modules of that particular script, and then I can call it with the invoke PowerShell command. So here I say invoke PowerShell, I say that it is a reverse shell, I put the IP address and I put the port, and once again, so I execute this, and once again I have a connection, this time with PowerShell. So that's the idea. Of course, you can also execute it with netcat just to -e PowerShell.exe instead of -e CMD.exe, doesn't change anything. And so this is another way to trigger reverse shells. A third way is by generating a malicious payload using MS-Venom. Now, MS-Venom comes from the Metasploit framework essentially, but it is a standalone binary. This is used directly on Linux. So, while these first four were used on Windows, this one is a typical tool that we use on our attacker machine, and the objective of this tool is to generate different sorts of payloads. Now, this tool is very rich, you should study its documentation, but essentially, if we have to describe it in a very high level, the idea is that we select the payload, we also select the architecture with a -a flag, then we put the information for the reverse shell, so the lhost and lport, which is the IP address and port of the attacker, that is the endpoint where the attacker is listening for the reverse shell connection. Then we put the output format, for example, executable, and here we put the output name. So, for example, in my machine, I can generate a payload as follows. So I open the shell here, I use MS-Venom. Here it says some wording, but we don't really care. We just wait a bit. And then we have our malicious payload. Now, if I transfer this malicious payload into the victim machine, then I'm gonna be able to essentially execute it. How can I transfer the machine? Well, here we can use Python in my attacker machine to act as a web server. So I can do python 3 -m http.server and then the port 1337. I have started a web server. Then here we can use the tools that we already know to create HTTP requests. So for example, certutil is a good tool. So in this case here the URL has to be http 129.168.122.1, 1337 is the port. And then here we put /malicious.exe, which is the name of the file, and then here malicious.exe. So here we have downloaded the file. Notice in the web server we get a request for it. Actually we get 2 requests, but whatever. And then if we just put a listener to this, so remember, how did we generate the reverse shell? With the port 7777. So we have 1, 2, 3, 4. We put a listener here. And then I put the malicious.exe. I just execute the malicious.exe. and I have once again a reverse shell. So this is a different way. For example, in this case, the information on the attacker endpoint are inserted within the binary itself, not outside like with the netcat, like with the invoke PowerShell script, essentially. Now they are inserted within the binary because we have generated maliciously by giving the input. So this is a different way of obtaining a reverse shell. And so these other 3 for reverse shells. Now to continue, we find the min GW32, which is the cross compiler. And so here the idea is that you can do Windows development also from Linux. Now, how do we do that? Well, you can simply like create a file. For example, let's create, not this file, but let's create an hello.c. So hello.c that simply prints hello world. And then we're gonna compile it with the cross compiler, which you can install it depending on your essentially distribution. So this is the thing for compiling. I go source, I'm compiling, so x64, x86 underscore 64, w64, etc, etc. So look at this, I have this hello.exe. I can start another web server here. So I can say port is important 1237, and then here I'm gonna download once again, this time the hello.exe. Hello.exe, hello.exe, and then I put hello.exe, and it's gonna print out hello world. So once again, here could be any arbitrary code you want. The cool thing about a cross compiler is that it allows you to write programs in Linux, but then they can execute in Windows. So first you can enumerate your target, you understand the exact exploit that you need to write, you write in your attacker box, and then you can send it and execute it to the victim machine. Now continuing, we have 2 other executables which are used to exploit the SeImpersonatePrivilege. Now this is a specific privilege and I made an entire video about that, but essentially with these 2 tools, they in different ways, they exploit the same privilege in order to increase the privileges, so in order to perform a privilege escalation. So in this video I will not go into the details on how to use them because I've already made an entire video on that, which is the video on the SeImpersonatePrivilege exploitation. So the idea is that both of these tools, they use the same privileges to obtain privilege escalation, and here you can see how to download them. For how to use them, go and watch the other video. So these are the other 2. Now at this point, we have 4 different enumeration tools, which is winPEAS, PowerUp, Privilege Check, and broot. So enumeration scripts, essentially, the idea of enumeration scripts is that they try to understand vulnerabilities within the system, such as misconfiguration or passwords that leaked through history files, through log files, how services are configured, if they are vulnerable to DLL hijacking, and things of the sort. Now here I put 4 of them. Now to be completely honest, I'm not an expert in enumeration script because I don't use them very often. I'd rather go through eye by eye, and then sometimes I use winPEAS when I don't find anything useful, essentially. So that's it, yeah. The problem with these tools, regardless of the one specifically, is that typically they end up producing a lot of output. So the problem is, if you don't know what you're looking for, it could be hard to read all that output. Still, knowing some enumeration tools is important for performing privilege escalation, so I wanted to put them here. So for example, with winPEAS, we can have a lot of different checks, and here I put all the GitHub repositories for all these different tools, and I thank all the authors that develop and share as open source these kind of tools. So for example, with winPEAS, we have system information, user, processes, services, application, network, cloud metadata, Windows credentials, browser, interesting files and registry, and events information. So if you want to use it, here is the output directly from the tool. Essentially, you can just to log all the output. And here I have the script to download it. So we can download it. So we can remove this thing now because we don't need it. We can go here, we can open a shell. We can go into tools, into download tools. Actually, let's open it as normal user, not administrator. We can download it, and so it takes some time. So after some time, the tool finished to download. So now we have the winPEAS x64. and here we can just execute it. So we do winPEAS, and it says it's gonna do all the various checks. Here we have the different legends with the different colors, essentially. And typically the things that checks are, as I said previously, general system information, users, processes, services, application. Here there are really a lot of information. I tend not to use these tools. I'm gonna be honest, as I said, I tend not to use these tools, especially for exams like the OSCP certification and other certification. I actually suggest to maybe you can still use these tools, but first, before doing anything, just get a feel for the system, just try to understand, just try to enumerate manually, for example, the services and things of the sort, and then you can you can use these tools on top to say, okay, maybe I did not find anything on my own, let's use one of these tools, let's see what it gives me. I will not use it as like an automation, like I get into the machine, I run the script, because the idea is that the most powerful thing is actually your intuition on the subject, on the problem. So first you gotta build intuition. In the process of building intuition, of course, these kind of tools have their place and moments, so you should use them as well, but just be careful to not automate everything without even thinking on what you're doing. So for example, in this run, it produced enough output that essentially it overwrote the scrolling history of the shell, so I cannot even go back at the start. But essentially, here it lists out all the services that I can start and stop. Here it is list out all the service information. For example, here I have file permission on this simple service, so therefore I can do DLL hijacking because I have permissions on the folder. I have permission on this other thing, vdservice.exe. I have, here I can start and stop these services. For example, in this case, it's autorun application. I have this hello.exe application, which I have access to, of course. And for example, at the end, we can see this enumerating securities packages credentials, which seems to give us the Net-NTLMv2 of the user quickemu. I did not check this, but right now I don't have too much time. So this could be useful as a way to obtain the hashes of your user. Although once again, then you need to check if it works and stuff like that. So that's the idea. This is very useful script. Anyways, I suggest this one because it's very useful. So that's the first one of the scripts. Then we have the power up. So once again, we have a post-exploitation script designed for privilege escalation in Windows environment to identify and exploit privileges escalation vulnerabilities. Once again, we can download it, we can import it into the PowerShell context, and we can once again perform all the checks. Now, in this case, I suggest to use the HTML report flag so that you have an HTML file with all the reports afterwards. So essentially, that's the idea. Here you can download it, you can execute it as always with the similar to the winPEAS. Then we also have the previous check. So the idea is the same. You download it, you execute with basic or extended checks, and then you have the broot script. Now, I don't use this too much, so I cannot tell you which one is the best. Typically, I use winPEAS because it's reliable in a way. So that's it, yeah, this is for the enumeration script. Then to finish off, we have Mimikatz, which is a must-use tool to dump NTLM hashes, to play with tickets. We're gonna use much more when it comes to Active Directory. Essentially, the idea is that this tool is extremely powerful in the context of Windows privilege escalation, post-exploitation for persistence, for pivoting and stuff like that. So extremely useful tool. So after Mimikatz, we find InPacket. Now this is a Python library. It is a collection of Python classes that allow you to work with Windows-related network protocols. We did not use InPacket in this series, however, we will use it later on in the Active Directories. A bunch of different attacks can be automated by InPacket scripts, so these are Python scripts that use the InPacket library. So that's the idea. And then we find Responder, which is another tool, it's also written in Python, and the idea here is that Responder acts as a rogue authentication server. So in the video where I talk about Windows hashes, I showed how to use Responder in order to obtain the Net-NTLM hash of a user. So let's say that you have a reverse shell from that user, you don't know the NTLM hash, you can use Responder to obtain it, because you trigger a connection from the shell to this rogue authentication server, and during an authentication, the hash is actually exchanged. So very, very powerful. Then we find Chisel, I don't know exactly how to pronounce that. However, This tool is extremely powerful. We will learn how to use it when in the context of Active Directory, we will talk about network pivoting. So the idea is that you start from an entry point in the network, but then you move inside the network, because typically Active Directory networks, they are not all exposed to the internet. They have specific servers which are exposed to the internet. These are the entry points, but then the most important AD infrastructure is actually behind, it's not exposed. So we must reach it through pivoting. So we have to create this internal path in the networks, and we can do that with Chisel. So it's a very powerful tool. Then of course we have the hashcat and join combination. These are two different tools that can be used for cracking hashes. So Net-NTLM, NTLM hashes, v1, v2, LM hashes. So all sorts of hashes essentially, you can use these tools to crack them. And finally, I just wanted to mention this, we did not use it in this series, but we will use it in the Active Directory one, crack map exec. This tool is extremely powerful for doing the Active Directory penetration test, red teaming, and sort of activities. So there are a bunch of different tools that I did not mention that we will see in the Active Directory series. This was just like, I would say, the most important tool you should at least know if you want to do Windows privilege escalation. There can be many others, of course, but these are the ones that we use. These are the ones that I use, for example, in my OSCP exam, so nothing more than that. Another tool that I used was Evil WinRM, which I will talk about that in the Active Directory series, but other than that, essentially, I mostly use these tools. So go and use these tools, but remember that tools are useful, but the best tool remains the mind. I hope this video was useful to have a quick recap on the tools that are useful on Windows. If you have any feedback, if you maybe want to tell me more about these enumeration tools, if you use them more than me, do so in the comments, please. I would appreciate any feedback. And so this is it for this video, and to the next video of the series. Hi everyone, and welcome to this new video in which I continue my Windows privilege escalation series. Now this video is going to be very interesting because we will introduce the concept of antivirus in the context of Windows, and we will talk specifically about a feature called AMSI, which is used to connect a program with the antivirus essentially, and we will show how we can bypass this feature. AMSI, for example, comes into play when we launch a PowerShell process. So consider here, I have this PowerShell shell here, and here I have the real-time protection activated. Now, if in this shell I execute malicious code that is recognized by the antivirus that is running, which in this case is the default Microsoft Defender, now the shell is not gonna allow me to execute such code. For example, to see this in action, we can simply write invoke Mimikatz. Without even having the command actually available, we can just write it, and notice that if we execute it, it's gonna say essentially, look, the script contains malicious content and has been blocked by your antivirus software. Now, when we see something like this, what is actually happening is that AMSI is the interface between the PowerShell process, which we are running, and the antivirus. So antivirus, which in this case is Microsoft Defender. So the idea is that AMSI is this interface, is this middleman. So when we write something, this thing is scanned by AMSI. So AMSI comes into play and it says, okay, we need to scan this content. To actually perform the scan, the antivirus is used. So for example, in this case is Microsoft Defender. Microsoft Defender recognizes that something is malicious and tells AMSI to tell PowerShell, look, you cannot execute this program, I'm gonna block it because it is malicious. So that's the idea of AMSI. In this video, we're gonna go into a little bit of depth into how it all works and how we can bypass it. Now, there are many different ways of bypassing AMSI, and they are patched by Microsoft, so they change every time, but the general strategies are kind of the same, essentially. So I'm gonna show two specific methods, and I'm gonna put a link to the references where I've taken them, so feel free to experiment on your own. So that's it. I hope this video is gonna be enjoyable. This is content that is not strictly needed for basic certification like the OSCP. You will not be required to bypass antivirus. However, I felt it was good to put it at the end of the course because it is a little bit more complex topic. It would deserve a lot more effort and time, of course, dedicated to it. I mean, it could deserve many other courses on the antivirus evasion EDR evasion, AMSI bypass, and things of the sort. Today we will introduce the main idea of the subject of all these concepts and all these areas of research, and we will show practical AMSI bypass, true practical AMSI bypass. So as always, I hope the video is interesting. If it is, leave some feedback, subscribe to the channel, share this video and this channel with like-minded people to help me grow, and enjoy the video. So let's get straight into the discussion by analyzing what is exactly an antivirus. So an antivirus is a software program designed to detect, prevent and remove malicious software, which is also known as malware. So the idea is that we have normal software and we have malicious software. And this is pretty intuitive. Malicious software has malicious intentions with respect to the user of the software. So when someone installs a malware, the malware acts against the user that is installing the software because it is malicious software. Now, this means that how do they recognize what is malicious and what is not malicious? Because this is the big idea. It's like, given a piece of software, let's say that this is a piece of code. How can we understand if it is good or if it is bad? How can we understand if it is malicious or if it is just normal? Maybe a little bit weird, a little bit unconventional, but ultimately not malicious. Now, to do this differentiation, different techniques can be used. And of course, these are like big areas of research that are being expanded every day, essentially. So the idea is that we start with a simple signature-based detection. So the idea is that you have so-called malware signatures. Now, what is exactly a signature can depend on how nuanced you want to be, essentially. But for example, a very simple signature is literally the hash of the executable. So you take the executable file, which is just a bunch of bytes, therefore just a bunch of data, and you compute an hash on it. For example, you could compute the SHA-1 of the executable, and you get a certain fingerprint. Now, if you find a program with the same SHA-1, then you can be sure that most likely it's going to be the same program and therefore it's going to be malicious. So this is one of the simplest way to do detection. Why? Because the problem with hash functions is that by construction they are very sensitive to the input. And this means specifically that if I take a malicious executable and then I literally change one byte in the file, just one, maybe a byte that has to do with some text, so ultimately I'm not really changing the function of the malware, I'm just literally changing one byte of the file, and I compute the same hash, I'm gonna get a totally different signature, a totally different digest. This means that signature-based detection can be easily bypassed if we compute simple signatures, essentially. And so this is the first thing. Of course, other kind of activities are, for example, strings that are found in the binary. So patterns of strings found in the binary, pattern of bytes found in the binary, they can also act as a signature, essentially. So anytime we have a database with signatures for malware, and then when we want to scan a program, we extract the fingerprints of this program that we want to analyze, and we compare it with the database of malicious fingerprints, and if we have a match, we consider it malware, or we consider it not malware if we don't have a match. So that's the idea. Now, how can we extract these signatures? To extract the signatures, there are a lot of techniques, but these techniques can be mainly done in three categories, which is static analysis, dynamic analysis, and machine learning analysis. So the static analysis, essentially, the idea is that you want to understand the malware as a static file. So the static bytes of the malware, which means that, for example, if it is an executable, from the executable, you can get a lot of information, like, for example, the DLL that is going to load, the main entry point of the function, the code of the executable, the data present there, a bunch of attribute data, if it is signed or not. Like, all this kind of stuff can be analyzed through static analysis. For example, if you use Ghidra as a reverse engineering tool, and the idea of using Ghidra, of course, is to produce the decompiled version of the binary, so where we can see the source code of the binary. So sometimes what researchers do, a lot of times what researchers do is, instead of executing the malware, which could be dangerous, they start by understanding its static structure. So the static code that is loaded at startup, when the program executes. Now, the problem with static analysis is that sometimes it's really hard to reverse engineering the malware because there are a lot of techniques to hide the actual program you want to execute. And for example, a class of tools that is used with malwares are called packers. So the idea of packers is that packers are just executable which contain other executable within themselves. So the idea is that when you first execute the executable, so when you first launch the program, you are actually launching the packer. The objective of the packer is to actually bootstrap the real program that you want to execute, which in this case would be the real malware. So when you're doing static analysis, maybe you are just analyzing the code of the packer, which obfuscates and encrypts sometimes the actual code that is gonna run when you execute the binary. This means that extracting information, meaningful and useful information from the malware using just static analysis can be very hard, challenging and time consuming. So what's the next idea? The next idea is to create a lab environment in which you can test out the actual execution of the malware. So, of course, this can be very dangerous because you are executing a malware, so you're executing malicious software. So if you're not careful, if you don't take extra care in protecting yourself through the usage of sandbox environment, so environment that do not leak out information so that the malware within cannot get data outside, this technique allows researchers to understand what the malware is doing. For example, what kind of APIs is the malware using? What kind of system call is the malware calling with respect to the kernel interaction? These kind of questions can be answered through dynamic analysis. And through dynamic analysis, we can also understand how the malware interacts with the file system and with outside servers, so through network protocols. So that's another area of analysis. So we have static analysis. When the malware is not executing, we just execute the bytes of the raw program. We have dynamic analysis, so we are executing the process. And then we have machine learning. Now, machine learning, the idea is to use statistical patterns to understand, it's sort of like a fingerprint that is a little bit more probabilistic than a simple hash function, than simple string pattern matching. So with machine learning, the analysis can be more nuanced, more complex. And so with machine learning, the analysis becomes more probabilistic. So the idea is to extract a sort of like statistical distribution of malware, like typically this malware, how we can characterize it with a statistical distribution, and then when you have a real program and you want to see if it is a malware or if it is not, you do some statistical test to extract, to sample out data, and then you confront the data you sample with the expected malicious distribution. If the data is too far away from the expected malicious distribution, then you can assume it's not malicious. But of course, I just summarized very rapidly. These are very complex area of research, which are all, of course, interesting. Now, in the system, we don't have just antivirus. We also have other technologies which are related, for example, network firewalls or web application firewalls. So the idea is that these tools are specialized for network packet data. So while an antivirus typically deals with files, with process, with things that happen dynamically on the processor, network firewalls are specialized with network packets. So they understand very much the data of a network packet, and web application firewalls even more with respect to the typical traffic that goes on in web application. So HTTP traffic, so TLS traffic, so WebSocket traffic, quick, like all the kind of protocols that are used in the web communication. Web application firewalls can analyze such protocol to understand if there are malicious payloads and things of the sort. Then, if we have a big business with a lot of workstations and servers spread throughout a region, and we want to analyze the security of each endpoint, we have different systems which are a little bit more sophisticated, such as intrusion detection and prevention systems, and endpoint detection and response. And these endpoints typically would be, for example, the laptops of your employees, or specific servers that are supposed to be interacted with outside people. So like sometimes these kind of endpoints are also in the client machines that are used by people, by the consumer of your service, like if you want to extract money from the bank and you go to a POS point. In that POS point, if software runs, maybe there's also an endpoint detection response, while IDPs tend to be more inside networks, so like protected internal network areas where there is a concept of there is an outside zone, there's an inside zone, and you want to make sure that no one is getting inside. So essentially that's the idea. Now, what about Windows? So this is very, very general. What about Windows? Of course, in Windows, there are a lot of tools and systems and features that allow to protect the system. So we start with the Windows Defender Antivirus, which is the default antivirus present in Windows, which provides real-time protection against viruses, malware, and spyware. So I would say in general, malicious software. Then we have a firewall for network protection. We have the Windows Hello for encrypting passwords. We have the BitLocker for encrypting the disk after we turn off the PC, which is really important because let's say that we lose our work PC when like it gets stolen, but we did not encrypt the data, then anyone can simply take the hard drive and read all our unencrypted data. So if we want to avoid this situation, we're gonna encrypt them. We must actually encrypt the data. It's really important, especially when you deal with work laptops with data that is not only yours, but of the company you work for, of the clients of that company, and things of the sort. You want to encrypt everything so that even in the worst case where you lose your laptop and you lose access to the data, you can be assured that no one else is going to be able to decrypt it. Well, this is not really true because there are techniques that have to do with hardware hacking that can extract the BitLocker key, but they are more sophisticated, and it's like you really need to have a sophisticated attacker who knows how to do those sort of attacks. For the average attacker, you are well protected with simple BitLocker. And then we have Secure Boot, which instead is a technology that is executed during startup to make sure that the code that runs is actually the correct one, so it's the original one. Now, among all these different technologies, we find the focus on this video, which is going to be the Windows Anti-Malware Scan Interface, which is abbreviated as AMSI. So what's the idea here? Well, in 2015, Microsoft introduced this AMSI interface, which is an agnostic security interface that allows application and services to integrate with security products installed on a computer in order to provide security scans. So what's the big idea here? And here I have a little picture that I've took from a presentation that I'm going to link in the description. So this essentially is the image we want to look at. So this one. So actually, let me open with Chromium here. So that's the idea. So what's the idea here? The idea here is that we have a bunch of applications. Thanks to the Win32 API, there are specific functions that are offered by a DLL, which is called AMSI DLL. And these are, for example, AMSI scan buffer, AMSI scan string. So they are interfaces to perform security scans. Then there is an internal layer of Microsoft. And then this internal layer calls the actual provider. So the AV provider layer essentially is the engine that performs the actual antivirus scan. And so the idea is that AMSI is an interface that is agnostic to the specific security product. So you're not dealing with this security product or with this other. You're not dealing with X, you're not dealing with Y, you're not dealing with Z. You're dealing with an agnostic interface, which is the call AMSI scan buffer, AMSI scan string, but then on your machine, depending on the various providers that you have, you could scan the same buffer or the same string with, for example, 3 different providers to have 3 different results, and then you can compare them and things of the sort. So that's the idea. For example, in this case, this is the Windows Defender service, so the executable of the Windows Defender antivirus, and the idea is that the AMSI layer then interacts through remote procedure called through RPC layer with the actual provider, so with the actual process, with the actual code that has all the antivirus scan logic implemented. So that's the idea. It's just an agnostic way to do security scans. And of course, since it's agnostic, it can be really useful. So that's the idea. Now, what's the data flow of AMSI? So application or services request a scan. The request is then sent to the AMSI provider, which is a security solution installed on the system. If you have no security solution, it's gonna be Windows Defender, the default one. The AMSI provider performs the actual scan using its own malware detection algorithm, and this can be the default one, can be for a specific product and things of the sort. And then the results of the scans are returned to the requested application or service in order to allow or block the requested command. And the idea is that AMSI can analyze the following components. PowerShell, so in the PowerShell process we have this interface, Windows script, JavaScript and Visual Basic Script, Office macros, Excel macros, .NET programs, and using the Windows Management Instrumentation WMI. So that's the idea. So for example, to list out all existing AMSI DLLs, we just do task list /m AMSI with a wildcard. I'm gonna copy it better. And notice what do I get here? I get that here I have the AMSI in both the task list.exe and also the PowerShell.exe. So it means that in the current PowerShell process, I have an AMSI DLL loaded in, and this is gonna be used when I want to execute various commands. It's gonna scan essentially. It's gonna scan the command to see what's going on, if it's malicious or not. And for example, I just open a different PowerShell and notice I have a different PowerShell process and I have a different AMSI DLL. So that's the idea. And to list out all the AMSI providers in my machine, I can use the WMI interface with this command essentially. Just gonna copy it here, and notice here, in this case, it's gonna say Windows Defender, because I just have installed the default protection, which is Windows Defender. So these two simple commands. And these, I've also taken them from the reference, which is gonna be this talk, essentially AMSI and Bypass, review of known AMSI bypass techniques and introducing a new one. I'm gonna put a link into the description for those interested in more. Essentially, developers can use AMSI using the following interface. So we have initialization for the AMSI data structure within the process. And notice here we use this AMSI context. So we put a pointer to the AMSI context. We put the address of this structure. Then we open a session and then we scan a buffer. So for example, scan buffer per session, these are the AMSI API, this for initialization and this for the actual scan. Notice that the AMSI context is passed throughout all these functions. And so that's the idea regarding AMSI. We have a process such as a PowerShell process. Now, when we use this PowerShell, typically we send a bunch of commands to it, right? We have a bunch of input, and if we want to understand if the command is malicious or not, we call the AMSI interface to scan a string or a buffer of bytes. Then AMSI takes care of communicating with all the different security solutions, XYZ. Each one of them is going to use their proprietary algorithm and their stuff, and they're going to give the result back to AMSI, which is going to give it back to the PowerShell process. So it's a very intuitive thing to have if you think about it. Instead of having that each process has to comply with all the different interfaces of the different security vendors, since these are activities that are most often done in the same way, we provide a common interface. And this is the objective of AMSI, to provide this common and somewhat simple interface, as we can see here. Initialize, open, scan, we get the results. So why then AMSI bypass become interesting? Well, the idea is that if we break the chain at the AMSI level, the content is not even going to go to the antivirus. Therefore, we don't even need to bypass the antivirus itself. We simply don't tell the antivirus to scan that particular string. And of course, the antivirus still can perform on its own different types of scan, but it's just going to be different because it's going to have to activate on its own. It's not going to be PowerShell that automatically tells, look, can you scan this, can you scan that, can you scan that? So the idea is that by bypassing AMSI, we are avoiding to call too much the antivirus. So it's going to give us a little bit of breather time to do whatever we need to do. For example, practical example. So in this case, AMSI is activated. There is real-time protection. So in terms of local protection, everything is activated. And for example, let's say that I'm downloading, so this is the payload to download the reverse shell script, so the invoke PowerShell TCP, right? So I execute this, and what do I expect is that what's going to happen is this string is going to be passed to the AMSI scan, it's going to be passed to the Windows Defender, it's going to say, look, this is not good, and it's not, it's malicious, and therefore I'm going to block it. So in this case, that's exactly what happened. This script contains malicious content and has been blocked by your antivirus software. Because what happens here is that we, the user, provide this string as input to the PowerShell process. Now the PowerShell process within itself, has the AMSI DLL, which provides different interfaces for performing scan. The AMSI DLL then interacts with Microsoft Defender, and so this is the chain essentially. Now, how can we break this chain? Well, instead of creating a payload that is not recognized by Microsoft Defender, which is another way to do, and if you really want to defend yourself, you must also do that. In this case, we're taking it a little bit easier, because what we're doing is, okay, we start from PowerShell, but we're gonna try to break the interface that connects PowerShell to the AMSI. So we're gonna try to break this specific interface so that the interface is not even gonna communicate with Microsoft Defender. So we want to remove essentially this layer by breaking something at this layer so that PowerShell is going to ask, is this safe or not? But the AMSI is going to be broken essentially, and it's going to allow us to execute the commands, but it's not going to send our stuff to the antivirus, regardless if it's Microsoft Defender or any sort of proprietary antivirus you can think of. So that's the idea. So how do we do it in practice? Well, notice all these functions use the same structure, which is the AMSI context structure. And this structure, it is not documented by Microsoft itself. So the idea is that Microsoft documents the interface, documents that it takes, for example, a pointer to the AMSI context, but it does not document too well the structure itself. So what virus researchers have done and continue to do, essentially, is they understand how these interfaces form, and they try to break it during the process. So essentially, the idea is that in this process, right now, as of right now, the memory of this process has also this structure, the AMSI context structure. And we want to break it. We want to corrupt it in a way that does not make the PowerShell process crash. So we still have our shell, but we break the AMSI process. We break the AMSI function in a way, not the process itself because it's a PowerShell process, but we break the AMSI functionality. So here I show two bypass, and for each bypass here I have the references. So these two, all method to bypass AMSI, this is 2022, and one liner to bypass AMSI, to bypass the AMSI in a PowerShell. So here are some more payloads. Here I'm just going to explain these two. So the first bypass consists in modifying one field of the system.management.automation.AMSI-utils class. Now, this class is an internal .NET class within PowerShell that interacts with the AMSI, so with the anti-malware scan interface. And the field we're interested in specifically, it is the AMSI context field. So as I was saying, this field is passed around a lot of times. It is found in this class, in the AMSI-utils class, and we're gonna modify it. So the code is actually really simple. It's just these 5 different lines of code. Now let's first execute them to see the effect, and then we're gonna explain them. So we start by executing the first one. So actually let me just copy here, so it's gonna be faster. I don't have to switch all the time. So I'm gonna do it line by line so that you see. Of course, you can also automate this in a script clearly, but I'm just gonna do it line by line for now. So here I'm creating a variable fields. I'm creating the AMSI context. I'm creating a pointer to the context. I'm creating an empty buffer, and I'm gonna overwrite that context with the empty buffer. So this is it. You see how quick it was. Now let's try once again to download the invoke PowerShell TCP. And also notice that with this specific command, I am downloading it, but I'm loading it in memory. I'm not saving it on the disk. And this is actually critical because think about it. If you save it on the disk, the antivirus could be awakened by the event of saving things in a disk. So that could be dangerous. However, we are just executing in the current PowerShell context, so it is a little bit harder for the antivirus to recognize it. I mean, typically it would because of AMSI, but now we are trying to break AMSI, so it's not going to wake up thanks to AMSI. So now let's try to do it again. So let's copy this, Gonna copy it here. Notice now there's no like this is blocked because of malicious things. All is good. And now I'm gonna open a reverse shell for 321 to this port. And let's see if we get execution. And notice I have my shell here. I mean, id does not work clearly because this is on Linux, but I can say wmi, I can say wmi priv, I can do, I can go and create in the desktop, I can create echo test into test.txt, I can create a file, test.txt, so here I have it, and in the meantime, the antivirus still didn't wake up, essentially. So that's the idea. Why? Because we have broken AMSI. With these 5 lines of code, we have essentially disabled AMSI for the current PowerShell session. If I close the shell, of course here the connection is lost. If I close the shell, I open it again, the AMSI is going to be restored as new, and so essentially this thing is not going to work anymore. So I do this, and I am blocked once again by the thing. I do the bypass again, so this, I get the fields, and once again I do the bypass. So I'm going to get the fields, I'm going to get the AMSI context structure within the field, I'm going to get a pointer to it, I'm going to create this empty buffer, and I'm going to overwrite the pointer with the empty buffer. I've done it again, I'm going to just execute it again. Notice there is no more error, and I can just execute the shell once again. So you would have to do this, of course, for every PowerShell that you spawn before doing malicious stuff, because you have to bypass this thing. So the antivirus is still running. However, it's not activated because we have bypassed AMSI. Now let's say that we do bypass AMSI again. So we open a new shell, we bypass the AMSI process. Actually, with the second bypass, I think it's faster. Yes, it's actually much faster. So I'm just gonna do this second bypass, and we're gonna discuss this too, essentially. So let's try to make sure that the bypass actually worked. So notice I have my shell, and here I can just execute it essentially. So I can just execute it, gonna copy it, and notice here, I have my wmi, I have the commands, I can do stuff on the computer without triggering the antivirus. Now, let's say though that, here I'm gonna close the shell, so here I have back control on the PowerShell. Let's say that instead of loading it in memory, I'm actually saving it on the disk. So the command here would be IWR here, but then I would do outfile test.ps1. So I do this, and notice that the antivirus wakes up and it says, look, I found something malicious. So why does this happen? It happens because we have triggered an event in the system which is writing to a file, so the antivirus woke on its own. It was not called by AMSI, it was called by the you wrote to a file event, technically. I mean, you gotta see internally to understand exactly, but that's the general idea, is that we trigger an outside event. It was not triggered within the PowerShell process, it was the interaction between the PowerShell process and the file system. And the antivirus, of course, is made to analyze the files that you are saving because they could be a potential source of malware. So when the data hits the disk, it goes through the antivirus. If you want to make sure that even if you save the file, the antivirus does not recognize that the file is malicious, then you did much more techniques, more thoroughly. You need to essentially pack the malware, you need to obfuscate it, you need to encrypt it, you need to do a lot of techniques which we will not cover in this video. In this video, we will cover the AMSI bypass because it is a quick way to get through the antivirus without actually getting through the antivirus. And here the idea that maybe can help intuitively to understand what is going on is that with an AMSI bypass, we are not creating a payload that is not detected by the antivirus. Rather, we are just avoiding the antivirus altogether. So the payload can easily be recognized because we don't obfuscate this payload. However, we are just like being very, very stealthy with respect to let's not wake up the antivirus. And by doing that, to do that, we just bypass AMSI. So that's the idea, because AMSI is the mechanism that allows the antivirus to wake up. So that is the bypass itself. So let's explain it now, because as I said, it's actually not that hard. So let's open a new buffer here so we can explain in depth. So what's the idea? Well, the first thing, so the idea is that we're going to use the reflection mechanism of PowerShell. So the reflection feature of PowerShell. And with reflection, we mean when a process is able to inspect its own memory. because, a process is just memory, and the idea is that process typically handle their data, so a specific region in memory that deals with the program data. However, sometimes through reflection mechanism, through reflection support, a process can see its own functions, can see the code of its own function, and therefore it's sort of like you can think of it as it can modify itself in memory. So that's really a cool and powerful feature, and we will use this feature to patch the AMSI structure. So this is why the first code is this ref assembly get type. So we are getting essentially this particular class in the context. So it's called System Management Automation AMSI Utils, and of this class we're getting all the different fields, also those that are non-public. So in a way, through this reflection mechanism, we can avoid the typical mechanism of class-oriented abstractions, which would imply that a non-public method, a non-public field, for example, cannot be accessed outside the class. Well, in this case, through reflection, we're just gonna extract all the different fields. So if we just do the first thing, notice this, if we just do this, so let's see the payload here, we just have to take the ref until the end of the AMSI utils. Notice we get essentially the class AMSI utils. Then we get all the fields, right? And we put it into this class fields. So let's open a new shell actually. So let's open a new shell. So we get the fields. And then if I just print out the fields, here I get all the different fields like AMSI lock object, like AMSI init failed, like AMSI session, AMSI context, and all the metadata of the field essentially. So that's the idea. So the second thing the script does is out of all these fields, we are filtering the one that ends with context. So this is very, very important. So what's the idea here? The idea is that we are filtering essentially. So we are doing this. So we are filtering only the field that is called AMSI context. And here, to be more specific, we can say $_name like context, or we can even be like equal AMSI context, like this. It's the same. However, what's the catch here? The catch is that sometimes antivirus software does not allow certain words, certain strings. So for example, if it sees AMSI context, it could simply block the payload. It could trigger some alarm, so that would not allow you to actually perform the AMSI bypass. So this is why sometimes you want to be a little bit smarter and work with the string pattern mechanism. So for example, in this case, we want to say, okay, give me the field where the name ends with context and starts with whatever. So if you see all the different fields before, only the AMSI context has this property. So it's an indirect and implicit way of just extracting the AMSI context, which can bypass certain security protection. So very simple protection, but it's also very simple to bypass. So that's the idea. So we're getting this specific field. It's sort of like, you have a class in .NET, in C#, you have a class, and this class has different fields, and we're just extracting one of them, which is called AMSI context, which is the one that is not documented by Microsoft. At this point, we are getting the value of this field, and we are essentially casting this value to a pointer, an integer pointer. So this is, this value. So we do this. So let's do this other because I still haven't executed it. So AMSI context. So this is the field. And then if I just do AMSI context get value, I'm going to get the pointer value to it. So if I say AMSI context pointer, so let's say context pointer, I get this big number. And if I take, for example, GDB and I print this number into hexadecimal, I'm going to get this particular value, which is a memory address of the PowerShell process. So this value 0x1b6247 blah 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 is actually an address in the PowerShell process that is executing on the Windows operating system right now. And specifically, it is the address of this particular field of the AMSI util class. So that's the idea. Then here we are setting an empty buffer. So this is really simple, nothing to do with AMSI, it's just an empty regular buffer in 32. And finally, the actual bypass itself is we're going to copy this empty buffer into the AMSI context pointer. So that's the idea. And this kind of copy is also called as managed to unmanaged memory copy. Because the idea is that we control the empty buffer. This is managed memory. This is memory that we deal with, that our program can deal with. The AMSI context pointer instead is unmanaged memory, because technically this is memory of the operating system of the AMSI interface of the AMSI DLL. So technically, it should not be us who modifies that memory. We should just be consumer of that memory, and actually we should just use the AMSI service itself. So the idea is that we're going to overwrite that memory to break the AMSI interface. So that's the idea. We do the copy, and that's it. We have bypass AMSI, nothing is broken other than AMSI, so we're good. And now we can do whatever we want. So for example, we can do this. We can load the shell. We can also write invoke Mimikatz. Because the funny thing is that, okay, I don't have the command invoke Mimikatz because I still have to import the Mimikatz module. But antivirus are programmed to just detect the fingerprint invoke Mimikatz. So notice, in the left, I have a shell in which I have bypassed AMSI. In the right, I have a shell in which I still have to do the AMSI bypass. If I write invoke Mimikatz on the right, I'm gonna get, you've been blocked by the antivirus. If I do it on the left, it's just gonna say, look, I don't understand this command because I still have to load the module, but the antivirus will block it even before. So I would say a good test, if you can make alarm in your system, is just to use this string as a sort of signal to see if you actually bypass AMSI. And so this is the first bypass. As you can see, we're just manipulating simple memory of the process. Very, very simple, few lines of code, and we have our bypass. Of course, this bypass can be also very complex. The second one is also pretty easy though. I mean, at this point, you should have all the knowledge to actually understand it. And actually, I'm gonna leave you to it with this. So I'm not gonna explain, I'm gonna give you a little bit of time to actually see it. So we do this, first we do this, then we get the fields, then we do this, and then we do this. So how does this second bypass work? Well, sort of like similar, very similar. We still get the AMSI utils class, we still get the fields. It's just that at this time we use the AMSI init failed field. We don't use the context, we use the init failed, and we set it to true. So that's it, we set it to true. Sort of like we put the field to true, and also this is gonna work. As they say, it works on my machine. So gonna do two instructions. So this one, remember, the one on the right still have to bypass it. So we're gonna do it on the right. Gonna do it set true, and let's do invoke Mimikatz. And right now I have the same error on the left because I have bypassed the AMSI mechanism. So now it goes back to say, look, this command is not loaded. And then you would load the invoke Mimikatz, and then you would actually use Mimikatz. Or if you just want a reverse shell, we can just do a listener here. We can just get our shell on the right. So we're gonna load it in memory, and we're gonna execute it directly in memory. So that's the idea. But of course, we still, I mean, ID does not work because I always forget I'm in Windows actually. So I can say UMI. Perfect. So once again, remember, we did not actually bypass the antivirus itself. We bypassed the AMSI mechanism, which connects us to the antivirus. If I put this in the disk, so if I put this in the disk, so for example, in disk, okay, no, here I totally fucked up because I copied wrong. So here I should say output file test.ps1. Actually, I don't think output file like this. Out file, I think it's called out file, and boom, we have triggered the antivirus because after all, we still didn't bypass the antivirus itself. We just bypassed AMSI. So essentially, this is it for this video. We show two bypass to AMSI. I mean, in this video, we roughly introduced the idea of antivirus and of Windows technologies that deal with the protection of data, essentially. And specifically, we zoom in on the AMSI, which is the Windows Anti-Malware Scan interface, which is an agnostic interface that Windows implements and that connects processes like PowerShell to the various security solution installed in the target system. So the idea is that by bypassing AMSI, we are actually not even caring about bypassing the antivirus itself, we are simply not triggering the antivirus. Although this approach by itself has some limitation, because if we hit the disk, then we still have to bypass the antivirus itself, so we still need to take care into protecting and preparing our payload for hitting the disk on the target. But of course, that would be a whole other topic. I could make an entire series about that, about antivirus bypass. And essentially this is the idea. So here I leave all the references. There are a lot of methods to bypass AMSI. So especially this link is suggested because look, you just have a lot of different methods, for example. And here you have also like AMSI fail, which generates like a payload that can bypass AMSI, but this can also make the PowerShell crash. So they are not always super reliable. So essentially, that's the idea. Now, I hope the video was fun, was enjoyable. I hope you learned something new. I hope you learned about this AMSI interface and how to bypass, and after all, how easy it is to bypass. I mean, of course, Microsoft sometimes patches these things, so things could change, could get a little bit more complex. It also depends on the version that you're running, essentially. I mean, in this case, let's do a quick system info. Let's do a quick system info to understand the version, because I don't really remember. So essentially, here I have a Windows 10 with build 19045. So essentially, that's the idea. Now, I hope the video was fun, I hope it was enjoyable. If it was so, leave some feedback, subscribe to the channel, share this video with like-minded people, and to the next video. Hi everyone, and welcome to this new video in which I continue and finish, finally, the Windows Privilege Escalation series. Now, in this last video, I want to give you two different things, a cheat sheet and a methodology. So the first thing we will see in this video is a cheat sheet, and you can find the file in the GitHub repository. Here I have the org file, windowsprivesc.cheatsheet.org, and this cheat sheet contains all the commands that we cover in the series divided by the area of interest. For example, basic commands, file system, user privileges and permission, file transfers, reverse shell, the SeImpersonatePrivilege exploitation, on-cross compilation, DLL hijacking, UAC bypass, AMSI bypass. So the idea here is that I went through all the different videos and all the different files that I've written for the course. I extracted all the commands and I've put it and organized into this cheat sheet. So I hope it is useful. So that's the idea. It is divided into 17 different sections. Now, would I say that this covers 100% everything that you need on Windows? Clearly not. I'm not gonna make that statement because this is introductory Privesc. Of course, I've tried to explain things in depth, but this is just to introduce yourself to Windows Privilege Escalation. If you want to become an expert on it, then you need to study more, and maybe in the future I'm gonna make more content more in depth. For now, with this knowledge though, you should be fine for an OSCP-like level certification. If you're interested in OSCP, and you have this knowledge, then you are good to go, because typically machines require one of these techniques. But of course, if you want to become, for example, a security researcher in the context of Windows, this is clearly not enough. However, it is a good start and it lays a very solid foundation, which was my objective after all. So the first thing is a cheat sheet, and the second thing is a methodology. Because while the cheat sheet is useful because it contains all the commands, so that we don't have to go look them up online, ask some ChatGPT or something like that to get them, we just have them in the cheat sheet. With the methodology, it's a little bit different. It's a different file, and essentially it contains a bunch of strategies for how to approach Windows Privilege Escalation. So I will also share this. It will also be present in the GitHub repository, link in the description, and I will discuss how I will go through it. So I hope this last one is enjoyable and useful as the others. If it was, leave some feedback in the comment, subscribe to the channel, share this video and this series with like-minded people to help me grow here on YouTube, and enjoy the video. So let's get started with the cheat sheet first. So as I said, it was divided in 17 sections, and for each section I tried also to put references to the video where I show and discuss those commands, and also to the material that I developed that is currently present in the GitHub repository. So GitHub Leonardo in 95 YouTube-N, which stands for YouTube English essentially. So for example, in this case, the first section is the basic. This is like super basic system enumeration, like the operating system, the version, the architecture, who is the user, environmental variables, the path, where are executables, some help with the documentation, very, very simple commands. Then we move on to the file system. And for example, here we have the history, PowerShell history. We have, for example, the registry hives, because they are specific files in the file system. We have, for example, where the history file is saved, as I was saying. And also we have the commands to search file recursively. And this is actually extremely useful, as we will see in the methodology section, because one of the first things you want to do in a system is explore the file system. understand what kind of files are saved, with what kind of extensions, what kind of programs. And so like doing this kind of recursive searches is really, really useful. So that's the idea. The file system is an important aspect of privilege escalation. Then we find commands relative to the permission system in Windows. So to list out the groups I belong to, the user belongs to list out the current privileges, the accounts in the system, to list out the user detail, so net user, and then you put the username, to get the list of local users of local groups, to get the members from a local group, permissions on a file, and to enumerate the SIDs, which belong to the Windows permission system. So just a bunch of useful commands to move around permissions, essentially. Then we find the commands for file transfers. So these are using two main utilities, which is the cert util and the invoke web request. And I've discussed a lot about them. So here I put the link in the where I use them essentially. Then commands for reverse shells. So here I put with netcat, with the invoke PowerShell TCP PowerShell command, with msvenom, and also with the custom PowerShell that I showcase during the course, and also how to use it essentially. So these are useful things to have. Then with the SeImpersonatePrivilege, so how to exploit this specific privilege, we have the sprint puffer and the god potato. Of course, many different exploits work in this, but for example, for my experience, these one are good enough. If they don't work, maybe you can search further, but they should work. Then we have the SeBackup privilege. So this privilege allows us to perform a copy of the SEM and system file which contain the NTLM hashes of the users, so they can be used in the context of Windows to either crack the hashes to obtain the password or to perform pass the hash techniques, which we will see in the next series, which is going to be regarding Active Directory. Now at that point it's going to be fun, but for now, for privilege escalation itself, we just know how to copy SEM and system. Clearly, Active Directory and Windows privilege escalation, they are related with each other. That is, some of the things we did not discuss in this series, we will discuss in the Active Directory exploitation. And then if you want to have the full Windows experience, you can follow both courses to get the privilege escalation on a single machine and all the exploitation of network protocols of the Kerberos system and stuff like that in the privilege escalation. Because one of the techniques that you do in Active Directory is also known as pass the hash, where you do not have to crack the NTLM hash to actually use it. You can just pass it along. So that's the idea. Then continuing, we have the commands for performing cross compilations using the MinGW compiler. So here it's a very useful tool to program in Linux and execute in Windows. Now, I did not code too much using the Win32 APIs. However, that could be a good content for the future, just to bring more content on, okay, how do I use these APIs? How do I craft either malicious software, or how do I detect malicious software if it's running on my system? And of course, this has to do with what the Win32 APIs do essentially. So that's a really cool thing. In the series, we just introduced the idea. We show some example, for example, how to compile a service. So we show how to do that. And in the future, maybe I can cover more. So with respect to services, we talk a lot because they represent a very significant attack surface in the context of Windows PrivEsc and privilege escalation. So all the commands, for example, to get a service, to enumerate services, to stop, start, restart service. So all the control that has to do with a service with the tool sc.exe, very, very useful. Then we have change the configuration, the permission, extract the security descriptor, get the executable path for the process, create a new process, delete a service. So in this case, it's create a new service starting from an executable that was obtained through cross compilation. So this topic, of course, they interact with each other. Then, for example, we have list out the DLLs of a given service, this more in the context of DLL hijacking. And also in one of the latest video, I show how to modify the image path using the registry. So a different thing, but still related to services. Sometimes you attack a service not directly through the service configuration, but going through the registry. So that's the idea. And then how to enumerate services with winPEAS, so a little bit about enumeration. So services, really huge attack surface. Here I have all the content you can find. I'm not gonna put all these links in the description, but the idea is that you just get the link to the cheat sheet and you will find everything within it. So that's the idea. Then a really important part is processes and programs. So get the list of running processes and get the install application, 32-bit and 64-bit. We will talk why this is important in the methodology section. Then, of course, DLL hijacking, as I was saying. Here I put the search order. Here I put a little example of a malicious library that you can just introduce in the search order to hijack execution. In this first example, we know that the program uses the function add numbers. If we don't have this knowledge, if we don't know what are the functions that are used by the program, we can just introduce a DLL main, which is going to execute regardless if we are called or not. So anytime we are loaded by a program, this is the entry point of the DLL, which always executes. So it's a much stronger way to do this kind of technique. Then, of course, we talk about the registry. So we talk about different paths of the registry. So we talk about the always install elevated configuration, which allows to, of course, elevate privileges, the service image path, which I also mentioned in the service, the load up init DLLs and the up init DLLs, which allow to perform DLL hijacking, the run and the win logon registry path, which instead can be used for persistence. So once you have an initial code execution, by using those kind of method, you can always be assured that every time the system is like someone logs in, it's going to execute the payload. Then we have the UAC bypass. So here I put a little recap of the different UAC levels and how to bypass the different levels. So how to enumerate the current UAC configuration and how to bypass the different levels depending on the situation. Of course, for most of the levels, here I'm assuming that always install elevated is enabled. If this is not, you can use, for example, DLL hijacking as a different technique, but in general, this is like the harder part of UAC. If you have level 0 or level 5, there are way easier methods to bypass UAC. So that's the idea. Then I put a little bit about Windows hashes, so the different hashes, the different configuration, for example, the usage of responder to steal the Net-NTLM hash, so this can be useful, how to crack them, so how to download the raw keyword list, and how to crack the different types of hashes. Then the Windows Vault with the credential, with the Logon credential, to list out all store credential, to list out all the entries in the vault. Schedule task, how to enumerate them, how to create them essentially. So in this case, it's just enumeration. Then I have enumeration scripts. Here I put 4 different enumeration scripts, which is winPEAS, PowerUp, previous check, and beroot. So different projects, you can choose the one you prefer. And finally, two simple ways to do AMSI bypass. So essentially, this is it for the cheat sheet. It included all the commands that we saw in the series. If you think some more commands should be added, feel free to do a pull request in the GitHub repository. When I have time, I will check it out. So thank you very much for your contribution. So that's the idea for the cheat sheet. Now in the second part of this video, instead, I want to discuss a very basic but solid methodology that you can use to perform a prevesc in the context of Windows. Say, for example, you are doing on OSCP. Typically in OSCP, you have the Active Directory part, which is 3 Windows machines, and also 3 independent machines. And these 3 independent can either be Windows or Linux. For example, in my exam, it was 1 Linux and 2 Windows. So I had to do 2 Windows privilege escalation. So in this methodology, we will go through the thinking process behind it all. And before starting to discuss the methodology itself, I just want to say, it's gonna be a little bit abstract, because if it weren't, I would not be able to apply it to every context. So the idea is that I don't know the specific Windows machine that you will do. However, this is a general approach on how to think about it. So let's get started. Now, what's the first thing you should do? Well, the idea is that you are an outside machine, you are an attacker machine, you want to get inside a target machine. Now, in this simplified CTF exams context, the idea is that you can abstract away the outside world. So it's just you and the target, and there is a communication link between you and the target. Now, this is extremely simplified, but it's a good thing for us because it means that everything you need to exploit the target is within the target. Now, this thing, when you do bug bounty, when you do penetration tests, when you are in the real world, this thing is no longer true. However, for this kind of training activities, CTFs, like certification, this is true. So never forget about this. There is a solution and everything you need is within your target. You just need to see it, which is a crazy amount of information already that we have. So that's the idea. So how do we interact with the target? Well, the idea is that there are going to be services, and each service will expose a certain protocol with a certain, a bunch of messages that they send back and forth. So the first thing you want to do is scan for services. Try to really understand what are each service and if they are vulnerable, essentially, because to get an initial foothold into the machine, you will have to exploit one of those services. So the hardest part initially is to understand what is the foothold. So how do you find the service to exploit for the foothold? Now, in this case, this is actually not treated by the course itself, right? Because we're doing privilege escalation. We are assuming we already have some code in the system and we want to elevate our privileges. However, before getting there, in a real situation, even in a certification scenario, let's say, to get there, you need to exploit a service. Now, we will cover this more in the Active Directory series, but essentially, you have web services and non-web services. Now, why do I separate them? I separate them because web technology is very structured and specific. So anytime you find a service, ask yourself this first. Is it a web service or is it something else? If it is a web service, then you want to enumerate for files and directories, you want to enumerate for virtual host, you want to enumerate for DNS, maybe if there are special domain names and things of the sort. You want to enumerate the technology stack used by the web services and check for known CVEs. This often happens in entry-level certification. They want to test your ability to search for known vulnerabilities. So, for example, you do a web request, the server contains the server banner, the response of the server contains the server banner, and you search if there are vulnerabilities on that particular version of PHP, Tomcat.NET, Microsoft SQL, stuff like that. And then, if you don't find anything, you search for custom vulnerabilities. So, in simple certifications such as the OSCP, I always suggest first you enumerate, so try to understand really what is going on, which means understand all the files of the application, understand the technology it is written in. Is it a PHP application, or is it a Java based on Tomcat application, or is it, for example, a C#.NET based application? So you want to understand the technological stack before even understanding the vulnerabilities. So that's your first step. Then, once you know the technological stuff, the technological stack, you want to search for known CVs. So enumerate basic web servers, enumerate PHP version or Tomcat version, the version of the web server that is serving the application. Enumerate if there are specific frameworks. For example, if there is a Ruby on Rails framework, enumerate the version and try to search for known CVs. Anything that is publicly available, anything that is already vulnerable. Then, if you find it, it doesn't mean that it's the way. It could also be a rabbit hole, so this is really careful to understand. If you find a CV that matches your technological stack, it's not game over, it's just a start. It's like, okay, let's actually try to exploit it. So find vulnerabilities with easy proof of concept, with proof of concepts that are either already implemented or can be easily implemented. So maybe there is a request that is not authenticated, maybe there is an RC in a parameter of a particular endpoint. Find something that is easy to check. Do not go into too complex initially. Try to have a mentality where first you're doing easy things, and as the easy things don't work out, they get more complex and complex. So do not go immediately for the more complex and abstract and like obscure stuff and exploit. Start with the easy ones. If they don't work, then go for the more complex one. And if you don't find anything, then probably it means that you have to do some custom web exploitation. And of course, for this, you should watch the web exploitation series. In that series, we analyze single web vulnerabilities. We don't put them together in like a full penetration test on web application. However, we do analyze the most important one that you will find in the context of, for example, OSCP. So the single vulnerabilities like file upload vulnerabilities, like injection vulnerabilities, like cross-site scripting, like things of the sort. So that's the idea. Also in that series, we discuss about how to enumerate files, how to enumerate virtual host, how to do DNS zone transfer attacks, and things of the sort. So for web services, there are like specific paths to go. Understand the application, understand the technological stack, understand the virtual host, so enumerate everything you can enumerate, check for known vulnerabilities. If there are none, maybe you must find a custom vulnerability in the specific way that service is implemented. If you have a non-web service, essentially the idea still stands. However, in this case, you also have to understand the specific entry points of that service and how to interact with that service. So the main idea is that web services have a very common pattern of interaction. Typically, you go with a browser. That's it. Other non-web services could be a little bit harder. Maybe you require specific clients, SMB clients, LDAP clients, depending on the service. But the idea is that enumerate the entry points and check for common misconfiguration, such as, for example, oh look, I have an SMB share that is open to the public. In this case, this is a vulnerability because it allows non-authenticated user to access the data in that specific share. So do not go too complex. Initially, always check for common misconfiguration, then check for known CVEs, and finally check for custom vulnerabilities. But in this context, in the non-web context, it's even harder to find a certification, a entry-level certification, for example, that requires custom vulnerabilities on non-web services. This is mostly done for research. Like if you want to do security research, then of course you also look for custom vulnerabilities in the implementation of specific non-web services such as LDAP, SMB, and things of the sort. The Kerberos implementation, like there are a lot of things that could be vulnerable. But initially, and for certification context, just try to study well the service. And in the Active Directory series, in the future series, we will analyze a bunch of these services, the most common one, a bunch of misconfiguration, and how to exploit them. So for this, look more for in the future. So at this point, let's say that you find the way. So you find the service, you understand how it works, you understand how it is vulnerable, and through the vulnerability, you get code execution within the system. So at this point, you do have a foothold, you are able to execute code on the remote server. But the point is that you executed the code as a low or medium user, so with low or medium privilege level. And now you want to become administrator, you want to raise your privilege level, you want to perform privilege escalation. So assuming you have an interactive shell on the system, a way to execute commands on the system and to read the output essentially. So what should you do to obtain root privileges? Well, you start once again with enumeration. So enumeration is always the key because the path to root is gonna come out of the information you gather from the machine. This is why you gotta enumerate everything. And if you notice here, enumeration, the word enumerate happens a lot. You can see it a lot because it's extremely important actually. The specific techniques themselves are only a small portion of the work. Most of the work will go through enumeration in order to understand what is configured, how it is configured, and how it can be attacked. So the first thing you want to enumerate is users, groups, and privileges, because this is one of the most critical things. You want to ask yourself, what kind of privileges do I have? This is the thing you start with. For example, if you already have the SeImpersonatePrivilege, you can already attempt a privilege escalation with the Sprint Puffer, with the God Potato, with other exploits that abuse that privilege. And so maybe you become already root and it's actually easy. If you have the SeBackup privilege, you can try to get a copy of the SEM and system files. You can extract the NTLM hashes of all the users. Maybe you can crack some of them. So that could be another way. So start with what you can already do, and start also to understand the relationships that appear within the system. So what kind of users are in what kind of groups, because sometimes you don't become the user administrator, but you become another user which belongs to the administrator group. So sometimes you don't need to become the user administrator, just need to understand what are the users that have special privileges. So that's the first thing. Then you want to enumerate install applications. Why? Because typically, if you're looking, for example, for known vulnerabilities, they will appear, they will happen essentially on already installed application. And typically, maybe you have an old application that is vulnerable and someone years ago published a CV on that application and it has not been fixed. This happens a lot. So what you want to do is, okay, let's enumerate what is installed on my machine. And if there are things old or things that are vulnerable, then I can try to check if I can exploit the vulnerability. So another thing that is going to be useful is to enumerate for files in accessible directories. So once again, based on the user, based on the data that you can access with the user, you got the foothold, you want to enumerate the semi-system file if you can. You want to enumerate the PowerShell history files, the environment files, the environment variables, and also the configuration files for the application that are installed in the system. You want to enumerate for backups, for databases, maybe of password managers, things of the sort. And in this context, the cheat sheet, of course, is very useful because we have the search recursively command. For example, search all the files that have this extension, which is the KeePass extension, which is a password manager. So maybe you obtain the KeePass file, then you obtain the password from somewhere else, and then you have access to all the credentials of that user. So that's the idea. Enumerate files in accessible directories and start to gain a mental picture of, okay, what kind of users are we dealing with? What kind of application does he use? Does he or she use? What kind of data does he or she processes and stores? So that's the idea. Then of course you want to enumerate the store credential because it's extremely easy to do. I showed the commands previously and in the video on store credential and the credential vault. You want to enumerate for services. Once again, this is also linked to the install application because sometimes, most of the time, when we install one application, different services are actually installed and configured, and maybe they are misconfigured, so they could contain vulnerability. So once again, you want to check for known vulnerability, you want to check for services that have weakly been configured with weak service permission, you want to check for unquoted service path, for potential for DLL hijacking. I've already showed how to do all these techniques, so services are really, really key. You want to check for the always install elevated configuration, and to be honest, maybe you can just check it before even going through the services because it's a simple check to do, and if you have this option on, essentially, you are good to elevate your privileges, so it's an easy way to get to root. Now, if your user already belongs to a privilege group, however, you got a shell with a low integrity level, then to actually get access to all those high privileges, you need to do a UAC bypass. So once again, you can check the UAC level, you can try to bypass it with different ways depending on the level. So this is another thing to do. If you are already running as administrator, you still want to do something because you still want, for example, to run Mimikatz as an easy way to dump the LSAS process and get the NTLM hashes. So even if you are running as administrator, running Mimikatz can be extremely useful because you can obtain hashes for different users in different machines. And in the Active Directory series, we will of course do more of this because in Active Directory you have many machines. So once you obtain admin in one machine, you are not done. You want to pivot and obtain admin in the others until you obtain essentially the domain admin role, so the one who controls the Active Directory domain. For example, if you need to obtain the NTLM hash of your current user, what you can do is you can run responder to leak your Net-NTLM hash, and from that maybe you can try to crack your own hash. Then you can enumerate the scheduled task. You can try to enumerate if you can access the registry path that could allow you to, for example, do DLL hijacking or to deal with services as I showed in the video. But in general, I would say this the scheduled task enumeration is hard. It's not really easy to do because sometimes you do not see the task themselves, so it's really hard to enumerate. And for the critical registry path, sometimes you just don't have the permissions. So I will put this down in the list. Of course, if the antivirus is active, you want to bypass the AMSI. You want to make sure that you bypass also the tracing of the events, which is another system called ETW, that essentially traces events in Windows. You want to execute software that is properly defended against antiviruses. Now, for example, in OSCP, you don't have an antivirus on, so you can simply bypass this. If you do have an antivirus on, AMSI bypass is not enough. So here I'm just going to say it is not enough. It's just what we cover in the course, but it's not enough at all. You need much more like methods to protect the code you run, essentially. So the idea is start with enumerating users, group, and privileges, move into install application and then into files, enumerate low-hanging fruit, so things that can allow easily to obtain root. For example, I have a user that belongs to administrator, but I have a low integrity level. However, there's no UAC configured, so I can just bypass it easily. So that's a typical low-hanging fruit. Always check for non-vulnerabilities first. So you enumerate the application, you notice a weird name that is not Microsoft, that is not developed by Microsoft, check immediately the version, check the configuration file, try to find data passwords like that essentially, and check for weird files in general. And that's it with respect to the basic approach. So of course, as I said, this is not 100% comprehensive of every possible scenario. However, it is a very strong foundational knowledge that will always help you regardless of the machine you're dealing with. Because, of course, one thing that here I did not put is use enumeration scripts. But to be honest, after all, enumeration scripts check these things and some more. If the machine is not too hard, probably with these things you will be good to go. Of course, if the machine is hard, it's made to be hard to obtain privilege escalation, maybe you might want to use more enumeration scripts. For basic machine, this is already a lot, and you should have it. At least all of these things you should know how to do it. And so essentially we are done with this video and therefore with the series. I hope it was useful, and I hope you will find useful both the cheat sheet and the methodology. Please let me know if you think I missed something. It would be interesting maybe to integrate it later on, not in the series, but maybe in the GitHub repository or with future videos, maybe specific technique that I forgot to mention. And so this is it. I'm gonna leave you now. I hope the video was enjoyable. I hope the entire series was useful and enjoyable. If it was so, leave some feedback, subscribe to the channel, share this video with like-minded people to help me grow, and to the next series and to the next video.